Most SAP go-lives don't fail because of SAP. They fail because testing was wrong and cutover was rushed.
Part 3, Volume 1. Transition to live testing and cutover.
In Part 3 of this series, we move from the technical build into the high-stakes environment of system validation and go-live execution. Because the functional and operational risks of an S/4HANA migration are so massive, we have split Part 3 into 2 volumes to maintain the technical depth you expect. Here in Volume 1, we analyze the 39 incidents that form the go-live gate, specifically focusing on testing strategy failures and the technical risks of the cutover sequence.
Part 2 Recap, Surviving the Crucible.
In Part 2, we analyze the 59 technical failures of the realize and deploy phases. We saw how legacy ABAP debt crashes the HANA database, how CV synchronization blocks the conversion, and how technical locks during the SUM window can derail the downtime schedule. Now, we assume the system is technically up, but we must determine if it is functionally ready for the business.
What this Volume 1 covers.
This volume focuses strictly on validating the system and executing the final transition to the production floor, covering 2 major sections. Section 6, Testing Incidents, why standard UAT misses S/4HANA specific edge cases, performance limits, and integration breaks. Section 7, Cutover Risks, managing transport sequencing, data freeze mismatches, and downtime orchestration. In the upcoming Volume 2, we will cover the remaining 46 incidents, involving Day 1 operational failures across logistics and cross-module integration.
Mapping to SAP Activate.
These operational sections align with the critical path of the final project lifecycle. Section 6 aligns with the realize phase for system integration testing and user acceptance testing validation. Section 7 aligns with the deploy phase for the final production cutover weekend. This mapping ensures the project team transitions safely from technical fixes to business process readiness.
Section 6, Testing Incidents.
Section 6 focuses on the failure of the validation strategy. In an S/4HANA migration, traditional regression testing is insufficient. Because the underlying data model has changed, testing must focus on behavioral deltas. We will analyze why standard test scripts fail to catch pricing variances, how integration testing often ignores cross-system dependencies, and why non-functional testing for volume and performance is the most skipped step in a failed migration.
Section 6 Overview, the testing landscape.
To ensure a bulletproof system, we categorize Section 6 incidents into 4 distinct testing domains. Category 1, Functional Testing, focused on validating S/4HANA core logic, simplifications, and behavioral deltas. Category 2, Integration Testing, validating end-to-end process connectivity across SD, MM, FI, and external platforms. Category 3, Non-functional testing, stress testing the system for volume, HANA performance, and ABAP engine load limits. Category 4, User acceptance testing risks, managing the human element, representative test data, and month-end simulations. By mastering all 4 domains, you ensure that system up translates into business ready.
Category 1, Functional Testing Incident List.
The following incidents represent gaps in the functional validation of the S/4HANA core. 142. Regression scope gaps. Relevant SAP note, not applicable test strategy and execution. 143. Pricing scenario coverage incomplete. Relevant SAP note, not applicable test strategy and execution. Reference SAP note 2267308 for context. 144. Variant order to cash flows not tested. Relevant SAP note, not applicable test strategy and execution. 145. Edge case scenarios missing. Relevant SAP note, not applicable test strategy and execution. 146. Country localization scenarios missing. Relevant SAP note, not applicable test strategy and execution. 147. Revenue recognition test cases incomplete. Relevant SAP note, not applicable test strategy and execution. Reference SAP note 2267319 and SAP note 2225170 for context. 148. Advanced variant configuration scenario gaps. Relevant SAP note 2711932. 149. Flexible workflow approval scenarios missing. Relevant SAP note, not applicable process design gap.
Category 2, Integration testing incident list.
These incidents focus on the failure of end-to-end process connectivity. 150. SDFI sequence incorrect. Relevant SAP note not applicable integration testing design failure. 151. SDMM availability mismatch. Relevant SAP note 2321191. 152. SDEWM integration scenarios missing. Relevant SAP note 2806070. 153. SDTM integration flows missing. Relevant SAP note 2267317. 154. Tax engine scenarios incomplete. Relevant SAP note not applicable test strategy and execution. 155. E-commerce scenarios missing. Relevant SAP note not applicable test strategy and execution. 156. Revenue accounting and reporting integration not reconciled. Relevant SAP note 2267319 and SAP note 2225170. 157. Group reporting reconciliation not tested. Relevant SAP note 2349298 and SAP note 2461837.
Category 3. Non-functional testing incident list.
These incidents represent failures in system performance and load stress testing. 158. Volume testing missing. Relevant SAP note not applicable test strategy and execution. 159. Performance testing unrealistic. Relevant SAP note not applicable performance testing strategy failure. Reference SAP note 1912445 for context. 160. Parallel processing not tested. Relevant SAP note not applicable test strategy and execution. 161. Advanced ATP load scenarios missing. Relevant SAP note 2321191. 162. Mass billing not tested. Relevant SAP note not applicable test strategy and execution. 163. Pricing scale performance not stress tested. Relevant SAP note 2267308. 164. BRF plus output runtime not tested. Relevant SAP note 2228611.
Category 4. UAT risks incident list.
The final group of testing incidents addresses the risk of failed user acceptance. 165. Test data not representative. Relevant SAP note not applicable test strategy and execution. 166. Business variance not covered. Relevant SAP note not applicable test strategy and execution. 167. Cutover scenarios not tested. Relevant SAP note not applicable test strategy and execution. 168. Reconciliation approach missing. Relevant SAP note not applicable test strategy and execution. 169. Month-end acceleration not simulated. Relevant SAP note not applicable test strategy and execution. Proper testing governance prevents the system from failing when real business volume hits.
Scenario 142. Regression scope gaps.
In the realize phase of an ECC to S4 HANA migration, the testing team often limits the regression scope to only those processes mentioned in the simplification list. Because a brownfield conversion is a system-wide replatforming, even standard transactions that were not explicitly modified can break due to underlying table changes and compatibility view performance. If the regression test plan ignores legacy SAP GUI paths and focuses only on new Fiori apps, the organization will discover hundreds of broken business rules and data inconsistencies only after the production go live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium project quality and risk management impact. 2. Phase, realize. 3. Frequency, very common in projects with compressed timelines. 4. Primary ownership, test lead and QA manager. 5. Supporting SD functional lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note, not applicable test strategy and execution. This is a governance and validation failure.
Diagnostic dashboard, symptoms and evidence.
How regression gaps manifest during the validation cycles. 1. Symptom. System integration testing finishes with a 100% pass rate, but the first day of user acceptance testing results in dozens of P1 defects in standard O2C flows. 2. Red flag, the test plan only covers the delta items from the readiness check and excludes high-volume legacy transactions like VA02 or VF02. 3. Business impact. Significant rework and project delays occur as developers are pulled away from cutover tasks to fix basic functional errors that should have been caught in SIT. 4. Detection. Comparing the transaction usage from transaction SD03N in ECC against the test script library reveals a coverage gap of 50% or more. 5. Technical proof. Runtime dumps in production for legacy custom routines that were never triggered because the test data was too clean or limited in scope. Insight. In a brownfield conversion, everything is a potential delta. There is no such thing as an unaffected legacy process.
Why this happens, scenario analysis and root cause.
1. Project managers prioritize speed and attempt to optimize the testing window by cutting out standard legacy scenarios that worked for years in ECC. 2. The testing team lacks the historical ECC knowledge to know which obscure business variants or Z transaction codes represent high financial risk. 3. Failure to use automated testing tools leads to a manual testing scope that is physically impossible to complete within the migration sprint. 4. A false assumption that the compatibility view layer perfectly mimics legacy table behavior for all custom reporting and pricing logic. The failure is a result of a testing strategy that treats S/4HANA as a minor patch rather than a new architectural reality.
Why this is a migration, exclusive failure.
1. Standard ECC upgrades involved very little data model change, making a delta-only testing strategy safe for most companies. 2. S/4HANA migration involves a total data transformation and a new database kernel which impacts every SQL statement and index in the system. 3. The complexity of the CVI synchronization and the PRCD_elements pricing shift is a unique migration feature that requires full regression to validate performance. 4. This failure only surfaces when the system transition reveals that standard code now behaves differently under real-world production load. Migration forces a level of regression testing that standard upgrades never required.
Financial and customer impact.
1. Undetected pricing errors in legacy. Z reports lead to significant revenue leakage on the first day of invoicing. 2. Customer trust is damaged when standard order confirmation forms contain incorrect data due to untested logic splits between Fiori and GUI. 3. Audit risk increases if mandatory internal controls coded in legacy user exits like MV45FZZ are bypassed because they were not part of the test scope. 4. Massive cost overruns occur as the organization is forced to extend the project hypercare phase to fix day one functional gaps. Testing gaps in SD directly translate to unbillable sales and financial reporting errors.
Governance and accountability, RACI model.
Ensuring testing quality requires a strict separation of execution and verification. 1. Accountable test lead and QA manager, the person who owns this and gets fired if it fails. 2. Responsible SD functional lead identifies the minimum viable regression list based on the ECC document volume statistics. 3. Consulted business process owners validate that the test scripts accurately reflect current operational reality and dirty data variants. 4. Informed project manager monitors the testing burndown chart and manages the risk of timeline slippage. Accountability ensures that the project does not move to go live based on an incomplete validation.
Ownership, who actually fixes it.
Resolving this requires a risk-based and data-driven regression strategy. 1. The test lead utilizes SAP Business Process Change Analyzer, or BPCA, to identify exactly which transactions are impacted by the migration. 2. The SD functional lead maps the top 80% of the company revenue-generating O2C variants to specific test scripts. 3. The QA team executes a smoke test covering 100% of the business-critical transactions before starting formal UAT. 4. The technical architect performs a volume-aware test on high-frequency transactions to ensure no performance regressions exist due to compatibility views.
Who gets blamed versus who owns it.
1. Blamed. SD functional lead, the business assumes the sales process was configured incorrectly or settings were lost. 2. Blamed ABAP development team, users assume the code was broken during the remediation of syntax errors. 3. Actual owner, test lead, and Q, a manager responsible for the failure to define a comprehensive and data-driven testing scope. 4. Root cause, using an ECC patch mindset for a fundamental S/4HANA digital transformation. Blame targets the configuration. The failure is in the quality assurance governance.
How this is actually fixed, the right way by a role.
1. The test lead mandates the use of automated testing for the standard O2C baseline, allowing human testers to focus on delta scenarios. 2. The project team implements a testing gate between SIT and UAT, where a coverage audit is performed against ECC document statistics from transaction SD03N. 3. Developers refactor test data to include edge cases like partial returns or split deliveries that were identified as high risk during Explore. 4. Functional leads execute a full document flow test, starting from an inquiry and ending at a cleared payment, for every major regional variant.
What not to do, common wrong fixes.
1. Do not rely on ABAP unit testing as a substitute for functional regression testing. 2. Do not allow the business to self-select the test scenarios based on memory. Use raw ECC data to drive the scope. 3. Do not skip testing for read-only Z reports, as these are the most likely to fail due to the new pricing and status data models. 4. Do not accept a green status from the testing team unless they can prove they tested the legacy GUI transactions for parity. Ignoring the legacy regression scope is the fastest way to trigger a system-wide rollback.
Follow-up 1. How do I define a safe regression scope for S4HANA without testing everything?
Answer: you must use data-driven scoping. Extract a list of every transaction code and program used in ECC production for the last 12 months. Any transaction with more than 500 executions must be in your regression scope. This approach ensures that high-volume business is protected while keeping the test window manageable.
Follow-up 2. Why do standard test scripts fail to catch behavioral deltas in S4HANA?
Answer: standard scripts often check, can I save an order? Behavioral deltas are more subtle, such as, does the system calculate tax the same way? Or does the ATP check consider the same supply sources? Your scripts must be updated to validate the final result against an ECC baseline, not just the technical success of the save.
Follow-up 3. Curveball. Can we use automated testing to skip the regression phase entirely?
Answer: no. Automation is an accelerator, not a strategy. Automation only tests what you tell it to test. If your automation suite is based on ECC logic, it will pass unremediated S/4HANA errors. You must first perform a manual architectural validation of your test scripts to ensure they are even valid for the S/4HANA data model before you automate them.
Exclusive pro tip.
Integrate SAP usage procedure logging with your test management tool. If a program is used in ECC but has 0 test cases in S/4HANA, flag it as a high-risk gap immediately. Let the actual usage history of your users dictate the quality of your testing.
Scenario 143. Pricing scenario coverage incomplete.
In the realize phase of an ECC to S/4HANA migration, the test plan often overlooks complex pricing scenarios like tiered scales, multi-level condition exclusions, and custom tax routines. Because S/4HANA moves to the PRCD_elements model, the underlying numeric precision and calculation sequence can behave differently than the ECC cluster model. If testing is limited to standard unit prices and ignores these complex variables, the business will suffer from massive financial variances and rounding errors once they begin high-volume billing.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial accuracy and audit risk. 2. Phase, realize. 3. Frequency, common in global manufacturing and retail companies. 4. Primary ownership, SD functional lead. 5. Supporting sales controller and ABAP lead HANA. 6. Business ownership, sales controller. 7. Relevant SAP note, not applicable test strategy and execution. Reference SAP note 22673008 For pricing data model context.
Diagnostic dashboard, symptoms and evidence.
How pricing testing gaps manifest during validation. 1. Symptom, total invoice values in S/4HANA differ from ECC for the exact same order by a few cents or even dollars. 2. Red flag test scripts only use whole numbers for prices and quantities, failing to test the new 15-decimal numeric precision of HANA. 3. Business impact. Customer disputes and payment delays occur as invoices do not match the agreed contract pricing due to rounding shifts. 4. Detection. Financial reconciliation reports between ECC and the S/4HANA sandbox show net value variances for complex O2C variants. 5. Technical proof. Debugging custom pricing routines shows that legacy round commands are producing different results on the HANA database kernel. Insight. Pricing in S/4HANA is mathematically stricter. If your test data is too simple, you are hiding future financial errors.
Why this happens, scenario analysis and root cause.
1. Functional leads assume that because they did not change the pricing procedure configuration, the result will be identical to ECC. 2. The testing team fails to create a comparison baseline using thousands of historical documents to verify the calculation engine. 3. S/4HANA enforces a 15-decimal internal precision for pricing, which can cause penny drift when compared to the 2-decimal cluster storage of ECC. 4. Legacy custom pricing routines often use dirty reads of global memory that are now bypassed by the new S/4HANA pricing APIs. The failure is a result of underestimating the impact of database physics on financial calculations.
Why this is a migration, exclusive failure.
1. ECC upgrades never change the fundamental pricing engine or the storage format of conditions in table KONV. 2. S/4HANA migration physically uncompresses the pricing data and moves it into transparent tables, exposing it to new database layer math rules. 3. The transition to PRCD_elements is a one-time event that requires a 100% validation of the gross-to-net calculation flow. 4. This failure only surfaces when the system transition from the old cluster math to the new transparent math occurs during brownfield conversion. S/4HANA introduces a numeric evolution that no previous SAP upgrade ever required.
Financial and customer impact.
1. Inaccurate revenue recognition leads to material weaknesses in financial audits and potential regulatory penalties. 2. Overbilling or underbilling of customers results in expensive manual credit or debit memo processing and customer churn. 3. Rebate accruals are calculated incorrectly, leading to significant financial variances at the end of the commercial year. 4. Loss of commercial trust as customers perceive the S/4HANA migration as a source of hidden billing errors. Pricing testing gaps directly compromise the company's gross margin and customer loyalty.
Governance and accountability, RACI model.
Securing the pricing engine requires a partnership between SD and finance. 1. Accountable SD functional lead, the person who owns this and gets fired if it fails. 2. Responsible SD functional team provides the master test data containing every complex discount, scale, and tax scenario. 3. Consulted sales controller signs off on the acceptable variance threshold, which is typically 0 variance. 4. Informed revenue accountant monitors the impact of pricing shifts on the deferred revenue accounts. Accountability ensures that technical migration does not override the corporate pricing policy.
Ownership, who actually fixes it.
Resolving this requires a full-spectrum pricing validation and data audit. 1. SD functional lead extracts the condition record logic for the top 50 most complex pricing scenarios, including tiered scales. 2. The test team executes a mass parallel run, calculating prices for 5,000 historical orders in both ECC and S/4HANA to flag variances. 3. The ABAP lead refactors any custom VOFM routines identified as producing inconsistent results on the HANA kernel. 4. The sales controller performs a final net revenue validation across all sales organizations before the production cutover.
Who gets blamed versus who owns it.
1. Blamed, master data team. The business assumes the condition records or scales were loaded incorrectly. 2. Blamed, SAP users claim the new engine is mathematically incorrect or produces random numbers. 3. Actual owner, SD functional lead responsible for the failure to perform a deep dive comparison of the calculation logic. 4. Root cause, using simplified unit test data for a complex architectural pricing engine transformation. Pricing errors are logic and precision failures, not data entry mistakes.
How this is actually fixed, the right way by a role.
1. SD functional lead mandates a pricing stress test using real customer data and actual high-volume tiered discounts. 2. The team implements automated comparison scripts that highlight any change in the net value field between ECC and S/4HANA. 3. The ABAP lead utilizes SAP Note 2267308 to reactivate and technically validate the registration of all custom VOFM pricing routines. 4. The FICO lead executes a reconciliation baseline, ensuring that currency decimal configuration in transaction OY04 matches ECC exactly.
What not to do, common wrong fixes.
1. Do not accept cent-level variances as normal, as they will accumulate into massive financial imbalances at scale. 2. Do not use manual rounding adjustments in sales orders to fix a systemic calculation engine error. 3. Do not skip the testing of rebate and settlement pricing, assuming it follows standard pricing logic. 4. Do not allow the go-live to proceed until the total order value reconciliation shows 100% alignment across all O2C variants. Shortcuts in pricing validation will lead to a financial crisis in the first month-end close.
Follow-up 1. Why does S/4HANA pricing produce different rounding results than ECC?
Answer: HANA 2.0 performs floating point math differently than legacy row-based databases. Additionally, because the new table PRCD_elements is transparent, the system no longer needs to compress values, which sometimes results in a higher degree of precision during intermediate calculation steps. This can cause a 1-cent drift if not handled in the pricing routine.
Follow-up 2. What is the most critical pricing scenario to test during an S/4HANA migration?
Answer: the most critical scenarios are those involving tiered scales and group conditions. These are the most sensitive to the architectural shift to PRCD_elements. You must verify that the scale-based values are being calculated across the entire document exactly as they were in ECC.
Follow-up 3. Curveball. What if finance refuses to sign off because of a 1-cent rounding difference on a $1 million order?
Answer: you must listen to them. While 1 cent seems trivial, it indicates a difference in how the system calculates tax or currency conversion. If that 1 cent appears on 100,000 invoices, you have a $1,000 imbalance that your auditors cannot explain. You must identify the root cause in the pricing routine and adjust the rounding rules to match the legacy audited figures.
Exclusive pro tip.
Establish a pricing council during the realize phase consisting of SD, finance, and tax leads. This council must sign off on a calculation truth document, which is used to audit the output of every automated test run, ensuring that the system's math matches the corporate financial policy.
Scenario 144. Variant order to cash flows not tested.
In the realize phase of an ECC to S/4HANA migration, the project team often validates the standard sales process, but ignores complex order to cash variants such as third-party drop shipments, intercompany sales, and consignment processing. Because S/4HANA introduces new integration logic for advanced ATP and embedded EWM, these secondary flows often require unique configuration and data mapping that differ from standard sales. If these variants are excluded from the test scope, the business will face immediate shipping and billing failures for non-standard orders post-go-live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high process and integration integrity risk. 2. Phase, realize. 3. Frequency, extremely common in multi-entity global corporations. 4. Primary ownership, test lead and QA manager. 5. Supporting SD functional lead. 6. Business ownership, sales operations director. 7. Relevant SAP note, not applicable test strategy and execution. This is a scoping and governance failure.
Diagnostic dashboard, symptoms and evidence.
How variant testing gaps manifest during the validation cycles. 1. Symptom: standard domestic orders work perfectly, but intercompany billing documents (IV) fail to generate or show account determination errors. 2. Red flag: the test management tool contains 0 test cases for document types like KB, KE, or NB. 3. Business impact: a total halt in third-party procurement and intercompany revenue recognition on the first day of operations. 4. Detection: checking table VBFA for document flow completeness reveals that secondary document types were never created during the SIT phase. 5. Technical proof: missing configuration in S/4HANA for purchase requisition creation from sales orders, item category TS, that was bypassed in testing. Insight: if you only test the happy path, you are only validating 20% of your real-world business complexity.
Why this happens, scenario analysis and root cause.
1. Test scripts are often based on standard training manuals rather than a deep analysis of the actual ECC document types used in production. 2. Underestimation of the cross-module dependencies between SD, MM, and FI for variant flows like intercompany and consignment. 3. Functional leads focus on the simplification items while ignoring the business logic that remain the same but requires different test data. 4. Project pressure to meet the testing sign-off date leads to the descoping of low-volume but high-complexity variants. The failure is a result of a testing strategy that prioritizes volume over variety.
Why this is a migration, exclusive failure.
1. In ECC upgrades, variant flows remain technically stable and did not require revalidation unless specifically modified. 2. S/4HANA migration involves a fundamental shift in how the system handles stock in transit and intercompany billing. SAP Note 2503673. 3. The move to business partner, CVI, requires that intercompany customers and vendors be perfectly synchronized, which is unique to S/4HANA. 4. This failure only surfaces when the system transition reveals that legacy hidden configuration for variants was not carried over correctly. Migration forces a level of variant revalidation that ECC never approached.
Financial and customer impact.
1. Operational paralysis as the business is unable to ship third-party orders, leading to massive delivery backlogs and customer penalties. 2. Financial imbalances between company codes if intercompany billing fails, complicating the first month-end close. 3. Inaccurate inventory reporting if consignment fill-ups and issues are not correctly processed in the new system. 4. High cost of emergency training and manual data correction for warehouse staff who encounter unfamiliar errors in non-standard flows. Variant testing gaps directly threaten the company's global supply chain and internal financial netting.
Governance and accountability, RACI model.
Ensuring variant coverage requires a formal sign-off between sales and logistics. 1. Accountable, test lead and QA manager, the person who owns this and gets fired if it fails. 2. Responsible, SD functional lead documents the full matrix of O2C variants and creates the corresponding test scripts. 3. Consulted, MM and FICO lead validate the cross-module integration points for third-party and intercompany flows. 4. Informed, sales operations director confirms that all business scenarios are represented in the final test sign-off. Accountability ensures that no business entity is left behind during the testing phase.
Ownership, who actually fixes it.
Resolving this requires a process inventory and mandatory variant scripts. 1. The test lead utilizes SAP Signavio or transaction SD03N to find all active sales document types in ECC and mandates a test case for each. 2. The SD functional lead creates a variant matrix showing the link between sold to, shipped to, and item category for every non-standard flow. 3. The QA team executes end-to-end testing for the top 10 variants, ensuring the document flow from order to payment is 100% complete. 4. The business process owner performs a day in the life test for specialized roles like consignment managers or export coordinators.
Who gets blamed versus who owns it.
1. Blamed, SD functional lead, the business assumes the integration was not configured correctly. 2. Blamed, testing team executives assume the testers did not try hard enough to find bugs. 3. Actual owner, test lead and QA manager responsible for the failure to define a comprehensive and data-driven testing scope. 4. Root cause, using a standard-only test script library for a highly customized enterprise system. Blame focuses on the bug. Ownership focuses on the missing script.
How this is actually fixed, the right way by a role.
1. The test lead mandates the use of variant-aware test scripts that include mandatory checks for subsequent document creation. 2. The project team implements a variant gate between SIT1 and SIT2, where 100% of active ECC document types must be proven to save. 3. Developers refactor test data to include intercompany customers and vendors that were identified as high risk during CVI preparation. 4. Functional leads execute a full-cycle test for third-party flows, verifying that the sales order correctly triggers the purchase order in MM.
What not to do, common wrong fixes.
1. Do not assume that if a standard order works, a dropship order will also work. They use different calculation engines. 2. Do not skip testing for low-volume variants like consignment returns, as these often contain the most complex tax and inventory logic. 3. Do not accept a unit test result as proof of integration success for intercompany flows. 4. Do not allow the go-live to proceed until every sales organization has successfully tested at least one of their local O2C variants. Shortcuts in variant validation will lead to a supply chain halt in your regional business units.
Follow-up 1. How do I identify every O2C variant in a messy legacy ECC system?
Answer: the most reliable way is to extract table VBAP for the last 12 months. Create a pivot table of sales document type and item category. Every unique combination represents a variant that must be accounted for in your test plan. This data-driven approach removes the guesswork from scoping.
Follow-up 2. Why do intercompany flows specifically fail during S/4HANA migration?
Answer: intercompany flows are sensitive to the new business partner and universal journal architecture. If the intercompany customer is not correctly linked to the sales organization in the BP master, or if the intercompany clearing accounts are not set up as cost elements in FICO, the process will crash.
Follow-up 3. Curveball. Can we use model company best practices to skip variant testing?
Answer: absolutely not. Model company provides a target state, but your migration is about moving from a legacy state. If your legacy business uses variants that aren't in the model company, which is common, and you do not test the gap, your system will be dead on arrival. Best practices are for new processes. Testing is for protecting existing revenue.
Exclusive pro tip.
Create a document flow poster for each O2C variant and hang it in the UAT room. Require users to physically check off every step in the flow, from quote to payment, for their specific variant. This manual audit forces users to look beyond the sales order screen and catch integration errors early.
Scenario 145. Edge case scenarios missing.
In the realize phase of an ECC to S/4HANA migration, the test scripts are often designed for perfect data scenarios. However, the real business operates with complex edge cases, such as sales orders with multiple delivery blocks, partial returns with mixed condition exclusions, or back-to-back orders with serial number requirements. If these high-complexity edge cases are missing from the test scope, the organization will experience unpredictable system dumps and data corruption once users begin processing real-world transactional chaos.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high system stability and data integrity risk. 2. Phase realize. 3. Frequency, very common in large systems with 20+ years of business rules. 4. Primary ownership, test lead and QA manager. 5. Supporting SD functional lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note, not applicable test strategy and execution. This is a negative testing and validation failure.
Diagnostic dashboard, symptoms and evidence.
How edge case testing gaps manifest during the validation cycles. 1. Symptom. A sales order with 100 line items and mixed tax jurisdiction triggers a CX_SY_arithmetic_overflow dump that was never seen in testing. 2. Red flag. All test data uses the same 5 clean materials and standard customers for every script. 3. Business impact. Significant downtime on day 1, as IT teams struggle to replicate obscure production errors that the testing scripts ignored. 4. Detection. Comparing the test data profile against the production data profile reveals that 90% of the product complexity was never tested. 5. Technical proof. Logs in transaction ST22 show dumps in custom pricing routines when specific mutually exclusive conditions are applied to a single line item. Insight: if your testing only covers the possible, your go-live will be destroyed by the probable.
Why this happens, scenario analysis and root cause.
1. Testing teams prioritize functional success. The system works over functional robustness. The system cannot be broken. 2. Functional leads lack the time to design negative test cases where invalid data is intentionally entered to test error handling logic. 3. The use of synthetically created test data, which lacks the real-world inconsistencies and historical baggage of production data. 4. Failure to perform a conflict analysis between different S4 HANA simplifications. For example, how ABAP interacts with credit management on a return order. The failure is a result of a testing strategy that treats the business process as a linear path rather than a complex web.
Why this is a migration, exclusive failure.
1. ECC systems were stabilized over decades, and users had already discovered and worked around most edge cases. 2. S4 HANA migration involves a massive change in the technical stack, HANA database, Fiori UI, OData APIs, where old workarounds no longer function. 3. The shift to memory-resident ATP and transparent pricing, PRCD_elements, changes the calculation sequence for complex multi-item documents. 4. This failure only surfaces when the new architectural components encounter the rare data combinations that occur only at production scale. Migration removes the safety net of legacy workarounds, exposing edge cases as system stoppers.
Financial and customer impact.
1. Operational disruption leads to missed fulfillment of complex orders, often involving the company's highest value and most sensitive customers. 2. Data corruption occurs if an edge case bypasses standard validations and saves inconsistent values into the Universal Journal, ACDOCA. 3. Increased financial risk if manual pricing overrides are used as a fallback to bypass untested system blocks on complex orders. 4. High cost of emergency patching, as developers must fix production-critical bugs under the extreme pressure of the go-live window. Edge case failures directly compromise the stability and auditability of the revenue engine.
Governance and accountability, RACI model.
Ensuring robustness requires a dedicated red team testing mindset. 1. Accountable test lead and QA manager, the person who owns this and gets fired if it fails. 2. Responsible SD functional lead identifies the high-risk document combinations that represent business edge cases. 3. Consulted lead ABAP developer provides the technical failure modes for custom routines and pricing formulas. 4. Informed IT transformation director monitors the defect density in complex scenarios as a key quality metric. Accountability ensures that system robustness is a mandatory quality gate.
Ownership, who actually fixes it.
Resolving this requires a negative testing strategy and chaos data scenarios. 1. The test lead mandates a destructive testing phase where users are rewarded for finding ways to break the system logic. 2. The SD functional lead reviews the top 20 historical production dumps from ECC to ensure those scenarios are in the test script. 3. The QA team executes dirty data loads into the test environment to simulate real-world input errors. 4. The technical architect performs a combinatorial test, verifying that multiple blocks credit, delivery, billing can be handled on a single document without collision.
Who gets blamed versus who owns it.
1. Blamed, ABAP development team executives assume the code was poorly written for complex cases. 2. Blamed, business users, IT assumes the users are doing it wrong or using the system incorrectly. 3. Actual owner, test lead and QA manager responsible for the failure to define a robust negative testing protocol. 4. Root cause, treating UAT as a validation of success rather than a search for failure. Blame focuses on the individual transaction. Ownership focuses on the lack of testing rigor.
How this is actually fixed, the right way by a role.
1. The test lead establishes a complexity index for test cases, requiring that 20% of scripts be negative or edge case scenarios. 2. The team implements boundary value analysis for all custom price and discount fields to test for arithmetic limits. 3. Functional leads utilize transaction SDAD to identify the most code-intensive transactions in ECC and prioritize them for deep dive testing. 4. The project team performs a stress test using a copy of actual production data from the last 30 days of ECC operations.
What not to do, common wrong fixes.
1. Do not use default values for every field in your test scripts. This hides errors in field-level validations. 2. Do not allow the business to skip negative testing because it is too difficult or not how we usually work. 3. Do not assume that because an order works for customer A, it will also work for customer A with a credit block. 4. Do not rely on the search results from transaction VA05 as proof that the document flow is correct. You must open the document. Ignoring edge cases is a high-stakes gamble that will inevitably fail when real production volume hits.
Follow-up 1. What is negative testing, and why is it mandatory for S4HANA?
Answer: negative testing is the process of trying to break the system by entering incorrect, extreme, or unexpected data. In S4HANA, this is mandatory because the new database and UI layers are much stricter. You must prove that the system correctly blocks an invalid transaction without dumping or corrupting the data.
Follow-up 2. How can I find real edge cases without waiting for production dump?
Answer: you should interview your help desk or level 2 support team. They know exactly which document combinations cause the most issues in the current ECC system. Translate their troubleshooting tickets into mandatory test scenarios for your S4HANA migration.
Follow-up 3. Curveball. What if the business says we have too many edge cases to test them all?
Answer: you must prioritize based on financial risk. An edge case in pricing or tax is a P1 priority. An edge case in a text description field is a P3. Use a risk matrix to show the business that skipping high-risk edge cases is an unacceptable liability for the go-live sign-off.
Exclusive pro tip.
Implement a bug bounty program during the final 2 weeks of UAT. Offer a prize to the user who finds the most creative way to trigger a system error. This gamification encourages users to think like stress testers and uncover the edge cases that standard scripts always miss.
Scenario 146. Country localization scenarios missing.
In the realize phase of a global ECC to S4HANA migration, the testing team often focuses on the global template while ignoring country-specific legal and tax requirements. Because S4HANA introduces new frameworks for document compliance and international trade, legacy localization workarounds often fail. If specific scenarios like Brazil Nota Fiscal, India GST, or Italy SDI are not part of the core test scope, the business will be legally unable to issue invoices or clear customs in those regions on day 1.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high legal compliance and regulatory risk. 2. Phase, realize. 3. Frequency, common in multinational global template rollouts. 4. Primary ownership, test lead and QA manager. 5. Supporting local functional lead and SD functional lead. 6. Business ownership, regional finance director. 7. Relevant SAP note, not applicable test strategy and execution. This is a governance and localization scoping failure.
Diagnostic dashboard, symptoms and evidence.
How localization testing gaps manifest during global validation. 1. Symptom: billing documents are created in S4HANA but fail to transmit to government portals or generate mandatory tax XML files. 2. Red flag: the test script library contains 0 entries for local legal reporting or statutory tax invoicing. 3. Business impact: complete operational shutdown in specific countries due to the inability to generate tax-compliant documentation. 4. Detection: comparing the country coverage in the test management tool against the company code list reveals missing regional scripts. 5. Technical proof: logs in the SAP document compliance monitor, transaction edoc_cockpit, show errors for untested regional tax jurisdictions. Insight: a system that is up but not local is a liability, not an asset for a global business.
Why this happens, scenario analysis and root cause.
1. The central project team lacks visibility into the last-mile compliance requirements that were handled by local Z reports in ECC. 2. Failure to include local subject matter experts, or SMEs, in the design and validation of the global test scripts. 3. Underestimating the impact of S/4HANA simplifications on localization components like the golden tax in China or nota fiscal in Brazil. 4. The project team assumes that standard SAP country versions will handle all local requirements without explicit testing of the custom extensions. The failure is a result of a headquarters-centric mindset that ignores regional legal reality.
Why this is a migration exclusive failure.
1. In ECC upgrades, localization logic was mature and stable, requiring only minor delta testing for new tax codes. 2. S/4HANA migration often involves moving from legacy add-ons to the new document and reporting compliance framework. 3. The shift to the Universal Journal ACDOCA impacts how local statutory reports, like the Italian Libro Giornale, pull data from SD. 4. This failure only surfaces when the organization attempts to execute a legal transaction in a newly converted regional environment. Migration forces a replatforming of local compliance that ECC upgrades never required.
Financial and customer impact.
1. Severe legal penalties and interest charges for failing to report taxes in a compliant digital format, for example, GST or VAT. 2. Shipments are impounded at national borders because the export documentation does not meet the new S/4HANA International Trade Standards. 3. Customer disputes increase as local buyers cannot process invoices that lack mandatory regional tax identifiers. 4. High cost of emergency localization, as the organization must scramble to implement local notes after the global go-live. Localization failures directly jeopardize the license to operate in international markets.
Governance and accountability, RACI model.
Securing global compliance requires a decentralized verification model. 1. Accountable test lead and QA manager, the person who owns this and gets fired if it fails. 2. Responsible local functional lead defines the mandatory legal scenarios for their specific country or region. 3. Consulted SD functional lead ensures the global pricing and billing logic does not break the local tax engine. 4. Informed regional finance director signs off on the legal readiness of the system for their entity. Accountability ensures that the global template does not come at the cost of local compliance.
Ownership, who actually fixes it.
Resolving this requires a localization audit and regional script enrichment. 1. Local functional lead creates a localization matrix listing every legal document and tax report required in their country. 2. Test lead mandates a regional UAT where local users process end-to-end orders in their native language and currency. 3. The SD functional team refactors the pricing procedure to ensure tax-on-tax calculations match the local government requirements. 4. Technical architect performs a connectivity test between S/4HANA and the local government tax authority cloud portals.
Who gets blamed versus who owns it.
1. Blamed local IT team. The business assumes the local staff did not tell HQ what was needed. 2. Blamed SAP users claim the country version for S/4HANA is incomplete or buggy. 3. Actual owner, test lead and QA manager responsible for the failure to integrate localization into the global test plan. 4. Root cause, treating localization as a post-go-live activity rather than a realize phase requirement. Blame targets the local team. Ownership targets the global governance failure.
How this is actually fixed, the right way by a role.
1. Test lead establishes a localization gate, requiring a signed-off statutory test report from every country before go-live. 2. The team implements local edge case data in the test environment, for example, multi-state tax registrations for India. 3. Functional leads utilize transaction code S_ALR_870123557 or regional tax reports to verify the data accuracy against an ECC baseline. 4. The project team executes a statutory mock run, simulating a full month-end legal reporting cycle for the highest-risk countries.
What not to do, common wrong fixes.
1. Do not assume that testing in US English and USD validates the tax engine for Europe or Asia. 2. Do not allow HQ users to test local regional processes. You must have native SMEs who understand the local law. 3. Do not skip the testing of paper-based legal requirements that may still exist in specific emerging markets. 4. Do not rely on the readiness check to identify all local Z modifications needed for compliance. Ignoring local compliance in the test plan is a guaranteed recipe for a day one legal crisis.
Follow-up 1. Why is HQ testing usually insufficient for global localization?
Answer: HQ data is usually too clean and follows standard corporate paths. Local compliance often depends on obscure fields like Incoterm locations or material groupings that aren't used at HQ, but are mandatory for tax calculation in countries like Brazil or Russia. Without local data variants, these errors stay hidden until go live.
Follow-up 2. What is SAP document and reporting compliance, and why does it matter?
Answer: it is the unified S/4HANA framework that replaces many legacy regional add-ons. It handles electronic invoicing and statutory reporting in a standardized way. Migrating to this framework is a major architectural shift that requires dedicated SIT and UAT cycles to ensure the mapping to government portals is correct.
Follow-up 3. Curveball. What if the global template contradicts a local legal requirement during testing?
Answer: law always wins over template. You must implement a localization exception in your architecture. This is why testing with local SMEs is critical. They will identify where the global template violates local law, allowing you to build a compliant regional variant in S/4HANA before you ship the first order.
Exclusive pro tip.
Mandate a passport test for your S/4HANA system. For every country in scope, process one sales order from inquiry to tax reporting using only local users and local master data. If the order cannot cross the legal border in the test system, it will not cross the physical border in production.
Scenario 147. Revenue recognition test cases incomplete.
In the realize phase of an ECC to S/4HANA migration, the organization often fails to validate the total transition from legacy SD revenue recognition to the new SAP revenue accounting and reporting, or RR. Because S/4HANA deprecates the VBREK and VBREV tables, the logic for recognizing revenue moves from the SD module to a contract-based engine. If test cases only focus on billing and ignore the revenue recognition events, the organization will face massive financial imbalances and audit failures at the first month-end close.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial integrity and audit risk. 2. Phase, realize. 3. Frequency, common in industries with subscription models or long-term projects. 4. Primary ownership, test lead and QA manager. 5. Supporting SD functional lead and FICO lead. 6. Business ownership, revenue manager and corporate controller. 7. Relevant SAP note, not applicable test strategy and execution. Reference SAP note 2267319 and SAP note 2225170 for revenue accounting context.
Diagnostic dashboard, symptoms and evidence.
How revenue testing gaps manifest during system validation. 1. Symptom: invoices are generated successfully in S/4HANA, but the corresponding revenue accounting item or RAI is never created in the RAR monitor. 2. Red flag test scripts are marked as pass based only on the creation of a billing document VF01 with no check for the revenue contract FRR_TM00. 3. Business impact: inability to recognize revenue according to IFRS 15 or ASC 606 standards, leading to potential financial restatements. 4. Detection: checking table FRR_D_contract reveals 0 entries for migrated sales orders that are supposedly open and active. 5. Technical proof: errors in the S/4HANA to RAR interface log stating that mandatory business attributes for revenue contracts were never passed. Insight: billing is a sales event. Revenue recognition is an accounting event. If you only test one, your system is half broken.
Why this happens, scenario analysis and root cause.
1. SD consultants assume that revenue recognition is an FI problem and exclude it from the O2C functional testing scripts. 2. A lack of end-to-end visibility. Testers stop once they see the accounting document, failing to check the subsequent revenue subledger. 3. Failure to simulate contract modifications during testing, such as changing an order quantity after revenue has already started to be recognized. 4. The project team fails to realize that S/4HANA revenue recognition, EBRR or RER, requires a different event trigger than legacy ECC. The failure is a result of a siloed testing approach that ignores the revenue lifecycle of the document.
Why this is a migration, exclusive failure.
1. ECC upgrades never required a change in the revenue engine. The VBREV table remained the stable source of truth. 2. S/4HANA migration physically deactivates legacy SD Rev Rec, making it impossible to continue with the old testing patterns. 3. The integration between SD and the new RER engine is a one-time setup unique to the S/4HANA transformation path. 4. This failure only surfaces when the organization attempts to perform its first period end close in the converted S/4HANA environment. Migration forces a total redesign of the revenue pipe that ECC took for granted.
Financial and customer impact.
1. Material misstatement of financial results, leading to a qualified audit opinion and a loss of market valuation. 2. Month-end closing is delayed by weeks, as accountants must manually calculate revenue for thousands of contracts in Excel. 3. Sales commissions are calculated incorrectly if they are tied to revenue recognition triggers rather than invoice dates. 4. Customer disputes arise if revenue-based billing, like time and material, is calculated using untested S/4HANA logic. Revenue recognition testing gaps directly compromise the company's financial truth.
Governance and accountability, RACI model.
Securing revenue requires a unified SD and FICO testing strategy. 1. Accountable test lead and QA manager, the person who owns this and gets fired if it fails. 2. Responsible FICO and SD functional lead jointly responsible for defining the revenue recognition test scripts. 3. Consulted revenue accountant provides the complex arrangement scenarios, for example, bundles for validation. 4. Informed corporate controller signs off on the financial reconciliation success before go live. Accountability ensures that revenue accuracy is a mandatory gate for system acceptance.
Ownership, who actually fixes it.
Resolving this requires an integrated cycle testing approach. 1. Revenue accountant identifies the top 20 most complex revenue scenarios, for example, milestone, time-based, and percent of completion. 2. Test lead mandates that every SD test script must conclude with a revenue balance check in transaction FRR_TM00. 3. FICO lead ensures that the general ledger accounts for contract assets and contract liabilities are perfectly balanced post-load. 4. Technical architect performs a stress test on the revenue accounting item or RAI transfer to ensure no bottlenecks exist at scale.
Who gets blamed versus who owns it.
1. Blamed. SD functional lead. The finance team assumes the sales order is not sending data to RAR. 2. Blamed. FICO team users assume the accounting side of S/4HANA is not configured correctly. 3. Actual owner, test lead and QA manager responsible for the failure to define an end-to-end revenue test cycle. 4. Root cause, treating revenue recognition as an isolated subtask rather than the final step of the O2C process. Revenue failures are integration failures, not single module bugs.
How this is actually fixed, the right way by a role.
1. Test lead mandates a revenue dry run where a full month's worth of transactions are processed and closed in the sandbox. 2. The team implements automatic reconciliation checks that flag any sales order that does not have a linked revenue contract. 3. FICO lead utilizes SAP Note 2225170 to execute the mandatory reconciliation tools between SD and RAR during the test cycles. 4. The project team executes modification testing, verifying that cancellations, returns, and price changes are correctly reflected in the revenue contract.
What not to do, common wrong fixes.
1. Do not assume that if the billing document is posted to the GL, the revenue is correctly recognized. They are different subledgers in S/4HANA. 2. Do not skip the testing of in-flight revenue contracts that were migrated from ECC. 3. Do not rely on manual journal entries to fix revenue errors during UAT. You must fix the underlying SD to RAR mapping. 4. Do not sign off on testing until the revenue accounting team has formally approved the P&L impact of the test orders. Shortcuts in revenue validation will lead to a material weakness finding in your first corporate audit.
Follow-up 1. Why is testing bundled sales so critical for S/4HANA revenue accounting?
Answer: S/4HANA RAR is designed to handle allocation. If you sell a machine and a 2-year service contract together, S/4HANA must allocate the revenue based on standalone selling prices. If your test cases only use single-item orders, you will never know if your allocation logic is compliant with IFRS 15 until it is too late.
Follow-up 2. What is the RI monitor and why should testers check it?
Answer: the Revenue Accounting Item or RI monitor is the holding area for data coming from SD. Testers must check this to ensure that data is flowing technically. If the RI is stuck in error status, the revenue contract will never be created, and the financials will be wrong.
Follow-up 3. Curveball. What happens to my revenue if the sales rep changes a price after the order is partially delivered?
Answer: this is a contract modification event. In ECC, this often required complex manual adjustment. In S/4HANA RAR, the system should automatically reallocate the remaining revenue. If you have not included this specific change order scenario in your test cases, you are leaving your most complex financial risk unvalidated.
Exclusive pro tip.
Mandate a revenue reconciliation sign-off for every single SIT and UAT cycle. Use transaction FRR_check_consistency to verify that the SD and RAR modules are in perfect technical sync before you allow any test script to be marked as complete.
Scenario 148. Advanced variant configuration scenario gaps.
In the realize phase of an ECC to S/4HANA migration, organizations moving to the advanced variant configuration, or AVC engine, often fail to test the technical syntax deltas between classic LOVC and the new HANA native engine. Because AVC uses a declarative constraint-based logic rather than procedural steps, legacy models often behave unpredictably during configuration. If test cases do not cover complex multi-level dependencies and custom variant functions, the business will experience incorrect BOM explosions and pricing errors for customizable products post-go-live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high product configuration and pricing integrity risk. 2. Phase, realize. 3. Frequency, common in automotive machinery and high-tech industries. 4. Primary ownership, SD and VC architect. 5. Supporting ABAP custom code remediation lead. 6. Business ownership, product management director. 7. Relevant SAP note. SAP note 2711932. Advanced variant configuration simplification.
Diagnostic dashboard, symptoms and evidence.
How AVC configuration gaps manifest during validation cycles. 1. Symptom: sales orders for configured materials trigger runtime errors like variant function not found or syntax error in constraint net. 2. Red flag: test scripts are based on ECC LOVC screen captures and do not account for the new Fiori-based AVC simulation environment. 3. Business impact: inability to quote or manufacture complex products because the system cannot validate the selected characteristics. 4. Detection: the AVC trace tool transaction VCH_trace shows that specific object dependencies are being ignored or skipped during runtime. 5. Technical proof: errors in the AVC compiler stating that legacy procedural P functions are incompatible with the new declarative engine. Insight: AVC is a paradigm shift. If you test it like a standard upgrade, you will miss the fundamental engine logic changes.
Why this happens, scenario analysis and root cause.
1. The project team assumes that because the VC models were not changed, the new AVC engine will process them exactly like the old LOVC engine. 2. Failure to refactor legacy Java-based IPC logic into ABAP-based AVC logic, which is a mandatory requirement for Fiori compatibility. 3. Test data lacks inconsistent configuration scenarios, which the new AVC engine handles much more strictly than classic ECC. 4. Functional leads underestimate the impact of constraint net performance on large, multi-level bills of materials. The failure is a result of treating the AVC engine as a technical patch rather than a functional replatforming.
Why this is a migration exclusive failure.
1. ECC upgrades never required a change in the configuration engine. LOVC remained the only native standard. 2. S4 HANA migration introduces the choice between classic and advanced configuration profiles for every material. 3. The transition from procedural logic to declarative constraints is a one-time architectural shift unique to the S4 HANA migration path. 4. This failure only surfaces when a material is switched to the advanced profile, and the AVC engine attempts to solve the legacy logic. Migration forces a logic modernization that classic ECC never demanded.
Financial and customer impact.
1. Revenue loss as the company cannot accept orders for its most profitable customizable products on day one. 2. Inaccurate production orders lead to massive scrap costs if the configuration drift results in a wrong BOM being sent to the floor. 3. Massive quoting errors where high-value options are selected, but the AVC pricing logic fails to trigger the surcharge. 4. Customer frustration as the online configurator becomes unstable, leading to abandoned shopping carts and lost sales. AVC failures directly paralyze the engineer-to-order and configure-to-order supply chains.
Governance and accountability, RACI model.
Managing AVC risk requires deep configuration and architectural expertise. 1. Accountable SD and VC architect, the person who owns this and gets fired if it fails. 2. Responsible VC modeler refactors legacy object dependencies into AVC-compliant constraints and nets. 3. Consulted product management director validates that the product constraints still reflect current engineering standards. 4. Informed IT transformation director monitors the configuration pass rate during the final simulation phase. Accountability ensures that product rules are technically sound before they reach the customer.
Ownership, who actually fixes it.
Resolving this requires a syntax and engine audit of the configuration models. 1. VC architect identifies all high-complexity materials and mandates a syntax audit using the AVC compiler. 2. VC modeler refactors procedural procedures into constraints to leverage the high-performance HANA engine. 3. ABAP development team refactors legacy variant functions into classes implementing the new AVC BADI interfaces. 4. The test team executes automated configuration comparison between the legacy system and the S4 HANA AVC simulation.
Who gets blamed versus who owns it.
1. Blamed. SD lead the business assumes the sales order configuration screen is broken. 2. Blamed. SAP users claim the new advanced engine is too restrictive for their complex products. 3. Actual owner, SD and VC architect responsible for the failure to audit and refactor the legacy models during the realize phase. 4. Root cause, assuming 100% backward compatibility between procedural legacy logic and declarative HANA native logic. Configuration logic is the hidden code of the supply chain. It requires professional remediation.
How this is actually fixed, the right way by a role.
1. VC architect mandates the use of transaction VCH_audit to identify model inconsistencies across the entire portfolio. 2. The team implements regression test cases using the AVC simulation tool to compare output values for 100 random configurations. 3. ABAP lead utilizes SAP Note 2711932 to ensure the new AVC-specific BADIs are correctly registered in the enhancement framework. 4. Functional leads execute scenario testing for multi-level BOMs to ensure the characteristic propagation logic is intact.
What not to do, common wrong fixes.
1. Do not allow materials to remain in classic mode if you are deploying Fiori apps. This creates a fragmented and unstable UI experience. 2. Do not use direct database reads inside a variant function. This will destroy HANA performance and cause session timeouts. 3. Do not skip the testing of inconsistent characteristic selections. The system must provide a clear error message, not a dump. 4. Do not assume that P functions for pricing will automatically find the new PRCD_elements data. Shortcuts in VC migration will lead to a production line stoppage when a bad configuration is sent to the floor.
Follow-up 1. Do I have to move to advanced variant configuration in S/4HANA?
Answer: not for all materials, but for any material you want to configure using the new SAP Fiori apps. AVC is the required engine. Classic LOVC is still supported, but it cannot leverage the HANA native performance or the modern UI capabilities.
Follow-up 2. What is the biggest advantage of the AVC engine for a global business?
Answer: the biggest advantage is conflict handling. In classic VC, the system often failed to tell the user why a selection was invalid. AVC can identify the exact object dependency that is causing a conflict and offer the user suggestions on how to resolve it, greatly improving user productivity.
Follow-up 3. Curveball. What if we keep 50% of materials in classic LOVC and move the rest to AVC?
Answer: this creates architectural dissonance. Your support team will have to maintain 2 different syntax rules and 2 different engine behaviors. Your Fiori apps will only work for half your products. While technically possible, it is a management nightmare and increases the risk of logic mismatch during future upgrades.
Exclusive pro tip.
During the explore phase, use transaction VCH_audit to generate a compatibility score for your top 10 products. If any score is below 90%, mandate a VC refactoring workstream immediately. Never go live with a model that has not been compiled by the AVC engine in a test environment.
Scenario 149. Flexible workflow approval scenarios missing.
In the realize phase of an ECC to S/4HANA migration, organizations often fail to fully validate the transition from legacy business workflow to the new flexible workflow engine. S/4HANA replaces complex O2C approvals, such as credit release, returns, and billing blocks, with a metadata-driven framework. If the test plan only covers functional approval but ignores technical conditions like agent determination errors, task gateway bottlenecks, or mobile notification failures, the business will be paralyzed by ghost blocks on day 1.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high process automation, and cash flow impact. 2. Phase realize. 3. Frequency, extremely common in multinational organizations with tiered approvals. 4. Primary ownership, SD functional lead. 5. Supporting workflow developer and Fiori lead. 6. Business ownership, sales operations manager. 7. Relevant SAP note, not applicable process design gap. This is a workflow redesign and validation failure.
Diagnostic dashboard, symptoms and evidence.
How workflow testing gaps manifest during system validation. 1. Symptom: a sales order is saved with a price block, but no notification appears in the manager's Fiori My Inbox app. 2. Red flag: test scripts are marked as pass after the block is applied, but the actual release event was never tested by a real business user. 3. Business impact: shipments are stuck in the system for days because the approvers are unaware that a task is pending. 4. Detection: transaction SWF_process_admin shows workflow instances in error status due to no agent found for the initial step. 5. Technical proof: logs in the task gateway, transaction/IWFND/error_log, show failures in pushing notifications to mobile devices. Insight: flexible workflow is a user experience process. If you only test the backend status, you are only testing half the process.
Why this happens, scenario analysis and root cause.
1. Project teams treat workflow as a technical transport and fail to realize that it requires a live connection to the team and responsibility management master data. 2. A lack of testing for complex conditions, such as tiered approvals where the agent changes based on the total order value. 3. The testing environment lacks the mobile infrastructure, SAP Mobile Start, required to validate push notifications, which is how modern managers work. 4. Legacy agent determination Z tables were not updated to point to the new S/4HANA business partner IDs for employees. The failure is a result of a siloed testing approach that ignores the human interaction of the workflow.
Why this is a migration exclusive failure.
1. ECC business workflow (SWDD) was triggered by stable BOR events that were rarely impacted by standard upgrades. 2. S/4HANA migration introduces the flexible workflow engine as the strategic foundation, which uses a completely different technical architecture. 3. The move from the SAP Office inbox to the Fiori My Inbox is a fundamental UI shift unique to the S/4HANA migration lifecycle. 4. This failure only surfaces when the new metadata-driven conditions encounter real organizational data that ECC never enforced. Migration forces a redesign of the approval pipe that ECC took for granted for decades.
Financial and customer impact.
1. Revenue is frozen in the system, as thousands of billing documents cannot be released by managers who cannot see the tasks. 2. Delayed shipments result in missed delivery windows and potential SLA penalties from large strategic accounts. 3. Loss of management trust in the new Fiori UI, as approvers are forced to go back into the legacy SAP GUI as a workaround. 4. Audit failures if the flexible conditions are too broad, allowing high-risk orders to bypass management sign-off. Workflow testing gaps directly compromise the company's internal controls and cash flow.
Governance and accountability, RACI model.
Modernizing workflows requires a tight sync between functional and UX teams. 1. Accountable SD functional lead, the person who owns this and gets fired if it fails. 2. Responsible workflow developer configures the flexible workflow scenarios and ensures the agent logic is active. 3. Consulted SAP Fiori and UX lead ensures that the My Inbox app is 100% functional for all manager personas. 4. Informed sales operations manager validates that the new approval chains match the corporate governance policy. Accountability ensures that system readiness includes user notification readiness.
Ownership, who actually fixes it.
Resolving this requires a config date notification validation sequence. 1. SD functional lead identifies every approval step and the corresponding manager role for each sales organization. 2. Workflow developer uses the Manage Workflows Fiori app to configure the start and step conditions based on CDS attributes. 3. MDM lead ensures that all managers are migrated as business partners with a valid email and system ID link. 4. Fiori lead performs a device test, verifying that approval buttons approve/reject/forward function correctly on both desktop and mobile.
Who gets blamed versus who owns it.
1. Blamed workflow developer. The business assumes the logic for the approval is broken or missing. 2. Blamed training team users claim they were never shown how to find their pending tasks. 3. Actual owner SD functional lead responsible for the failure to lead the workflow modernization workshops during the explore phase. 4. Root cause, treating workflow as a technical lift and shift rather than a business process redesign. A missed approval is a functional gap, not a technical glitch.
How this is actually fixed, the right way by a role.
1. SD functional lead mandates a workflow stress test where 500 documents are triggered simultaneously to test the task gateway capacity. 2. The team implements manual fallback agents in the workflow configuration to ensure orders are routed to a superuser if the regional lead is missing. 3. Workflow developer utilizes transaction SWF_flex_activate to ensure all O2C scenarios are technically initialized in the target environment. 4. The team executes notification testing, proving that managers receive real-time alerts even when they are not logged into the Fiori launchpad.
What not to do, common wrong fixes.
1. Do not allow the go-live to proceed until the team and responsibility data load is confirmed as 100% complete in production. 2. Do not use hard-coded user IDs in workflow conditions. You must use responsibility management to ensure future stability. 3. Do not assume that because the workflow works in GUI transaction VA01, it will work in the Fiori app. Fiori uses a different event trigger. 4. Do not ignore empty agent errors during mock migration. These are guaranteed blocked orders on day 1. Shortcuts in workflow validation will lead to an immediate operational hard stop at go live.
Follow-up 1. Why is testing the agent determination so complex in S4HANA?
Answer: in ECC, you often hard-coded a user or used a simple Z table. In S4HANA, you use responsibility management. The system must find a BP, link it to a system user, and check their team membership. If any link in that chain, BP, user, or team, is missing in the new system, the workflow fails.
Follow-up 2. What is the risk of using custom CDS attributes for workflow conditions?
Answer: the risk is visibility. If you add a custom Z field to your sales order but do not extend the workflow trigger CDS view, the flexible workflow engine will never see your field. You will be able to save the order, but the workflow will never start because the condition attribute is technically null.
Follow-up 3. Curveball. What if a manager approves an order in Fiori, but the backend status remains blocked due to a locked document?
Answer: this is a technical race condition. If a warehouse user is packing the delivery at the exact moment a manager approves the credit block, the update will fail. You must test the error handling logic. Does the system send a notification back to the manager, or does the task simply disappear? In a robust system, the task must remain in the inbox with a document locked warning.
Exclusive pro tip.
Add a mobile-first checkpoint to your UAT. Require every manager in the pilot group to approve at least one real-world document using their mobile device. If they cannot do it in the test environment, your go-live will be plagued by "I did not get the message" excuses.
Category 1 wrap-up. Functional testing.
In Category 1, we analyzed the failures in the core functional validation of S4HANA. We saw how limited regression scopes, incomplete pricing scenarios, and missing order-to-cash variants leave the system vulnerable to logic errors. The takeaway is that functional testing in a brownfield migration is not about verifying standard code, but about validating the behavioral deltas created by the new S4HANA data models.
Transition to Category 2. Integration testing incidents.
While Category 1 focused on internal module logic, Category 2 moves to the handshake. In a modern S4HANA environment, the sales and distribution module is no longer an island. It is technically fused with finance via the Universal Journal and physically synchronized with warehouse and transportation management. Now, we will analyze the incidents that occur when these cross-module connections are tested under end-to-end pressure.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Category 2. Integration testing incidents.
Category 2 addresses the failure of the end-to-end process connectivity. In S4HANA, integration is real-time and strict. A minor configuration error in SD can now trigger an immediate hard stop in the general ledger or a queue failure in the warehouse. This category highlights why testing the modular handshakes between SD, MM, FI, and TM is the most complex part of the system integration testing phase.
Category 2 Incident List, Integration Testing.
The following incidents represent failures in the cross-module and external integration points of the SD cycle. 150. SDFI sequence incorrect. Relevant SAP note not applicable integration testing design failure. 151. SDMM availability mismatch. Relevant SAP note 2321191, AATP and MRP live. 152. SDEWM integration scenarios missing. Relevant SAP note 2806070, embedded EWM. 153. SDTM integration flows missing. Relevant SAP note 2267317 LETRA to TM. 154. Tax engine scenarios incomplete. Relevant SAP note not applicable test strategy and execution. 155. E-commerce scenarios missing. Relevant SAP note not applicable test strategy and execution. 156. Revenue accounting and reporting integration not reconciled. Relevant SAP note 2267319 and SAP note 2225170. 157. Group reporting reconciliation not tested. Relevant SAP note 2349298. Universal Journal. Integration testing failures are the primary cause of Day 1 operational paralysis.
Scenario 150. SDFI sequence incorrect.
In the realize phase of an ECC to S/4HANA migration, the integration testing schedule often fails to account for the new sequential dependencies of the Universal Journal. In legacy ECC, SD and FI testing could often happen in parallel because the modules were technically decoupled. However, because S/4HANA requires every SD billing event to balance perfectly within table ACDOCA in real time, attempting to test FI month-end processes before the SD pricing and tax logic is stabilized leads to a total collapse of the financial reconciliation effort.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium project management and integration risk. 2. Phase, realize. 3. Frequency, common in projects with siloed functional teams. 4. Primary ownership, test lead and QA manager. 5. Supporting SD and FICO lead. 6. Business ownership, corporate controller. 7. Relevant SAP note, not applicable integration testing design failure. Reference SAP note 2349298 for Universal Journal context.
Diagnostic dashboard, symptoms and evidence.
How integration sequencing errors manifest during the test cycles. 1. Symptom. The FICO team reports massive out-of-balance errors during their unit testing because the upstream SD test data is inconsistent. 2. Red flag. The project plan shows SD billing testing and FI revenue testing starting in the same week with no prerequisite links. 3. Business impact. SIT cycle durations double as the FICO team is forced to wait for the SD team to fix account determination, VKOA errors. 4. Detection. Checking the defect logs reveals a high volume of blocked for accounting errors in transaction VFX3 caused by untested SD pricing formulas. 5. Technical proof. Errors in the Universal Journal validation engine stating that profit center or segment is missing from the SD-originated posting. Insight. In S/4HANA, FI is the mirror of SD. If you do not clean the mirror SD first, the reflection, FI, will always be distorted.
Why this happens, scenario analysis and root cause.
1. Traditional project managers follow the legacy ECC testing habit where accounting was seen as a separate downstream activity. 2. A lack of understanding of S/4HANA document splitting. The SD billing document is now the primary driver for splitting rules in the general ledger. 3. Functional leads do not coordinate their test data requirements, leading to broken chains where an order is created but cannot be invoiced. 4. Underestimating the impact of real-time COPA, profitability analysis, which now requires every SD condition type to be mapped to a GL account before any testing can occur. The failure is a result of a testing strategy that treats S/4HANA as a set of modules rather than a unified core.
Why this is a migration exclusive failure.
1. In ECC, you could post an invoice and fix the reconciliation issues later in the month. It was a batch-oriented world. 2. S/4HANA migration moves the enterprise to a real-time world via the Universal Journal, where the subledger SD and GLFI are technically one. 3. The requirement to have a 100% synchronized SDFI mapping before testing begins is a unique discipline of the S/4HANA migration path. 4. This failure only surfaces when the organization attempts to run end-to-end cycles in the new integrated architecture. Migration forces a level of modular synchronization that ECC allowed you to bypass.
Financial and customer impact.
1. Significant delays in the month-end close during the first quarter post-go-live, leading to late financial reporting to stakeholders. 2. Inaccurate cost of goods sold or COGS reporting if the SDM-MFI link is not tested in the correct sequence. 3. Revenue leakage if pricing variances are not identified until the FI reconciliation phase, which is often too late to correct the invoice. 4. Loss of ROI as the company fails to achieve the real-time reporting benefits promised in the S/4HANA business case. Sequencing errors in testing directly translate to financial reporting bottlenecks in production.
Governance and accountability, RACI model.
Managing integration sequences requires an overarching view of the data flow. 1. Accountable test lead and QA manager, the person who owns this and gets fired if it fails. 2. Responsible SD functional lead must prove that billing documents are postable before handing off data to the FICO team. 3. Consulted, FICO lead provides the mandatory field status and document splitting requirements for SD documents. 4. Informed, IT transformation director manages the project timeline and the risk of sequential delays in the test plan. Accountability ensures that one module's success is not built on another module's failure.
Ownership, who actually fixes it.
Resolving this requires a dependency-aware project schedule. 1. The test lead mandates a prerequisite map for all test scripts. No FI script can start until the parent SD script is marked as ready. 2. The SD functional lead executes a billing release audit for all test data, ensuring transaction VFX3 is 100% empty in the test client. 3. The FICO lead provides a validation report to the SD team, highlighting missing profit centers or segments in the test sales orders. 4. The project manager rebaselines the SIT schedule to allow for a sequential flow of data from order to cash.
Who gets blamed versus who owns it.
1. Blamed, FICO team. The business assumes the accounting setup is slow and blocking the project. 2. Blamed, SD team. The FICO team claims the sales consultants are providing dirty data. 3. Actual owner, test lead and QA manager responsible for the failure to design a realistic and integrated test sequence. 4. Root cause, treating SD and FI as parallel silos instead of a unified financial process. Blame targets the person holding the ticket. Ownership targets the person who designed the process.
How this is actually fixed, the right way by a role.
1. The test lead establishes a data chain approach. The output of the SD billing test case becomes the mandatory input for the FI reconciliation test case. 2. The team implements cross-functional stand-ups daily during SIT to identify where SD data issues are blocking financial progress. 3. Functional leads utilize transaction FINS_recon to automate the consistency checks between the SD subledger and the general ledger. 4. The project team executes a minicycle 0 where only one end-to-end O2C variant is tested to prove the modular sequencing works.
What not to do, common wrong fixes.
1. Do not allow the FICO team to manually post data to pass their tests if the SD billing interface is failing. 2. Do not skip the sales order step and test from billing only. You will miss the profit center derivation logic which starts at the order. 3. Do not accept a project schedule that shows modular SIT starting on the same day for all modules. 4. Do not ignore document splitting errors in the sandbox, assuming they will be easier to fix in the larger SIT environment. Shortcuts in testing sequence lead to a false pass and a day one financial disaster.
Follow-up 1. Why is the Universal Journal so sensitive to testing sequences?
Answer: in S/4HANA, There is no longer a separate reconciliation step between SD and FI. The moment you save a billing document, it is written to table ACDOCA. If the SD configuration for profit center or tax is wrong, the FI posting will fail immediately. This means your SD testing must be 100% accurate before you can even begin to validate your general ledger.
Follow-up 2. How can I technically prove that the SDFI sequence is broken?
Answer: check transaction VFX3 in your testing client. If you see thousands of documents with the error account determination error or missing profit center, it proves that the SD team is pushing untested data through to the FICO team, effectively using the FICO team as their data cleansing department.
Follow-up 3. Curveball. What if the project manager says parallel testing is mandatory to meet the deadline?
Answer: you must push back with a risk-impact analysis. Parallel testing only works if the configuration is 100% stable. In a migration, configuration is rarely stable. Parallel testing will actually delay the project because the FICO team will spend 80% of their time debugging SD data errors rather than testing their own financial logic. Sequential testing is actually the fast path.
Exclusive pro tip.
Mandate a modular handover gate. The SD team cannot hand over their billing test results to the FICO team until they can prove zero errors in transaction VFX3 for all test data. This simple governance rule prevents modular silos from polluting the integration testing results.
Scenario 151. SDMM availability mismatch.
In the realize phase of an ECC to S/4HANA migration, organizations often find that the available to promise results in the sales order do not match the physical stock in the warehouse. S/4HANA introduces advanced ATP and the MRP Live engine, which change how the system prioritizes supply sources. If the testing strategy fails to account for new MRP areas or the stock in transit behavior, sales reps will promise delivery dates that the procurement and manufacturing teams cannot fulfill, leading to massive backlogs on day one.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high supply chain and inventory integrity risk. 2. Phase, realize. 3. Frequency, common in manufacturing and high-volume distribution systems. 4. Primary ownership, supply chain planning director. 5. Supporting SD functional lead and MM and PP functional lead. 6. Business ownership, supply chain planning director. 7. Relevant SAP note. SAP note 2321191. Advanced ATP simplifications.
Diagnostic dashboard, symptoms and evidence.
How availability mismatches manifest during system validation. 1. Symptom: a sales order confirms stock for today, but the warehouse monitor, VL060, shows zero available for the same material and plant. 2. Red flag: discrepancies between transaction CO09, availability overview, and transaction MMBE stock overview for materials using new ATP rules. 3. Business impact: order fulfillment rates drop immediately after go live as the system overpromises stock to low-priority customers. 4. Detection: checking the requirement class in the sales order reveals that the system is using an obsolete ECC checking rule that ignores S/4HANA stock types. 5. Technical proof: logs in the MRP Live monitor, transaction MD01N, show that certain SD requirements are being skipped by the planning run. Insight: in S/4HANA, ATP is a real-time allocation engine. If your MM and SD settings are not perfectly mirrored, the engine will fail.
Why this happens, scenario analysis and root cause.
1. Legacy ECC systems often had loose ATP rules that allowed sales to confirm against stock in quality inspection, which is now restricted by ATP. 2. The move to S/4HANA mandatory MRP areas means that stock is now partitioned. Testing often ignores that a sales order for plant A might not see stock in MRP Area B. 3. Failure to update the scope of check, transaction OPJJ, to account for new S/4HANA stock categories like valuated stock in transit. 4. The project team failed to simulate concurrent access, where multiple sales reps are competing for the same last 10 units of high-demand stock. The failure is a result of a siloed design where MM manages the supply, but SD defines the promised logic independently.
Why this is a migration exclusive failure.
1. Standard ECC upgrades use the same table-based ATP, table VBBE, which ensured that the logic never changed between versions. 2. S4 HANA migration introduces the advanced ATP engine, which is memory resident and uses HANA native algorithms for stock allocation. 3. The shift from classic MRP to MRP Live is a fundamental architectural change unique to S4 HANA that impacts how SD requirements are seen by supply. 4. This failure only surfaces when the system transition from the table-based check to the HANA native check occurs. S4 HANA introduces an allocation discipline that ECC row-based databases could not enforce.
Financial and customer impact.
1. Revenue is lost rather than deferred as customers move to competitors when promised delivery dates are repeatedly missed. 2. Increased expedited shipping costs as the warehouse is forced to ship partial quantities from remote plants to fulfill errors. 3. Inaccurate inventory valuation if the system confirms stock that is technically blocked or earmarked for other purposes. 4. Operational stop shipments if the mismatch between SD and MM causes the delivery split logic to fail during the nighttime job run. ATP mismatches directly erode the supply chain reliability and the net profit margin.
Governance and accountability, RACI model.
Securing the promise to the customer requires a cross-functional supply chain guard. 1. Accountable supply chain planning director, the person who owns this and gets fired if it fails. 2. Responsible SD functional lead configures the ATP checking rules and defines the backorder processing or BOP strategies. 3. Consulted MM and PP lead provides the supply source data, ensuring that lead times and stock types are 100% accurate. 4. Informed sales operations manager monitors the order fulfillment rate across all sales regions post-migration. Accountability ensures that the sales promise is backed by a physical reality.
Ownership, who actually fixes it.
Resolving this requires an end-to-end supply and demand audit. 1. Supply chain lead extracts a list of top 50 high-demand materials and their current checking rules in ECC. 2. SD functional lead configures the new ATP business categories in S4 HANA to ensure they perfectly match the ECC stock types. 3. The MM team validates that all MRP areas are correctly mapped to storage locations to avoid inventory blind spots in the ATP check. 4. The technical architect performs a volume test on backorder processing, ensuring the system can reallocate stock for 100,000 orders in the batch window.
Who gets blamed versus who owns it.
1. Blamed warehouse team. The sales team assumes the warehouse is hiding stock or miscounting inventory. 2. Blamed SAP users claim the advanced ATP engine is overpromising or fundamentally broken. 3. Actual owner supply chain planning director responsible for the failure to harmonize the demand SD and supply MM parameters. 4. Root cause. Using legacy ECC loose checking rules in a high-precision S4 HANA environment. An ATP mismatch is a planning failure, not an inventory counting error.
How this is actually fixed, the right way by a role.
1. Supply chain planning director mandates a checking rule synchronization workshop during the explore phase. 2. The team implements HANA native BOP or backorder processing, which recalculates availability for all open orders every hour to catch mismatches. 3. The SD team utilizes SAP Note 2321191 to apply the latest PAC or product availability check performance patches. 4. Functional leads execute conflict testing, where two orders for the same stock are entered simultaneously to verify the first-in first-out logic.
What not to do, common wrong fixes.
1. Do not use manual confirmed quantity entries in sales orders to fix an ATP error. This will cause inventory imbalances in MM. 2. Do not assume that classic ATP will work fine in S4 HANA if you are using MRP Live. They are architecturally incompatible. 3. Do not skip the testing of intercompany stock availability. The stock in transit logic has changed fundamentally in S4 HANA. 4. Do not allow the go-live to proceed if the MRP to ATP reconciliation report, MD04 versus CO09, shows a variance of more than 1%. Shortcuts in availability testing lead to an immediate fulfillment crisis on day 1.
Follow-up 1. Why does MRP Live impact SD availability testing?
Answer: MRP Live is significantly faster and runs more frequently. If your ATP check is set to look at planned orders, but MRP Live deletes and recreates those orders every 30 minutes, your sales confirmations will bounce. You must test the stability of the supply plan against the sales order promise logic.
Follow-up 2. What is an MRP area and why does it break SD testing?
Answer: an MRP area allows you to plan stock for a specific group of storage locations separately from the main plant. If your sales order is pointing to the plant, but the stock is physically in an MRP area that is excluded from the plant-level ATP check, the system will return zero stock. This is a common master data mapping error in S/4HANA.
Follow-up 3. Curveball. Can I use S/4HANA to protect stock for strategic customers during a shortage?
Answer: yes. This is a core feature of advanced ATP called Supply Protection, or SUP. It allows you to reserve stock for high-priority sales organizations or segments, even if a low-priority order arrives first. This is a powerful competitive advantage, but it requires a 100% redesign of your testing scripts to validate the reservation logic.
Exclusive pro tip.
Run report SDRQCR21 immediately after your final data load in every SIT cycle. This report corrects the Sales Requirements Index and ensures that the ATP engine is reading the real state of the database. If your CO09 and MMBE do not match, this report is your first line of defense.
Scenario 152. SDEWM integration scenarios missing.
In the realize phase of an ECC to S/4HANA migration, organizations moving from decentralized EWM to S/4HANA embedded EWM often fail to test the new synchronous communication layer. While legacy integration relied on asynchronous IDOCs or CIF, embedded EWM uses direct function calls. If the testing scope ignores queue failures or partial picking scenarios, the system will frequently deadlock during the post-goods issue event, leaving deliveries stuck in a technical limbo between the warehouse and the sales subledger.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high logistics execution and system stability risk. 2. Phase, realize. 3. Frequency, common in companies moving to embedded S/4HANA EWM. 4. Primary ownership, logistics integration lead. 5. Supporting SD functional lead and EWM functional lead. 6. Business ownership, warehouse operations manager. 7. Relevant SAP note. SAP note 28067070. SAP EWM deployment options.
Diagnostic dashboard, symptoms and evidence.
How SD-EWM integration gaps manifest during system validation. 1. Symptom: a delivery is fully picked in the warehouse, but the SD goods movement status remains not started. 2. Red flag: technical queues in transaction SMQ1 and SMQ2 are flooded with logical unit of work or LUW errors during peak testing volume. 3. Business impact: inability to generate invoices because the delivery document is technically locked by a failed background EWM update. 4. Detection: checking transaction /SCWM/PRDONEWM shows the document as completed, but the linked SD delivery is in process. 5. Technical proof: logs in the warehouse management monitor show direct call failures to the SD API because of a custom validation exit. Insight: embedded EWM is part of the core. If the core SD rejects a minor update, the warehouse EWM cannot finalize the shipment.
Why this happens, scenario analysis and root cause.
1. The project team assumes that embedded means the systems share the same database tables. They do not. They still communicate via technical interfaces. 2. Legacy custom logic in SD user exit MV50 AFZ1 delivery save was not updated to handle the rapid, automated updates coming from the EWM engine. 3. Failure to map EWM item types to SD item categories for non-standard O2C variants like returns or internal stock transfers. 4. Testing scripts focus on the physical pick, but ignore the technical handshake that occurs during the goods issue commit. The failure is a result of treating a structural architectural change as a simple UI update.
Why this is a migration exclusive failure.
1. In ECC, decentralized EWM was a fire-and-forget model via iDocs. If an error occurred, only the interface failed, not the transaction. 2. S/4HANA embedded EWM is a shared process model. If the SD delivery save fails, the EWM pick confirmation also fails in real time. 3. The transition from asynchronous IDOC to synchronous direct call communication is a fundamental change unique to the S/4HANA migration path. 4. This failure only surfaces when the organization attempts to execute a logistics cycle in the new embedded environment. Migration forces a level of real-time transactional integrity that legacy ECC could never achieve.
Financial and customer impact.
1. Blocked revenue as deliveries cannot be goods issued, preventing the accounting engine from recognizing the sale. 2. Inaccurate inventory levels result in ghost stock appearing in the warehouse, leading to warehouse staff searching for non-existent items. 3. Customer service delays as reps provide incorrect shipping information because the SD status is out of sync with the warehouse reality. 4. High cost of manual queue cleansing, as basis teams must resolve thousands of technical blockages daily during hypercare. Integration failures directly paralyze the physical movement of goods and the financial recognition of revenue.
Governance and accountability, RACI model.
Ensuring warehouse continuity requires a partnership between SD and EWM leads. 1. Accountable logistics integration lead, the person who owns this and gets fired if it fails. 2. Responsible EWM functional lead configures the picking and staging logic and ensures the item type mapping is 100% accurate. 3. Consulted SD functional lead provides the delivery and item category rules to ensure the handshake is logically consistent. 4. Informed IT transformation director monitors the queue error rate as a critical indicator of logistics stability. Accountability ensures that the warehouse is never blind to the sales order requirements.
Ownership, who actually fixes it.
Resolving this requires an interface and process audit. 1. Logistics integration lead extracts the queue monitor error logs from transaction/SCWM/MON to identify systemic failure patterns. 2. EWM functional lead refactors the warehouse process type to ensure it aligns with the S/4HANA SD document categories. 3. ABAP development team implements defensive coding in the delivery user exits to prevent express document terminations during automated updates. 4. Technical architect performs a stress test on the QRFC layer, simulating 5,000 picks per hour to find database locking bottlenecks.
Who gets blamed versus who owns it.
1. Blamed. Warehouse team. The sales department assumes the warehouse did not confirm the shipment. 2. Blamed. Basis team. Users assume the server is slow because the status has not updated. 3. Actual owner. Logistics integration lead responsible for the failure to design a robust synchronous handshake between the two modules. 4. Root cause. Underestimating the technical sensitivity of the S/4HANA embedded EWM communication layer. Logistics errors are usually technical integration errors, not physical picking errors.
How this is actually fixed, the right way by a role.
1. Logistics integration lead mandates a zero-error queue policy for all SIT2 and UAT testing cycles. 2. The team implements automatic queue restart for temporary network glitches using the standard SAP background job scheduler. 3. ABAP lead refactors the delivery user exits to avoid hard errors during goods issue. Instead, errors are logged in the EWM monitor for human review. 4. Functional leads execute partial success testing, verifying that if 5 out of 10 items are picked, the system correctly updates the partial status.
What not to do, common wrong fixes.
1. Do not use direct SQL update statements in the SD tables to fix a delivery status. This will permanently corrupt the EWM SD link. 2. Do not ignore warning messages in the technical queues. In an embedded environment, a warning in the warehouse often becomes a hard stop in billing. 3. Do not assume that the CIF or core interface is still needed for master data. In S/4HANA embedded EWM, CIF is largely obsolete for most objects. 4. Do not allow go live if the locked queue count exceeds 1% of the total daily transaction volume. Shortcuts in EWM integration lead to a logistics gridlock that will shut down your shipping dock on day 1.
Follow-up 1. What is the benefit of embedded over decentralized EWM in S/4HANA?
Answer: the main benefit is the elimination of data redundancy. You no longer need to send iDocs for materials, batches, or documents. The system uses a shared master data model, providing real-time visibility and significantly reducing the complexity of the landscape.
Follow-up 2. What is a QRFC, and why is it the first thing to check when SD and EWM are out of sync?
Answer: QRFC stands for Queued Remote Function Call. It is the technology that ensures that updates between EWM and SD happen in the correct sequence. If an order update fails, it blocks the queue for that specific document. You must check SMQ2 to see which specific technical error is holding up the business status update.
Follow-up 3. Curveball. What happens if the EWM system performs a post-goods issue, but the SD system fails to trigger the revenue recognition RI items due to a lock?
Answer: this is the split-brain nightmare. The warehouse thinks the stock is gone, but the finance subledger thinks it has not happened. You must test the rollback and re-trigger logic. S/4HANA is designed to atomically commit these together, but if your custom exits have an unhandled commit work, you break this atomicity, leaving your inventory and financials permanently out of balance. You must ensure 0 commit statements exist in your delivery exits.
Exclusive pro tip.
Before starting UAT, set up a logistics war room with a large monitor displaying transaction SMQ2. If any queue turns red, the EWM and SD consultants must solve it together within 15 minutes. This zero tolerance for queue errors is the only way to stabilize the embedded EWM integration before go live.
Scenario 153. SDTM integration flows missing.
In the realize phase of an ECC to S/4HANA migration, organizations often fail to validate the mandatory transition from legacy transportation (LETRA) to S/4HANA Transportation Management (TM). Because LETRA is technically deprecated, standard tables like VTTK and VTTP are no longer maintained. If the test plan ignores the creation of freight units and freight orders for complex shipping scenarios like multi-stop routes or carrier selection, the business will be unable to calculate freight costs or print bills of lading on day 1.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high logistics compliance and cost impact. 2. Phase, realize. 3. Frequency, common in systems with heavy dependency on freight forwarders. 4. Primary ownership, transportation architect. 5. Supporting SD functional lead and TM functional lead. 6. Business ownership, global logistics director. 7. Relevant SAP note. SAP note 2267317. S4 TWL LETRA deprecation and TM integration.
Diagnostic dashboard, symptoms and evidence.
How SDTM integration gaps manifest during validation cycles. 1. Symptom: a delivery is created in SD, but it fails to trigger the transportation planning status and no freight unit is generated. 2. Red flag: users attempt to use transaction VT01N for shipment creation and receive a function not available or deprecated warning. 3. Business impact: trucks arrive at the warehouse, but the system cannot generate the freight order needed for the driver's paperwork, halting all shipments. 4. Detection: checking the integration profile in the delivery header reveals that the document is not flagged for external planning. 5. Technical proof: mismatches in the condition type mapping where legacy LETRA freight costs, for example, TK11, fail to appear in the SD billing document. Insight in S/4HANA: transportation is not an add-on. It is a workflow that must be triggered by the delivery.
Why this happens, scenario analysis and root cause.
1. Project teams assume that basic shipping in S/4HANA is a one-to-one clone of ECC LETRA. It is not. It uses a fundamentally different business object model. 2. The shift from the shipment VTTK to the freight order TOR requires a total redesign of carrier selection and transit time calculation. 3. Failure to map transportation zones to TM locations, making it impossible for the engine to calculate a valid route. 4. Legacy custom reports in SD were built on the VTTK and VTTP tables, which are now ghost tables that contain zero data for new S/4HANA shipments. The failure is a result of treating the LETRA to TM transition as a UI change rather than an engine swap.
Why this is a migration exclusive failure.
1. ECC upgrades never impacted the shipment tables. VTTK remained the stable source of truth for 25 years. 2. S/4HANA migration involves a physical deactivation of the LETRA module for any advanced logistics scenarios. 3. The requirement to migrate shipment cost documents, VI01, to freight settlement documents is a one-time event unique to S/4HANA migration. 4. This failure only surfaces when the organization attempts to execute a load in the new S/4HANA transportation framework. Migration forces a level of logistics modernization that standard upgrades never required.
Financial and customer impact.
1. Massive financial loss if accrued freight costs are not correctly transferred to finance, leading to hidden logistics expenses. 2. Shipment delays lead to missed delivery slot appointments at large retailers, resulting in expensive late delivery fines. 3. Inaccurate customer billing if the freight surcharge logic in SD is not perfectly synchronized with the actual freight cost from TM. 4. Operational cost increases as the logistics team is forced to use manual paperwork to get trucks off the lot during go-live week. Transportation failures directly block the physical and financial completion of the sales cycle.
Governance and accountability, RACI model.
Managing TM integration requires a unified logistics and SD leadership. 1. Accountable transportation architect, the person who owns this and gets fired if it fails. 2. Responsible TM functional lead defines the freight unit building rules and the carrier selection logic. 3. Consulted SD functional lead provides the delivery priority and Incoterm rules that drive transportation costs. 4. Informed global logistics director monitors the freight cost variance as a key indicator of system accuracy. Accountability ensures that system planning matches physical loading reality.
Ownership, who actually fixes it.
Resolving this requires an end-to-end document flow validation. 1. Transportation architect identifies every shipment type from ECC and maps it to a corresponding freight order type in S/4HANA. 2. TM functional lead configures the integration profile for deliveries to ensure the automatic creation of freight units. 3. MDM lead ensures that all carriers are migrated as business partners with the service provider role and valid SCSC codes. 4. Technical architect refactors all legacy shipping reports to read from the new TOR and TCOR tables instead of VTTK.
Who gets blamed versus who owns it.
1. Blamed. SD lead the warehouse team assumes the delivery is broken because they cannot create a shipment. 2. Blamed. SAP the business assumes S/4HANA is too complex compared to the simple VT01 in transaction. 3. Actual owner, transportation architect responsible for the failure to lead the LETRA to TM design workshops during Explore. 4. Root cause, treating the deprecation of LETRA as a future problem rather than a day one migration requirement. Logistics failures in S/4HANA are usually due to missed architectural transitions, not configuration bugs.
How this is actually fixed, the right way by a role.
1. Transportation architect mandates a full-cycle test, sales order to delivery to freight order to freight settlement to billing. 2. The team implements basic TM configuration, the no-license alternative to LETRA, to ensure standard shipping functions remain available. 3. ABAP lead refactors the bill of lading print program to pull from the new TM freight order objects. 4. Functional leads execute cost reconciliation, verifying that the freight accrual in FICO matches the carrier's quote in TM.
What not to do, common wrong fixes.
1. Attempting to technically re-enable the LETRA screens via a core modification. This is a violation of SAP support and will fail in future upgrades. 2. Assuming that a carrier is just a vendor. In S/4HANA TM, they must be a BP with specific TM active roles. 3. Ignoring transit time variances, assuming the new TM engine will learn the routes on its own. 4. Failing to update the output determination for deliveries. TM-based shipping uses a different output trigger than LETRA. Shortcuts in TM migration will lead to a complete shipping halt and financial chaos on day 1.
Follow-up 1. Is LETRA shipments completely gone in S/4HANA?
Answer: yes and no. The traditional LETRA shipment, VTTK, is technically deprecated. However, SAP provides a basic shipping feature within S/4HANA that uses the TM engine but mimics the simple functionality of LETRA. You must migrate your logic to the TM framework, even if you are only doing basic shipping.
Follow-up 2. What is a freight unit, and why is it the most important new object in O2C?
Answer: a freight unit is the glue between SD and TM. It represents the set of delivery items that must be transported together. Without a freight unit, the TM engine cannot see your delivery, and no transportation planning or cost calculation can occur. If your freight unit building rules are wrong, your logistics flow stops.
Follow-up 3. Curveball. How do you handle a freight cost accrual if the carrier's final invoice from TM does not match the estimated SD pricing condition at the time of PGI?
Answer: this is the classic logistics variance trap. In S/4HANA, you must implement the Freight Settlement Document or FSD process. The FSD creates an accrual in FICO based on the TM freight order. When the carrier's invoice arrives, it is matched against the FSD, not the SD document. If your testing did not cover this three-way match SDTMFI, you will have massive, uncleared accrual balances on your balance sheet on day 1. You must test the dispute management logic in TM to handle these variances.
Exclusive pro tip.
Perform a ghost table audit during the realize phase. Run a report to see if any custom Z programs are still trying to read from table VTTK. Mandate an immediate refactoring to the TMTOR tables. If you wait until day 1 to find these VTTK-dependent reports, your logistics visibility will be 0.
Scenario 154. Tax engine scenarios incomplete.
In the realize phase of an ECC to S/4HANA migration, organizations utilizing external tax engines such as Vertex, Avalara, or Sabrix often fail to validate the end-to-end integration logic. Because S/4HANA enforces stricter address validation and utilizes a new business partner tax registration framework, the technical data passed to the external API can differ significantly from legacy ECC. If the test plan ignores complex scenarios like tax-exempt certificates, drop shipments across multiple jurisdictions, or nexus-based overrides, the system will trigger billing blocks or inaccurate tax liabilities on day 1.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial compliance and legal risk. 2. Phase realize. 3. Frequency, common in North American and multinational implementations. 4. Primary ownership, SD functional lead and tax lead, the person who owns this and gets fired if it fails. 5. Supporting integration architect. 6. Business ownership, corporate tax manager. 7. Relevant SAP note, not applicable test strategy and execution. This is an integration validation and data mapping failure.
Diagnostic dashboard, symptoms and evidence.
How tax integration gaps manifest during the testing cycles. 1. Symptom billing documents created in S/4HANA show the error tax calculation failed or return a default 0% rate for taxable items. 2. Red flag. The RFC trace and transaction ST05 shows that S/4HANA is sending the business partner ID to the tax engine instead of the required customer ID. 3. Business impact. Significant financial risk due to undercollection of tax or customer disputes caused by overcharging. 4. Detection. Comparing the tax XML request sent from S/4HANA against the legacy ECC request reveals missing geocodes or jurisdiction indicators. 5. Technical proof. Errors in the external tax engine logs indicating invalid address for records that were successfully processed in ECC. Insight. External tax engines are highly sensitive to address precision. If S/4HANA does not pass the exact geocode, the integration fails.
Why this happens, scenario analysis and root cause.
1. The project team assumes that because the RFC destination did not change, the tax engine will automatically recognize S/4HANA data. 2. Failure to realize that the tax number fields in the business partner model, BUT000, may be mapped differently than the legacy KNA1 fields. 3. Underestimating the impact of the international trade simplification, which changes how the departure country is determined for tax calls. 4. Testing scripts focus on domestic sales only, skipping the triangulation or export scenarios where the tax engine logic is most complex. The failure is a result of treating a specialized external integration as a standard SD configuration task.
Why this is a migration, exclusive failure.
1. In ECC upgrades, the data structures passed to the tax interface, structure TAX_EXT_input, remain stable for years. 2. S/4HANA migration involves a master data shift to business partner, which often disrupts the secondary identifiers used by tax engines. 3. The shift to the Universal Journal, ACDOCA, requires that every tax line item be perfectly balanced at the moment of invoice save. 4. This failure only surfaces when the S/4HANA pricing engine attempts to call the external API using newly converted master data. Migration creates a data mismatch between the S/4HANA core and the external compliance engine.
Financial and customer impact.
1. High risk of uncollected tax liabilities, resulting in massive back tax payments and interest during government audits. 2. Customer invoices are rejected by portals or accounts payable departments if the tax jurisdiction code is missing or invalid. 3. Delayed cash flow as sales reps must manually correct tax codes for thousands of orders to clear shipping blocks. 4. Loss of ROI as the organization is forced to pay for manual tax reconciliation services to fix migration errors. Tax engine failures directly jeopardize the financial compliance and cash flow of the enterprise.
Governance and accountability, RACI model.
Securing tax integration requires a bridge between SD, tax, and IT. 1. Accountable SD functional lead and tax lead, the person who owns this and gets fired if it fails. 2. Responsible integration architect ensures the data mapping between the S/4HANA pricing structures and the tax engine API is 100% accurate. 3. Consulted corporate tax manager provides the compliance scenarios and validates the final tax results. 4. Informed IT transformation director monitors the tax error rate as a key go-live readiness indicator. Accountability ensures that legal compliance is the primary driver for integration testing.
Ownership, who actually fixes it.
Resolving this requires a mapping and payload audit. 1. Integration architect extracts the request payload from both ECC and S/4HANA for the same customer and material to find data gaps. 2. SD functional lead refactors the tax procedure and condition types to ensure they are compatible with the external engine response. 3. ABAP development team refactors the user exit SAP_LFCPTY_001 to ensure the correct geocodes are being passed from the new BP tables. 4. Tax manager performs a tax return simulation, verifying that the S/4HANA data correctly populates the external engine's audit reports.
Who gets blamed versus who owns it.
1. Blamed. Integration team, the business assumes the interface is down. 2. Blamed. Tax engine provider users claim the external software is not working with S/4HANA. 3. Actual owner, SD functional lead and tax lead responsible for the failure to perform an integrated end-to-end tax validation. 4. Root cause, treating the tax engine as a black box that would automatically adapt to the S/4HANA data model. Blame focuses on the connection. Ownership focuses on the data content.
How this is actually fixed, the right way by a role.
1. Tax lead mandates a tax nexus audit to identify every jurisdiction where the company is legally required to calculate tax. 2. The team implements negative testing, intentionally entering orders with bad addresses to verify that the system correctly blocks the document. 3. Integration Architect utilizes SAP Note 1497956 to ensure the external tax interface or ETI settings are optimized for S/4HANA. 4. The project team executes a parallel run, calculating tax for 1,000 production copy orders, and comparing the results to the legacy ECC output.
What not to do, common wrong fixes.
1. Do not use default tax codes in S/4HANA to bypass integration errors. This will lead to massive audit penalties. 2. Do not assume that because the connection test in transaction SM59 passed, the logic is working. 3. Do not skip the testing of tax-exempt customers. The validity of exemption certificates must be re-verified against the new BP IDs. 4. Do not allow the go-live to proceed until the total tax liability reconciliation shows 100% alignment. Shortcuts in tax validation will lead to a financial crisis that the CFO will have to answer for.
Follow-up 1. Why does S/4HANA Business Partner change the tax call logic?
Answer: in ECC, the tax call was based on the customer number. In S/4HANA, the system must often check the tax jurisdictions maintained at the BP level. If your external engine relies on a specific field like tax number 3, and your CVI mapping moved that data to a different field, the API call will return an error or an incorrect rate.
Follow-up 2. What is a geocode and why does it break in migration?
Answer: a geocode is a technical identifier for a specific tax jurisdiction, state, county, city. During a migration, if the S/4HANA address cleansing was not performed correctly, the system might pass a zip code that does not match the city name according to the tax engine's stricter ISO standards, causing the tax calculation to abort.
Follow-up 3. Curveball. What if the external tax engine returns a successful response, but the S/4HANA pricing engine fails to persist the tax condition because the condition category is misaligned with the new PRCD_element structure?
Answer: this is a technical data drift failure. You must debug the pricing communication structure, or KONV. In S/4HANA, the tax condition category must be strictly mapped. If the external engine returns a value for a condition type that is no longer defined as tax in the target pricing procedure, the system will ignore the value and save the invoice with zero tax, creating a silent financial leak. You must perform a technical reconciliation between the external engine's transaction log and S/4HANA table PRCD_elements.
Exclusive pro tip.
Establish a compliance gate for SIT2. The tax team must sign off that every tax-exempt customer in the test data actually produced a tax-exempt result in S/4HANA. If even one exempt customer is charged tax, your entity mapping is broken and must be redesigned before UAT begins.
Scenario 155. E-commerce scenarios missing.
In the realize phase of an ECC to S/4HANA migration, organizations often focus on internal order entry, while ignoring the automated inbound flow from e-commerce platforms like SAP Commerce Cloud or Shopify. S/4HANA introduces the mandatory business partner and CVI model, meaning the inbound OData or SOAP services for order creation must now handle partner identification in a fundamentally different way. If the test scope misses scenarios like guest checkout or one-time customers, the integration layer will fail to create the correct master data links, resulting in failed web orders and immediate revenue loss.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium integration, and revenue continuity risk. 2. Phase, realize. 3. Frequency, extremely common in B2C and retail-oriented industries. 4. Primary ownership, integration architect, the person who owns this and gets fired if it fails. 5. Supporting SD functional lead and Fiori lead. 6. Business ownership, e-commerce manager. 7. Relevant SAP note, not applicable test strategy and execution. This is an end-to-end integration testing failure.
Diagnostic dashboard, symptoms and evidence.
How e-commerce integration gaps manifest during system validation. 1. Symptom: web orders are visible in the e-commerce middleware but fail to appear in S/4HANA table VBAK. 2. red flag technical error logs in transaction SRT_MONI SOAP or /IWFND/error_log OData stating business partner role FLCU01 not maintained. 3. Business impact, a total halt in digital sales channel revenue on day 1, leading to customer abandoned carts and brand damage. 4. Detection, checking the inbound payload shows that the webshop is sending a legacy ECC customer number that S/4HANA no longer recognizes as a primary key. 5. Technical proof, the CV IMapper class triggers a dump because the inbound order is missing a mandatory business partner grouping required by S/4HANA. Insight, your webshop does not know about CVI. If your integration layer does not bridge the gap, your orders are dead on arrival.
Why this happens, scenario analysis and root cause.
1. The project team treats the e-commerce link as a simple API and fails to update the mapping logic for the new S/4HANA partner structures. 2. A lack of joint testing between the webshop developers and the SAP migration team during the realize phase. 3. Failure to account for one-time customer, account group CPDA logic, which requires a specific CPBP role in the S/4HANA business partner model. 4. Testing scripts focus on success paths only, ignoring scenarios where the webshop user provides an invalid address that S/4HANA's CVI engine now rejects. The failure is a result of treating digital commerce as an external entity rather than a core O2C variant.
Why this is a migration, exclusive failure.
1. In ECC, inbound orders were customer-centric. The API simply checked if the customer ID existed in table KNA1. 2. S/4HANA migration makes business partner the mandatory lead object. The API must now create or find a BP before the sales order can be saved. 3. The renumbering of customers during CVI, customer vendor integration, often results in a mismatch between the ID stored in the webshop and the new S/4HANA ID. 4. This failure only surfaces when the organization attempts to process an external order against the new S/4HANA digital core. Migration breaks the ID sync that e-commerce channels have relied on for years.
Financial and customer impact.
1. Immediate loss of daily digital revenue, which for many companies represents their highest margin sales channel. 2. Operational stop shipments for web orders, resulting in a backlog that takes weeks of manual entry to resolve. 3. Severe damage to the brand's customer experience score as users receive error messages during the checkout process. 4. Inaccurate inventory levels in the webshop if the S/4HANA stock update interface also fails due to technical bottlenecks. E-commerce failures are the most public and expensive way to fail an S/4HANA migration.
Governance and accountability, RACI model.
Securing digital sales requires a unified integration and sales strategy. 1. Accountable integration architect, the person who owns this and gets fired if it fails. 2. Responsible SD functional lead provides the mapping logic for partner determination and item category rules to the integration team. 3. Consulted e-commerce manager defines the web order personas, B2B, B2C guest for validation. 4. Informed IT transformation director monitors the API success rate during the final integration testing cycle. Accountability ensures that the front end and back end are technically synchronized.
Ownership, who actually fixes it.
Resolving this requires an API mapping and partner link audit. 1. Integration architect refactors the inbound API payload to include mandatory S/4HANA fields like BP grouping and role. 2. MDM lead ensures that the webshop cross-reference table in S/4HANA is updated with the new business partner IDs. 3. ABAP development team refactors the inbound BAPI wrapper, for example, for BAPI_salesorter_creatifromdet2 to handle CVI-specific errors. 4. The team performs end-to-end UAT, where a user places an order on the live website and verifies it appears in S/4HANA within seconds.
Who gets blamed versus who owns it.
1. Blamed middleware team. The business assumes SAP PI or PO or BTP is not sending the orders. 2. Blamed webshop team. The users assume the website code is broken. 3. Actual owner, integration architect responsible for the failure to perform a 100% channel simulation during SIT. 4. Root cause, underestimating the impact of the S/4HANA business partner model on inbound transactional APIs. In S/4HANA, the API is only as strong as the master data it is trying to create.
How this is actually fixed, the right way by a role.
1. Integration architect mandates a channel readiness audit, ensuring every web order scenario is part of the automated regression suite. 2. The team implements partner mapping logic in the SAP BTP layer to translate legacy webshop IDs to the new S/4HANA BP IDs. 3. Functional leads execute guest checkout testing to verify that S/4HANA correctly creates a business partner and sales order in a single LUW. 4. The project team utilizes SAP Note 2265093 to ensure all BP-relevant IDOC and OData structures are correctly initialized.
What not to do, common wrong fixes.
1. Do not allow the e-commerce site to go live with hard-coded legacy customer numbers. 2. Do not assume that B2C orders are low risk. They often have the highest volume and most sensitive tax requirements. 3. Do not ignore partner validation errors in the integration logs, assuming they are test data issues. 4. Do not skip the testing of order cancellations coming from the webshop. Cancellations require specific document flow logic in S/4HANA. Shortcuts in e-commerce integration result in a manual order entry nightmare on day 1.
Follow-up 1. Why does S/4HANA reject web orders that ECC used to accept?
Answer: S/4HANA enforces a stricter single source of truth. In ECC, an inbound order might be saved with incomplete partner data. In S/4HANA, the business partner synchronization engine checks for mandatory fields like search term or postal code the moment the API is called. If the webshop does not provide these, the order creation is rejected.
Follow-up 2. What is the best way to handle renumbered customers in e-commerce integration?
Answer: you should use a cross-reference mapping in your middleware SAP BTP or PI or PO. This table should store the legacy web ID and map it to the new S/4HANA BP ID. This allows you to go live without having to redevelop and resync the entire e-commerce database, which is often a separate, high-cost project.
Follow-up 3. Curveball. How do you handle the scenario where the webshop passes a legacy ECC customer ID that has been renumbered during the business partner migration, and the S/4HANA OData service triggers a duplicate key error because the CVI link table has not been updated?
Answer: this is a race condition and a data integrity failure. If the CVI link table, CVI_cust_link, is not updated before the OData call, the API will try to create a new business partner for a customer that technically already exists under a different ID. You must test the lookup first logic in your integration wrapper. The wrapper must first query S/4HANA using the legacy ID as a search attribute. If found, it uses the existing BP ID. If not, it triggers the creation. This prevents duplicate master data and ensures the order is linked to the correct financial account.
Exclusive pro tip.
Mandate an end-to-end stress test 2 weeks before go live. Trigger 1,000 web orders per hour from the e-commerce staging site into S/4HANA. Monitor transaction SMQ2 for inbound queue bottlenecks. If your system cannot handle the web volume during testing, it will crash your production sales dock on day 1.
Scenario 156. Revenue accounting and reporting integration not reconciled.
In the realize phase of an ECC to S/4HANA migration, organizations moving to SAP revenue accounting and reporting or RAR often fail to reconcile the historical recognized revenue. Because S/4HANA deprecates legacy SD revenue recognition, the inception-to-date revenue must be perfectly migrated into the new contract-based model. If the reconciliation testing ignores the balance between legacy table VBREV and the new RAR subledger, the organization will face massive financial variances, audit flags, and incorrect revenue catch-up postings during the first month-end close.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial compliance and revenue integrity risk. 2. Phase, realize. 3. Frequency, common in industries with milestone billing or service contracts. 4. Primary ownership SD and FICO lead, the person who owns this and gets fired if it fails. 5. Supporting data migration lead and revenue accountant. 6. Business ownership corporate controller. 7. Relevant SAP note. SAP note 2267319 and SAP note 2225170. Revenue recognition transition.
Diagnostic dashboard, symptoms and evidence.
How RAR reconciliation gaps manifest during integration testing. 1. Symptom: total recognized revenue in S/4HANA report FRR_TM00 does not match the audited ECC revenue for the same set of contracts. 2. Red flag: the revenue accounting item or RI monitor shows thousands of items processed with warnings regarding inception to date mismatches. 3. Business impact: inability to certify quarterly earnings because the migration baseline for deferred revenue is technically unauditable. 4. Detection: comparing the balance of the deferred revenue GL account against the SUM of the RR contract liabilities reveals a variance. 5. Technical proof: logs in the transition workbench show that the recognized revenue field was left blank during the legacy data load. Insight: revenue migration is not a data copy. It is a financial revaluation of every open contract in the company.
Why this happens, scenario analysis and root cause.
1. Legacy SD revenue recognition was account-based, GL-centric, while SAP RAR is contract-based, event-centric, creating a data granularity gap. 2. Testing teams focus on new orders and ignore the in-flight contracts that have 5 years of historical revenue recognized in ECC. 3. A lack of inception-to-date or ITD logic in the migration scripts, causing S/4HANA to think no revenue has ever been recognized for the order. 4. Failure to perform a financial dry run where a full year of historical events is resimulated in the new engine. The failure is a result of treating revenue recognition as a functional setting rather than a financial data transformation.
Why this is a migration, exclusive failure.
1. In ECC upgrades, the revenue engine never changed. VBREV remained the stable source of truth for recognized values. 2. S/4HANA migration physically deactivates the old SDREV submodule, making it impossible to continue using legacy schedules. 3. The requirement to bridge legacy GL balances with new performance obligation or POB balances is a unique migration hurdle. 4. This failure only surfaces when the system transition tool attempts to reconcile the historical subledger with the new universal journal. Migration forces a rebaselining of the company's revenue history that ECC never required.
Financial and customer impact.
1. Material financial risk, as the company may incorrectly double post or miss revenue recognition, leading to restatements. 2. Delayed month-end close, as accountants must manually reconcile thousands of contracts in Excel to explain migration variances. 3. Customer disputes if revenue-based billing, like service milestones, is incorrectly calculated by the new untested logic. 4. Loss of management confidence in the S/4HANA system if the revenue growth reports do not align with historical ECC trends. Revenue reconciliation failures are the most frequent cause of qualified audit opinions post-migration.
Governance and accountability, RACI model.
Securing revenue integrity requires a partnership between SD, FI, and audit. 1. Accountable SD and FICO lead, the person who owns this and gets fired if it fails. 2. Responsible revenue accountant defines the reconciliation baseline and extracts the audited revenue history from ECC. 3. Consulted external auditors validate the migration methodology for IFRS 15 and ASC 606 compliance. 4. Informed CFO monitors the financial accuracy and signs off on the final revenue balance migration. Accountability ensures that technical success does not violate accounting standards.
Ownership, who actually fixes it.
Resolving this requires a value match audit and technical mapping. 1. SD functional lead identifies every open revenue contract and ensures the SD item categories correctly trigger the RI monitor. 2. FICO lead configures the SAP RAR transition method and defines the performance obligation derivation rules. 3. Data migration team loads the inception-to-date revenue history into the RAR staging tables. 4. Revenue accountant performs a cent-by-cent reconciliation between ECC table VBREV and S4HANA table FRR_D_contract.
Who gets blamed versus who owns it?
1. Blamed. SD lead the business assumes the sales order is failing to pass data to accounting. 2. Blamed. SAP the finance team claims the RAR engine is too complex and produces random numbers. 3. Actual owner, SD and FICO lead responsible for the failure to establish a financial baseline prior to migration. 4. Root cause, treating revenue migration as a technical IT task rather than a core financial audit requirement. A revenue error is a governance failure, not a software bug.
How this is actually fixed, the right way by a role.
1. SD and FICO lead mandate a revenue freeze in ECC 48 hours before the final snapshot to ensure a clean source baseline. 2. The team implements automated reconciliation reports that compare the legacy GL balance to the new RAR contract subledger. 3. ABAP lead refactors the SD to RAR interface baddies to ensure all custom SD attributes needed for contract derivation are passed. 4. Functional leads execute a modification test, verifying that cancellations or price changes in SD correctly reallocate revenue in RAR.
What not to do, common wrong fixes.
1. Do not allow the go-live to proceed until the revenue variance is 0% or explained and approved by audit. 2. Do not use manual journal entries in S4HANA to fix a revenue subledger error. This destroys the document-level audit trail. 3. Do not assume that the migration cockpit will automatically calculate the inception-to-date revenue correctly. 4. Do not skip the testing of bundled sales, where revenue must be allocated across multiple items based on standalone selling prices. Shortcuts in revenue reconciliation result in a financial disaster that the CFO cannot defend.
Follow-up 1. What is inception-to-date revenue and why is it critical?
Answer: ITD revenue is the total revenue recognized from the start of a contract until the cutover. S4HANA RAR needs this number as a starting point so it can calculate how much revenue is remaining to be recognized. If this is wrong, you will either miss revenue or recognize it twice, violating accounting standards.
Follow-up 2. Why cannot I just use legacy SD Rev Rec in S4HANA?
Answer: because SAP has physically replaced the old tables, VBREK and VBREV, with a compatibility mode that is read-only. You cannot create new schedules or modify existing ones using the old engine. S4HANA is architected for RAR or event-based revenue recognition, and bypassing this is technically unsupported.
Follow-up 3. Curveball. What happens if the business performs a manual revenue adjustment in the legacy ECC system via transaction VF44 after the final migration snapshot has been taken, but before the S4HANA system is live?
Answer: this is a financial leak and a reconciliation failure. The S4HANA RAR contract will be created based on the snapshot, making it out of sync with the legacy GL. You must test the delta-delta reconciliation. You must re-extract the VBREV table one last time after the freeze and apply the difference as a manual RI in S4HANA. If you miss this, your first month-end in S4HANA will show a variance that exactly matches the value of those post-snapshot adjustments, which auditors will flag as a lack of process control.
Exclusive pro tip.
Invite your external auditors to review your revenue reconciliation baseline 4 weeks before the cutover. If they approve the methodology in the sandbox, you avoid a crisis during the first post-migration quarterly audit.
Scenario 157. Group reporting reconciliation not tested.
In the realize phase of an ECC to S4HANA migration, organizations often focus on individual entity testing while ignoring the consolidation layer. S4HANA replaces legacy BPC or SCMBCS with SAP S4HANA Group Reporting, which is integrated directly into the Universal Journal. If the testing plan fails to validate how intercompany sales and SD-based eliminations flow into table ACDOCU, the group-level financial statements will be inaccurate, leading to incorrect profit reporting for the global enterprise.
Scenario classification and relevant SAP note. if applicable?
1. Complexity, high global financial integrity and consolidation risk. 2. Phase, realize. 3. Frequency, common in multinational corporations with complex intercompany netting. 4. Primary ownership, corporate controller, the person who owns this and gets fired if it fails. 5. Supporting SD functional lead and FICO lead. 6. Business ownership, group finance director. 7. Relevant SAP note. SAP note 2349298 and SAP note 2461837. Universal Journal and Group Reporting.
Diagnostic dashboard, symptoms and evidence.
How group reporting gaps manifest during integration testing. 1. Symptom. Group-level P and L reports show duplicated revenue for intercompany sales because the elimination rules did not trigger. 2. Red flag. The group reporting monitor, transaction CX18, shows thousands of documents in error status for the data collection task. 3. Business impact. Inability to produce consolidated financial statements, delaying public earnings calls and investor reporting. 4. Detection, comparing the consolidated revenue in S/4HANA against the SUM of the individual sales organizations reveals a mismatch. 5. Technical proof, custom SD attributes like trading partner are missing from the ACDOC align items, causing the group reporting engine to skip the record. Insight in S/4HANA group reporting is continuous. If the SD data is wrong, the group financials are wrong in real time.
Why this happens, scenario analysis and root cause.
1. SD consultants treat intercompany sales as a logistics process and fail to realize that specific fields, like partner sales org, are mandatory for group elimination. 2. The project team assumes that real-time consolidation happens automatically without needing to test the release data task. 3. Legacy intercompany clearing accounts were not correctly mapped to the new S/4HANA financial statement items or FS items. 4. Underestimating the impact of currency conversion. S/4HANA group reporting performs conversion at the transaction level, which may differ from legacy BPC logic. The failure is a result of a siloed testing approach that ignores the corporate consolidation of sales data.
Why this is a migration, exclusive failure.
1. In ECC, consolidation was an offline process. You extracted data to an external system, which allowed you to fix data errors manually. 2. S/4HANA migration moves the organization to embedded group reporting, where errors in the SD document flow block the consolidation monitor immediately. 3. The technical move from table BSEG to ACDOCA/ACDOCU is a one-time transformation required only for the S/4HANA transition. 4. This failure only surfaces when the organization attempts its first global consolidation in the converted S/4HANA environment. S/4HANA removes the buffer between the local sale and the group financial statement.
Financial and customer impact.
1. Overstatement of group revenue leads to material misstatements and potential legal penalties for the board of directors. 2. Loss of management visibility into the actual profitability of different sales regions due to uneliminated intercompany markups. 3. Audit costs increase as the consolidation team must manually force eliminate thousands of records to close the books. 4. Strategic decisions are based on dirty, consolidated data, leading to incorrect resource allocation across global business units. Group reporting failures directly jeopardize the financial credibility of the global enterprise.
Governance and accountability, RACI model.
Securing group reporting requires a local-to-global testing strategy. 1. Accountable corporate controller, the person who owns this and gets fired if it fails. 2. Responsible FICO and SD functional lead jointly ensure that intercompany sales documents contain all mandatory group reporting attributes. 3. Consulted consolidation lead provides the elimination logic and validates the final group financial statement accuracy. 4. Informed group finance director monitors the consolidation status as a key go-live success metric. Accountability ensures that the local order is always consolidation ready.
Ownership, who actually fixes it.
Resolving this requires an intercompany and elimination logic audit. 1. Consolidation lead identifies all intercompany sales document types and maps them to specific elimination profit centers. 2. SD functional lead refactors the partner determination logic to ensure the trading partner field is automatically populated from the BP master. 3. FICO lead ensures the financial statement items are correctly assigned to the SD account keys in transaction VKOA. 4. The team performs an end-to-end consolidation run in the sandbox, tracing a local sale through to the group-level ACDOCU table.
Who gets blamed versus who owns it?
1. Blamed. SD lead the group finance team assumes the sales orders were set up wrong. 2. Blamed. SAP users claim the group reporting module is not as flexible as legacy BPC. 3. Actual owner. Corporate controller responsible for the failure to define the consolidation requirements during the design phase. 4. Root cause, treating group reporting as a downstream accounting task rather than an integrated part of the O2C cycle. A consolidation error in S/4HANA is usually an upstream data error in SD.
How this is actually fixed, the right way by a role.
1. Corporate controller mandates a consolidation stress test, simulating 10,000 intercompany orders during the SIT phase. 2. The team implements real-time data collection tasks that flag missing consolidation attributes at the moment of invoice save. 3. Technical architect applies SAP Note 2461837 to ensure the S/4HANA Group reporting engine is correctly integrated with the Universal Journal. 4. Functional leads execute matrix eliminations, verifying that sales between two subsidiaries are perfectly eliminated across both profit center and legal dimensions.
What not to do, common wrong fixes.
1. Do not allow intercompany sales to go live without trading partner data, assuming you can fix it later with manual consolidation entries. 2. Do not skip the testing of non-consolidating entities, as they still impact the group's net debt and cash position. 3. Do not assume that legacy company code mapping is sufficient. S/4HANA Group reporting requires mapping at the functional area and segment level. 4. Do not ignore exchange rate variances in consolidation, assuming the local currency is the only one that matters. Shortcuts in consolidation testing lead to a financial black hole at the group level.
Follow-up 1. Why is the trading partner field so important for SD integration?
Answer: the trading partner field, VBUND, is the primary key that group reporting uses to identify which legal entity is on the other side of a sale. If this field is missing from your SD billing document, the consolidation engine cannot link the sale in company A with the purchase in company B, making automatic elimination impossible.
Follow-up 2. What is table ACDOCU, and how does it relate to table ACDOCA?
Answer: ACDOCA is the local universal journal where all transactions land. ACDOCU is the group journal. When you run the data collection task, the system copies and transforms data from ACDOCA to ACDOCU. This is where the consolidated group view of your SD data lives.
Follow-up 3. Curveball. How do you handle a multi-currency intercompany sale where the SD billing rounding rule in the selling company entity A differs from the group currency conversion rule in the consolidation layer, causing a non-zero balance in the elimination entry?
Answer: this is a precision divergence failure. S/4HANA Group reporting performs eliminations in group currency. If the SD pricing routine rounds to 2 decimals in local currency, but the consolidation engine uses 5 decimals for group conversion, an elimination variance will appear. You must test the rounding and translation rules in the group reporting workbench. The fix is to implement a consolidation rounding rule that matches the SD pricing routine precision, ensuring that the intercompany revenue and cost of goods sold eliminate exactly to 0 in the consolidated balance sheet.
Exclusive pro tip.
Add a consolidation monitor task to your SIT exit criteria. The SD team must prove that every intercompany test scenario was released to group reporting without technical error. If the local sale cannot be consolidated in the test system, your global P&L is a risk on day 1.
Category 2 wrap-up. Integration testing.
Category 2 has exposed the vulnerability of the modular handshake. We analyzed how misaligned sequences between SD and FI, as well as gaps in EWM and TM connectivity, can paralyze the digital core. The lesson is that S/4HANA integration is synchronous and strict. A failure in one module is now a failure in all. Validating the end-to-end data flow is no longer optional. It is the only way to guarantee a functional supply chain.
Transition to Category 3, non-functional testing.
Even if every individual transaction works perfectly, the system can still collapse under pressure. In Category 3, we move from what the system does to how it performs. We will analyze the non-functional testing incidents, focusing on volume bottlenecks, HANA performance regressions, and the stress limits of the new ABAP and output engines. This is the stage where we separate a functioning system from a production-ready enterprise solution.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Category 3, non-functional testing.
Category 3 addresses the risk of system instability at scale. Many organizations fail because they test in clean environments with low data volumes. In S/4HANA, the HANA database and the application server must be tuned to handle massive parallel processing for billing and delivery. We will examine why volume testing is the most frequently ignored safety gate and how unoptimized pricing scales or output runtimes can crash the system on day 1.
Category 3 incident list, non-functional testing.
The following incidents represent failures in system performance, load stress, and architectural throughput. 158. Volume testing missing. Relevant SAP note not applicable test strategy and execution. 159. Performance testing unrealistic. Relevant SAP note not applicable performance testing strategy failure. Reference SAP note 1912445 for context. 160. Parallel processing not tested. Relevant SAP note not applicable test strategy and execution. 161. Advanced ATP load scenarios missing. Relevant SAP note 2321191. 162. Mass billing not tested. Relevant SAP note not applicable test strategy and execution. 163. Pricing scale performance not stress tested. Relevant SAP note 2267308. 164. BRF plus output runtime not tested. Relevant SAP note 2228611. Category 3 incidents often remain hidden until the system is under full production load.
Scenario 158, volume testing missing.
In the realize phase of an ECC to S/4HANA migration, the project team often signs off on testing based on SING LETR transaction success. However, they fail to perform a dedicated volume test representing a full production day. S/4HANA handles data transformation in real time, which places a high load on the HANA CPU and memory. Without simulating peak volumes for sales order creation and mass billing, the organization will face system-wide freezes and database lock-weight errors, as soon as the full user population logs in.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high system stability and performance risk. 2. Phase realize. 3. Frequency, extremely common in large global rollouts. 4. Primary ownership, test lead and performance manager, the person who owns this and gets fired if it fails. 5. Supporting basis lead and SD functional lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note, not applicable test strategy and execution. This is a technical governance and resource planning failure.
Diagnostic dashboard, symptoms and evidence.
How volume gaps manifest during the move to production. 1. Symptom, response times for transaction VA01 degrade from 1 second to 30 seconds when more than 50 concurrent users are active. 2. Red flag, the performance testing environment contains less than 10% of the production data volume. 3. Business impact, warehouse operations halt because the system cannot generate delivery notes fast enough to keep up with the physical packing line. 4. Detection, monitoring transaction SD06 shows 100% CPU utilization on the HANA appliance during the first mini-volume test. 5. Technical proof, database logs show thousands of record lock contentions on table PRCD_elements that were never seen during unit testing. Insight, if you do not stress test the pipe, you will not know it is clogged until the production water is turned on.
Why this happens, scenario analysis and root cause.
1. Project teams treat performance testing as an optional activity that can be squeezed into the final week of the integration test cycle. 2. Lack of a production-size performance client because the organization wanted to save on HANA hardware costs during the project. 3. Failure to simulate the background noise of production, such as inbound EDI interfaces and real-time Fiori analytical refreshes. 4. The assumption that HANA is so fast that volume testing is a legacy ECC requirement that is no longer relevant. The failure is a result of overconfidence in hardware speed at the expense of architectural validation.
Why this is a migration, exclusive failure.
1. ECC upgrades occurred on established hardware where the volume performance was already known and stabilized over years. 2. S/4HANA migration involves a move to a columnar database where the SQL execution plans are completely different for mass data sets. 3. The transition to AATP and Fiori introduces new memory-resident processes that consume significantly more RAM than legacy ECC transactions. 4. This failure only surfaces when the new HANA engine encounters the true concurrency and volume of the live enterprise. Migration introduces a new performance profile that requires a new testing baseline.
Financial and customer impact.
1. Revenue loss occurs as customer service reps are unable to enter orders during peak hours, leading to abandoned sales. 2. Delayed shipments result in contractual penalties for late delivery to large retail partners. 3. Increased total cost of ownership as the organization is forced into an emergency hardware upgrade to compensate for untested software performance. 4. Loss of brand reputation if the public-facing webshop crashes due to the S/4HANA backend being overwhelmed. Volume failures turn a technical milestone into a public business embarrassment.
Governance and accountability, RACI model.
Securing system stability requires a dedicated performance authority. 1. Accountable test lead and performance manager, the person who owns this and gets fired if it fails. 2. Responsible basis lead provisions the performance environment and monitors the database KPIs during stress tests. 3. Consulted SD functional lead provides the peak hour transaction profile, such as 5,000 orders per hour. 4. Informed IT transformation director manages the go-no-go decision based on the performance test report. Accountability ensures that performance is a hard exit gate for the realize phase.
Ownership, who actually fixes it.
Resolving this requires a volume simulation strategy. 1. The performance manager utilizes tools like SAP Load Runner to simulate hundreds of concurrent users performing O2C tasks. 2. The basis lead monitors HANA thread health and identifies unoptimized SQL statements during the stress run. 3. The SD functional lead validates that batch processing for deliveries can run in parallel without causing database deadlocks. 4. The technical architect refactors any custom code identified as a performance bottleneck during the high-volume simulation.
Who gets blamed versus who owns it?
1. Blamed basis team. The business assumes the servers are too small. 2. Blamed SAP users claim S/4HANA is slower than ECC. 3. Actual owner, test lead and performance manager responsible for the failure to define and execute a production-scale stress test. 4. Root cause, testing in a vacuum without considering the physics of mass data concurrency. Blame targets the hardware. Ownership targets the test strategy.
How this is actually fixed, the right way by a role.
1. The performance manager mandates a performance SIT cycle using a one-to-one copy of production data volume. 2. The team implements workload distribution, ensuring Fiori analytical users and SAP GUI transactional users are not saturating the same application server. 3. The basis lead applies SAP Note 1912445 to optimize the HANA parameter settings for high-volume SD environments. 4. Functional leads execute peak volume testing, simulating the busiest day of the year, such as Black Friday, before go live.
What not to do, common wrong fixes.
1. Do not accept extrapolated performance results from a 10% volume test. 2. Do not assume that adding more HANA RAM will fix a row-level locking issue in the application code. 3. Do not skip the testing of auto-invoicing background jobs during the volume run. 4. Do not allow the go-live to proceed until the system proves it can handle 120% of the current peak ECC volume. Shortcuts in volume testing will lead to a day one system meltdown.
Follow-up 1. Why is volume testing more critical in S/4HANA than it was in ECC?
Answer: in ECC, data was often processed in batches, and the row store database was less sensitive to parallel thread counts. S/4HANA is designed for real-time everything. If you have 500 users running real-time CDS-based Fiori dashboards while 200 users are entering orders, the contention for HANA CPU resources is much higher than in the ECC world.
Follow-up 2. How do I find a production-sized test environment if I do not have the budget?
Answer: you do not necessarily need the full hardware permanently. You can use cloud elasticity, such as AWS or Azure, to spin up a production-grade HANA instance for 2 weeks of performance testing. The cost of this temporary instance is a fraction of the cost of a failed go-live.
Follow-up 3. Curveball. What if the database performance is excellent, but the application layer ICM or gateway times out during a mass web order sync because the thread count was not tuned for S/4HANA volume?
Answer: this is the gateway bottleneck trap. S/4HANA uses OData and REST APIs heavily. If your basis team tuned the HANA database but left the SAP gateway thread parameters at legacy ECC levels, the wait time in the Internet Communication Manager, or ICM, will spike. You must perform full-stack volume testing that includes the network, the gateway, the application server, and the database to identify these hidden bottlenecks.
Exclusive pro tip.
Establish a performance budget for your top 10 SD transactions. If VA01 takes more than 2 seconds to save during a 500-user stress test, the project is forbidden from go live. Use this objective data to stop the "it feels fast enough" subjective arguments.
Scenario 159. Performance testing unrealistic.
In the realize phase of an ECC to S/4HANA migration, performance testing is often conducted under artificial conditions. Teams test simple sales orders with one line item and no pricing complexity. In the real world, SD documents often contain hundreds of lines, tiered pricing scales, and complex credit checks. If the performance testing is unrealistic and fails to simulate the dirty data and transaction depth of production, the HANA database will experience severe thread congestion post-go-live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high runtime integrity and resource management risk. 2. Phase realize. 3. Frequency, very common in systems with complex pricing and ATP logic. 4. Primary ownership, test lead and performance manager, the person who owns this and gets fired if it fails. 5. Supporting ABAP lead, HANA and SD functional lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note, not applicable test strategy and execution. Reference SAP Note 1912445 for HANA behavior context.
Diagnostic dashboard, symptoms and evidence.
How unrealistic testing manifests during the first week of operations. 1. Symptom: simple orders are fast, but intercompany or export orders take 2 minutes to save and eventually timeout. 2. Red flag: the test scripts use the same 10 standard materials for all 1,000 test orders, resulting in false cache performance. 3. Business impact: high-value strategic orders, which are usually the most complex, are the only ones failing, leading to a loss of key account revenue. 4. Detection: checking transaction STAD reveals that database request time is low, but ABAP processing time for pricing is extremely high. 5. Technical proof: HANA Studio shows specific columnar scans are hitting the memory limit when processing large document headers in table VBAK. Insight: if your test data is clean, your performance results are lies.
Why this happens, scenario analysis and root cause.
1. Testing teams use synthetic data created by scripts rather than scrambled production data, which contains real-world complexity. 2. A failure to simulate document depth, where a sales order has 200 items, each triggering a separate ATP and price check. 3. Failure to include integration load in the performance test, such as real-time calls to Vertex or an external warehouse system. 4. Relying on average response times instead of 95th percentile times. The average hides the catastrophic outliers. The failure is a result of a testing philosophy that values pass rates over operational reality.
Why this is a migration, exclusive failure.
1. Legacy row store databases in ECC handled large documents sequentially. HANA processes them using parallel columnar threads. 2. Unoptimized legacy ABAP code using select star is penalized by HANA much more severely when the document depth is high. 3. The new S/4HANA pricing engine in table PRCD_elements has a different memory footprint for complex scales compared to the ECC cluster model. 4. This failure only surfaces when the new code-to-data architecture encounters the real-world complexity of the legacy business. HANA amplifies the performance gap between simple and complex code.
Financial and customer impact.
1. Revenue leakage, as complex orders are abandoned by users who cannot wait for the system to respond. 2. Inaccurate financial accruals if the performance timeouts result in partial document saves or broken database updates. 3. High cost of emergency code refactoring after go live when the organization realizes the system cannot handle their real business. 4. Damaged employee morale, as sales reps feel the new advanced system is a step backward in productivity. Unrealistic testing results in a system that is technically live but operationally dead.
Governance and accountability, RACI model.
Ensuring realism requires a cross-functional validation of test data. 1. Accountable test lead and performance manager, the person who owns this and gets fired if it fails. 2. Responsible SD functional lead must curate a representative set of production copy data for testing. 3. Consulted ABAP lead HANA identifies the technical complexity drivers in the code that must be stress tested. 4. Informed IT transformation director manages the stakeholders' expectations regarding real-world response times. Accountability ensures that success is measured against reality, not a lab environment.
Ownership, who actually fixes it.
Resolving this requires a production copy testing methodology. 1. The performance manager mandates that 30% of all performance test orders must have more than 50 line items. 2. The SD functional lead identifies the top 5 most complex customers by pricing rules to be used as test personas. 3. The ABAP lead uses SQL Monitor or SQLM to trace the worst-case transactions during the stress run. 4. The basis lead ensures that buffer swapping is monitored to ensure the system does not run out of memory during complex calculations.
Who gets blamed versus who owns it.
1. Blamed SD lead: the business assumes the functional design is inefficient. 2. Blamed ABAP developers executives assume the custom code is slow. 3. Actual owner test lead and performance manager responsible for the failure to mandate data realism in the test plan. 4. Root cause, treating performance testing as a box-ticking exercise with easy data. A performance outlier is a testing failure, not a coding bug.
How this is actually fixed, the right way by a role.
1. The test lead mandates the use of productivity scenarios where real users perform a series of complex interlinked tasks. 2. The team implements percentile-based SLAs, requiring that 95% of all transactions save in under 3 seconds. 3. The SD team utilizes SAP Note 19124445 to ensure that HANA-optimized coding patterns are followed for all complex routines. 4. The project team execute a chaos test, where they intentionally flood the system with the 50 most complex orders while a background job is running.
What not to do, common wrong fixes.
1. Do not allow the performance team to use looping scripts that only touch the same data repeatedly. This artificially inflates performance via caching. 2. Do not skip the testing of export control checks for international orders during the performance run. 3. Do not assume that because the average time is 1 second, the system is fine. You must find the document that takes 60 seconds. 4. Do not allow go live until the worst-case scenario is proven to be stable under peak load. Shortcuts in testing realism will result in a performance crisis that cannot be solved by tuning.
Follow-up 1. Why is data diversity so important for HANA performance testing?
Answer: HANA uses data compression and caching. If you test with the same customer and material 1,000 times, HANA will keep that data in the hot cache, giving you a lightning-fast result that is impossible in production. You must use diverse data to force HANA to perform real-time memory reads and columnar scans.
Follow-up 2. What is the 95th percentile, and why is it better than the average?
Answer: the average can be skewed by thousands of fast, simple orders. The 95th percentile shows you the experience of your users with the most complex 5% of orders. If the average is 1 second but the 95th percentile is 40 seconds, you have a major architectural bottleneck that will cause user complaints and system locks.
Follow-up 3. Curveball. What if the performance results are excellent for all standard O2C transactions, but the system crashes when a user attempts a global sales search across 10 years of history using a custom CDS-based Fiori app?
Answer: this is a columnar scan failure. CDS views are incredibly fast, but they can saturate the HANA CPU if they are forced to scan billions of rows without proper filtering or data aging. You must test the reporting load alongside the transactional load. If your analytics apps are not restricted by a time filter, they will act as a denial of service attack against your own database during the business day. You must implement mandatory filters in all SD-based CDS views.
Exclusive pro tip.
Perform a document depth audit of your production ECC system. Find the top 1% of documents with the most line items. Mandate that these exact documents, or their equivalents, be used as the stress items for every performance test run. If you cannot save your biggest order, you cannot go live.
Scenario 160. Parallel processing not tested.
In the realize phase of an ECC to S/4HANA migration, organizations often fail to validate the system's ability to handle parallel work processes for mass SD activities. Transactions like mass billing, collective delivery creation, and backorder processing utilize server groups to distribute load. If the testing strategy ignores parallel processing settings, the production system will experience massive database deadlocks and kernel-level task congestion during the first nightly batch run, paralyzing the morning shipment wave.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high system throughput and basis stability risk. 2. Phase, realize. 3. Frequency, common in high-volume environments with complex job schedules. 4. Primary ownership, test lead and performance manager, the person who owns this and gets fired if it fails. 5. Supporting basis lead and ABAP custom code remediation lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note, not applicable test strategy and execution. This is a technical orchestration and resource management failure.
Diagnostic dashboard, symptoms and evidence.
How parallel processing gaps manifest during volume testing. 1. Symptom, mass billing jobs VF04. Start 10 parallel threads, but 8 of them fail immediately with the error resource bottleneck. 2. Red flag, technical logs in transaction SM12 show thousands of locks held by a single background user ID during a collective run. 3. Business impact. Nightly O2C processing windows exceed 8 hours, causing background jobs to collide with the morning login of warehouse staff. 4. Detection. Checking transaction RZ12 reveals that the parallel processing server groups have not been configured for the new S/4HANA application servers. 5. Technical proof. System dumps call _function_send_error when attempting to trigger an asynchronous RFC for a mass delivery split. Insight. Parallel processing is a force multiplier. If the math behind your thread allocation is wrong, you multiply the errors, not the speed.
Why this happens, scenario analysis and root cause.
1. Testing is performed in a single-user mode, where the system has 100% of the work processes available for one task. 2. Failure to define the max percentage of work processes for background groups, leading to the O2C batch job starving the rest of the system. 3. The project team assumes that HANA's speed removes the need for application layer parallelization. In reality, the ABAP layer still has thread limits. 4. Underestimating the impact of shared buffer contention when 20 parallel threads all attempt to read the same pricing condition tables. The failure is a result of treating S/4HANA as an infinite resource rather than a finite technical engine.
Why this is a migration, exclusive failure.
1. Legacy ECC systems on Oracle or SQL Server were often CPU-bound, whereas S/4HANA on HANA is frequently memory-bound or thread-bound. 2. S/4HANA introduces new task frameworks for parallelizing revenue recognition and AATP, which require a redesign of server group allocations. 3. The move to SAP Fiori increases the number of concurrent short tasks, which can conflict with legacy long-running parallel SD jobs. 4. This failure only surfaces when the new application server architecture encounters the full parallel workload of the production ECC environment. Migration requires a retuning of the orchestra, work processes, to match the new stage, HANA.
Financial and customer impact.
1. Revenue leakage if nightly billing jobs fail to complete, delaying invoices by 24 hours or more during critical month-end periods. 2. Warehouse idle time costs skyrocket as picking teams wait for collective delivery jobs that are stuck in a technical deadlock. 3. Inaccurate inventory levels result from interrupted goods issue tasks, leading to out-of-sync stock messages on the web shop. 4. Risk of duplicate invoicing if unhandled parallel errors lead to jobs being restarted without proper data cleanup. Parallel processing failures turn the high-speed S/4HANA core into an operational bottleneck.
Governance and accountability, RACI model.
Securing system throughput requires coordination between performance and basis leads. 1. Accountable, test lead and performance manager, the person who owns this and gets fired if it fails. 2. Responsible, basis lead configures the RFC server groups and monitors work process consumption during parallel runs. 3. Consulted, SD functional lead identifies the peak mass processing scenarios, for example, 50,000 invoices in a single batch. 4. Informed, IT transformation director manages the performance sign-off for the realize phase. Accountability ensures that technical settings are validated against business-critical throughput volumes.
Ownership, who actually fixes it.
Resolving this requires a full-load parallelization audit. 1. The performance manager mandates a batch stress test where multiple SD mass processing jobs are triggered simultaneously. 2. The basis lead utilizes transaction SRFC to monitor the utilization of server groups and adjust the max request parameters. 3. The SD functional lead configures the parallel processing flags in the billing and delivery creation variants. 4. The technical architect reviews the asynchronous RFC logic in custom SD enhancements to ensure they handle resource_failure exceptions.
Who gets blamed versus who owns it.
1. Blamed, basis team the business assumes the hardware is failing under the load. 2. Blamed, SAP users claim S/4HANA cannot handle our transaction volume. 3. Actual owner, test lead and performance manager responsible for the failure to simulate concurrent parallelism during testing. 4. Root cause, treating individual job performance as success without testing for modular collision. The failure is not the speed of the car, but the width of the road.
How this is actually fixed, the right way by a role.
1. The performance manager establishes a mass processing gate. All nightly batch scenarios must be tested with 100% production volume. 2. The basis lead implements server group isolation, ensuring that critical SD jobs have dedicated work processes that cannot be stolen by Fiori users. 3. The team executes lock contention testing, identifying specific Z tables that cause deadlocks when multiple SD threads attempt to write at once. 4. The project team utilizes SAP Note 1912445 to optimize the DB connection limits for parallel HANA threads.
What not to do, common wrong fixes.
1. Do not simply increase the number of threads. This often exacerbates database locking and makes the system even slower. 2. Do not ignore failed background tasks in transaction SM58. These are often the first sign of a parallel processing bottleneck. 3. Do not use the standard server group for all tasks. You must create specific groups for dialog first and batch first operations. 4. Do not skip the testing of rollback scenarios. If 5 out of 10 threads fail, the system must remain in a consistent state. Ignoring parallel processing limits will result in a total system lockout on day 1.
Follow-up 1. Why is transaction RZ12 so critical for S/4HANA SD testing?
Answer: RZ12 is where you define RFC server groups. In S/4HANA, many SD activities are triggered via Fiori and processed asynchronously in the background. If your RZ12 groups are not tuned to balance the dialog and batch work processes, a single mass billing run could consume all available threads, preventing any user from logging into the system.
Follow-up 2. What is a database deadlock, and why is it more common in unoptimized parallel processing?
Answer: a deadlock happens when thread A locks table 1 and wants table 2, while thread B locks table 2 and wants table 1. In S/4HANA, because the data model is flattened, for example, status is now in the header. The frequency of 2 threads trying to update the same row in table VBAK simultaneously is much higher than in ECC.
Follow-up 3. Curveball. How do you handle a scenario where parallel processing for collective billing, VF04, works perfectly on an application server with 64 CPU cores, but fails with system resource exhausted on an asymmetrical standby server with only 16 cores during a high-volume cutover event?
Answer: this is a hardware asymmetry failure. S/4HANA server groups must be resource-aware. You must test the dynamic workload distribution logic. If your test scripts used a static thread count, for example, always use 20 threads, the small server will crash. The fix is to configure the server group to use a percentage of available work processes rather than a fixed integer. You must explicitly test the failover scenario during SIT to ensure that if the primary app server fails, the smaller standby server throttles the O2C load, rather than attempting to process it all and crashing the kernel.
Exclusive pro tip.
Perform a global batch lock audit during the realize phase. Identify every SD background job that runs in parallel and map their shared database tables. Use transaction DB01 during a stress test to catch wait situations before they become production deadlocks.
Scenario 161. Advanced ATP load scenarios missing.
In the realize phase of an ECC to S/4HANA migration, organizations moving to the advanced ATP engine often fail to test the memory-intensive nature of real-time stock allocation. S/4HANA ATP is a memory-resident service that processes millions of requirements in the HANA layer. If the testing scope fails to simulate peak concurrency, where hundreds of sales reps and webshop interfaces trigger availability checks simultaneously, the ATP engine will exceed its allocated HANA memory quota, leading to zero stock confirmations and system-wide order entry failures.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high supply chain continuity and HANA resource risk. 2. Phase, realize. 3. Frequency, common in retail, consumer goods, and wholesale industries. 4. Primary ownership, SD functional lead and performance manager, the person who owns this and gets fired if it fails. 5. Supporting basis lead and supply chain architect. 6. Business ownership, supply chain planning director. 7. Relevant SAP note. SAP note 2321191. Advanced ATP simplifications.
Diagnostic dashboard, symptoms and evidence.
How ATP load failures manifest during system validation. 1. Symptom: during a 500-user stress test, sales orders for hot materials suddenly return zero confirmed quantity despite stock being available. 2. Red flag: HANA cockpit alerts show the product availability check or PSC service consuming 90% of the dedicated ATP memory pool. 3. Business impact: inability to fulfill customer orders during high-demand events like product launches, leading to massive revenue loss. 4. Detection: checking the ATP monitor reveals thousands of sessions in waiting status for the ATP dispatching thread. 5. Technical proof: system log errors referencing memory allocation failed for ATP component during a collective backorder processing run. Insight: ATP is a high-performance engine that trades HANA RAM for allocation speed. If you do not budget the RAM correctly, the engine stops.
Why this happens, scenario analysis and root cause.
1. Testing is performed with a small set of materials, failing to simulate the global search impact on the HANA memory buffer. 2. The project team fails to account for the characteristic-based complexity of ATP, where every rule evaluation consumes more CPU than classic ECC ATP. 3. A lack of testing for asynchronous BOP, where the system must hold stock allocations in memory for thousands of orders, while the main transaction is still open. 4. Basis teams often use standard S/4HANA sizing without adjusting for the specific memory per item overhead of the ATP product availability check. The failure is a result of treating a memory-resident engine as a legacy table-based process.
Why this is a migration, exclusive failure.
1. ECC ATP was table-based table VBBE. It was slow, but it never ran out of memory. It simply used disk space. 2. S/4HANA ATP is the first time stock allocation has been moved to a dedicated memory-resident engine in the SAP core. 3. The shift from classic rescheduling V_V2 to ATP backorder processing BOP is a one-time architectural transition. 4. This failure only surfaces when the new ATP engine encounters the true data breadth and depth of the enterprise production environment. Migration forces a transition from I/O-bound availability checks to memory-bound availability logic.
Financial and customer impact.
1. Revenue leakage occurs as high-value customers are denied stock because the ATP engine timed out during the protection evaluation. 2. Operational stop shipments during peak events, forcing the business into manual stock rationing using Excel. 3. Loss of customer trust as the webshop shows in stock, but the S/4HANA backend returns zero due to engine load. 4. Significant costs for emergency hardware expansion, as the organization realizes the HANA appliance is undersized for ATP. ATP load failures directly paralyze the company's ability to commit to its customers.
Governance and accountability, RACI model.
Securing ATP performance requires an integrated supply chain and IT gatekeeper. 1. Accountable SD functional lead and performance manager, the person who owns this and gets fired if it fails. 2. Responsible supply chain architect defines the BOP segments and checking rules that drive memory consumption. 3. Consulted basis lead monitors the HANA memory consumption of the ATP service PSC during load testing. 4. Informed supply chain planning director validates that the system can handle the nightly reallocation of 100,000 orders. Accountability ensures that functional complexity is balanced against technical system limits.
Ownership, who actually fixes it.
Resolving this requires an engine-aware stress testing strategy. 1. The performance manager mandates an ATP-only stress run, triggering availability checks for 1,000 unique materials simultaneously. 2. The basis lead utilizes transaction NSILC to monitor the memory footprint of the ATP product availability check service. 3. The SD functional lead refactors the BOP segments to ensure that only critical materials are checked during the hourly runs. 4. The technical architect applies SAP Note 2321191 to optimize the thread distribution of the ATP engine on the HANA database.
Who gets blamed versus who owns it.
1. Blamed. SD lead the business assumes the availability logic was configured incorrectly. 2. Blamed basis team users claim the system is slow because the ATP check takes 10 seconds. 3. Actual owner, SD functional lead and performance manager responsible for the failure to simulate peak availability concurrency. 4. Root cause, underestimating the HANA memory required to solve complex multidimensional stock allocation rules. A timeout in ATP is a testing failure, not a master data bug.
How this is actually fixed, the right way by a role.
1. The SD functional lead mandates a BOP performance run using the actual production order set to measure memory peaks. 2. The team implements supply protection, or SUP, carefully, ensuring the rules are not so complex that they trigger a combinatorial explosion in HANA. 3. The basis lead configures a dedicated HANA service for a TP to prevent it from crashing the main database service during a load spike. 4. Functional leads execute collision testing, where 2 sales reps compete for the last unit of stock to verify the real-time consistency of the buffer.
What not to do, common wrong fixes.
1. Do not disable the advanced features of a TP to fix a performance issue. You are throwing away the ROI of the migration. 2. Do not assume that classic rescheduling test scripts are sufficient for a TP. The engines are completely different. 3. Do not allow the go-live to proceed if the ATP check for a 100-line order takes more than 3 seconds during a load test. 4. Do not skip the testing of alternative plant substitution under load. Searching multiple plants is the most memory-intensive ATP task. Shortcuts in ATP load testing result in a day 1 supply chain blackout.
Follow-up 1. Why does ATP require its own memory management strategy?
Answer: because ATP uses a technology called Product Availability Check, or PAC, which loads the entire stock and requirement situation into the HANA RAM. Unlike other modules that read and release data, ATP must keep this data in sync and hot for milliseconds-level response times, making it a major consumer of system resources.
Follow-up 2. What is the risk of having too many BOP segments in S/4HANA?
Answer: every BOP segment is a separate logic pass for the engine. If you have too many segments, the system must perform multiple resorting and reallocation loops. Under load, this can cause the BOP background job to exceed its runtime window, leading to out-of-sync stock confirmations for the morning shipment wave.
Follow-up 3. Curveball. How do you resolve a scenario where ATP results are perfect in the Fiori Manage Sales Orders app during unit testing, but the system triggers a memory limit, reached dump, when the high-volume collective delivery background, job VL10, triggers availability checks for 50,000 items at once?
Answer: this is a transactional batch volume failure. The ATP engine handles single-user Fiori requests using a short-lived thread model. However, mass jobs like VL10 trigger thousands of synchronous PAC calls in a tight loop, saturating the ATP memory buffer before it can release the data from the previous call. You must test the ATP pacing logic. The fix is to configure the parallel processing groups for VL10 to limit the number of concurrent ATP calls, or to increase the HANA memory limit specifically for the ATP service. You must include this mass logistics trigger in your non-functional testing to avoid a day 1 system crash.
Exclusive pro tip.
Before the final technical conversion, go to Transaction NSILC and audit the ATP configuration. Ensure that the parallelization settings are optimized for your HANA hardware core count. If your hardware has 32 cores but ATP is limited to 4, your system will be artificially slow on day 1.
Scenario 162. Mass billing not tested.
In the realize phase of an ECC to S/4HANA migration, the project team often validates individual invoice creation in transaction VF01, but fails to simulate the month-end mass billing tsunami via transaction VF04 or background jobs. Because S/4HANA integrates billing directly into the Universal Journal in real time, the database load for 50,000 concurrent invoices is significantly higher than in ECC. If mass billing is not stress-tested, the system will suffer from record-level locking and log file saturation, causing the first month-end close to fail.
Scenario classification and relevant SAP note. if applicable?
1. Complexity, high financial throughput and system stability risk. 2. Phase, realize. 3. Frequency, common in high-volume wholesale and retail industries. 4. Primary ownership, test lead and performance manager, the person who owns this and gets fired if it fails. 5. Supporting SD functional lead and FICO lead. 6. Business ownership, billing manager. 7. Relevant SAP note, not applicable test strategy and execution. This is a technical volume and throughput validation failure.
Diagnostic dashboard, symptoms and evidence.
How mass billing gaps manifest during volume testing. 1. Symptom, the collective billing background job SD bill DL runs for 12 hours and eventually cancels with a database rejection error. 2. Red flag, unit testing only confirms that one invoice can be saved, ignoring the concurrency of the billing subledger. 3. Business impact, significant delays in revenue collection as the business is unable to transmit thousands of invoices to customers on time. 4. Detection, checking transaction SM12 shows massive lock contention on table ACDOCA during the simulated mass billing run. 5. Technical proof, HANA alerts for log full status, indicating that the database cannot keep up with the volume of real-time financial commits. Insight in S/4HANA, billing is a high-stakes financial event. If you do not test the volume, you have not tested the process.
Why this happens, scenario analysis and root cause.
1. Testing scripts focus on functional accuracy rather than batch throughput, ignoring the reality of the business billing cycle. 2. A lack of production copy data in the test environment, making it impossible to trigger a realistic mass billing event. 3. Underestimating the impact of real-time profitability analysis, which adds additional database write load to every billing line item. 4. The assumption that HANA handles all volume issues automatically, ignoring the application layer bottlenecks in the ABAP stack. The failure is a result of a testing strategy that treats month-end as a collection of individual clicks rather than a system load event.
Why this is a migration, exclusive failure.
1. In ECC, SD billing and FI postings were often separated by a buffer. S/4HANA fuses them into a single synchronous event. 2. The move to the Universal Journal, ACDOCA, significantly increases the number of database inserts per billing document compared to the old BSEG model. 3. Legacy ECC batch schedules for billing may be unoptimized for the new parallel HANA execution architecture. 4. This failure only surfaces when the new financial core encounters the full transactional pressure of the legacy billing volume. S/4HANA enforces a level of data commit intensity that ECC batch jobs never encountered.
Financial and customer impact.
1. Direct impact on cash flow as the company cannot generate invoices, leading to a spike in unbilled receivables. 2. Increased risk of double invoicing if failed batch jobs are manually restarted without proper technical cleanup. 3. Customer disputes arise if consolidated invoicing logic fails under load, sending 500 individual invoices instead of one summary. 4. High cost of war room support during the first month-end close as consultants manually push blocked billing documents. Mass billing failures directly disrupt the company's financial heartbeat and DSO performance.
Governance and accountability, RACI model.
Securing billing throughput requires a link between the billing manager and basis leads. 1. Accountable test lead and performance manager, the person who owns this and gets fired if it fails. 2. Responsible SD functional lead defines the peak billing profile, for example, 100,000 invoices on the last day of the month. 3. Consulted FICO lead validates the accounting impact and ensures profit center and segment derivation can keep up with the load. 4. Informed billing manager confirms that the time to invoice meets the operational business requirements. Accountability ensures that performance is a mandatory sign-off for the revenue engine.
Ownership, who actually fixes it.
Resolving this requires a cycle-based volume test strategy. 1. The performance manager mandates a day-in-the-life stress test where a full 24-hour production workload is compressed into 8 hours. 2. The SD functional lead configures server groups in transaction RZ12 to allow for massive parallel processing of billing documents. 3. The ABAP lead refactors custom pricing routines that are identified as CPU hogs during the mass billing simulation. 4. The basis lead monitors the HANA savepoint duration to ensure the database can commit mass data without freezing the system.
Who gets blamed versus who owns it?
1. Blamed billing team. The business assumes the users are too slow to finish the billing run. 2. Blamed SAP. The project team claims S/4HANA is not as fast as ECC for batch processing. 3. Actual owner, test lead and performance manager responsible for the failure to simulate month-end concurrency. 4. Root cause, treating mass billing as a functional task rather than a technical performance task. The failure is not in the transaction, it is in the throughput design.
How this is actually fixed, the right way by a role.
1. The performance manager mandates an SIT 3-phase dedicated solely to high-volume O2C batch scenarios. 2. The team implements parallel billing using transaction VF04 with server group distribution to use 100% of the CPU capacity. 3. The SD team utilizes SAP Note 19124445 to optimize the account determination logic for HANA native execution. 4. Basis lead ensures that the HANA log segments are sized at 3 times the standard size to handle the peak month-end commit volume.
What not to do, common wrong fixes.
1. Do not allow the go-live to proceed until the system proves it can process 5,000 invoices per hour without slowing down VA01. 2. Do not use manual billing as a backup plan for day 1. The volume of a global business makes manual entry impossible. 3. Do not ignore update terminated errors in the system logs during testing. These are the first sign of a mass billing deadlock. 4. Do not assume that the sandbox performance is indicative of production performance. Data volume is everything. Shortcuts in mass billing validation will result in a financial hard stop on day 30.
Follow-up 1. Why does mass billing trigger more deadlocks in S/4HANA than in ECC?
Answer: S/4HANA has a flattened data model. In ECC, header and item data were separate locks. In S/4HANA, because status fields are now in the header tables like VBAK and VBRK, multiple parallel threads attempting to update different status flags on the same document are far more likely to collide, triggering a technical deadlock.
Follow-up 2. How can I optimize mass billing without changing the code?
Answer: you can optimize it through logical partitioning. Instead of running one massive billing job, split the jobs by sales organization or billing type. This distributes the load across different database ranges and reduces the contention for the same number range objects and table indexes.
Follow-up 3. Curveball. What if the mass billing run, VF04, works perfectly for domestic orders, but crashes the system during the consolidated intercompany billing run because the new SAP RAR revenue recognition engine is attempting to create 100,000 revenue accounting items simultaneously in the same technical LUW?
Answer: this is a cross-framework sync failure. The S/4HANA billing engine is fast, but the SAP RAR RI monitor can become a bottleneck. You must test the RI transfer pacing. The fix is to decouple the billing save from the revenue recognition event. You must configure the system to create raw RIs first, which is fast, and then use a separate background job to process them into contracts. If your testing did not cover this asynchronous revenue handshake, your mass billing run will time out at the commit phase, leaving your intercompany balance sheet permanently out of sync.
Exclusive pro tip.
Conduct a month-end simulation in the sandbox using actual production data from a previous fiscal close. Measure the invoices per minute throughput and share this with the CFO. This is the only way to gain the political support needed for expensive HANA hardware upgrades or code refactoring workstreams.
Scenario 163. Pricing scale performance not stress tested.
In the realize phase of an ECC to S/4HANA migration, organizations often overlook the performance impact of the new pricing engine on complex discount scales. S/4HANA replaces the KONV cluster with the transparent PRCD_elements table. While this enables analytics, the evaluation of multi-level tiered scales for documents with hundreds of line items can trigger significant CPU spikes on HANA. If this performance is not stress-tested with real-world document depth, Sales orders and billing documents will experience 3 to 5 second save latencies, paralyzing high-volume operations.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high runtime integrity and HANA resource risk. 2. Phase realize. 3. Frequency, common in wholesale distribution and chemicals industries. 4. Primary ownership, SD functional lead. 5. Supporting ABAP lead, HANA and performance manager, the person who owns this and gets fired if it fails. 6. Business ownership, pricing manager. 7. Relevant SAP note. SAP note 2267308. S4 HANA pricing data model.
Diagnostic dashboard, symptoms and evidence.
How pricing scale bottlenecks manifest during validation cycles. 1. Symptom. Entering a quantity in a 200-line sales order causes the Fiori spinner to run for 10 seconds before the price updates. 2. Red flag. ATC checks flag legacy VOFM pricing routines that use nested select statements to evaluate scales. 3. Business impact. Order entry productivity drops by 30%, leading to customer service backlogs and unacceptably long call durations. 4. Detection. Checking transaction SDAD shows that the ABAP time for pricing calculation is 5 times higher than an ECC. 5. Technical proof. HANA Studio shows a massive spike in calculation engine threads when a mass billing job processes tiered scale items. Insight. Transparent pricing is better for reports, but it is more CPU hungry for calculations. If your scales are complex, your math is expensive.
Why this happens, scenario analysis and root cause.
1. Legacy ECC pricing routines were optimized for the cluster model, where the entire pricing set was loaded into memory at once. 2. S4 HANA PRCD_elements requires the engine to perform individual lookups or complex joins for each tiered scale evaluation. 3. The project team failed to simulate document depth during testing. They tested 5-line orders instead of the 500-line orders used in production. 4. Underestimating the impact of group conditions, where the scale is calculated across multiple line items, multiplying the database calls. The failure is a result of treating a structural data model change as a simple table rename.
Why this is a migration, exclusive failure.
1. ECC upgrades never changed the way scales were evaluated. The cluster technology was stable for 30 years. 2. S4 HANA migration involves a move to the HANA native pricing engine, which processes math differently than the legacy ABAP kernel. 3. The transition from table KONV to table PRCD_elements is a one-time architectural event unique to S4 HANA migration. 4. This failure only surfaces when the new transparent pricing architecture encounters the high-complexity scales of a legacy business. S4 HANA introduces a performance profile for pricing that ECC simply did not have.
Financial and customer impact.
1. Revenue leakage if pricing timeouts result in default or zero prices being applied to high-volume invoices. 2. Operational disruption as sales reps hard-code prices to bypass the slow system calculation, destroying the margin controls. 3. High cost of emergency hardware expansion as the organization realizes they need more CPU cores just to calculate prices. 4. Customer service delays result in abandoned shopping carts on the integrated e-commerce site. Pricing performance is the silent killer of S4 HANA ROI.
Governance and accountability, RACI model.
Securing pricing throughput requires a bridge between functional SD and technical HANA teams. 1. Accountable SD functional lead, the person who owns this and gets fired if it fails. 2. Responsible ABAP lead HANA refactors legacy pricing routines to use code-to-data logic and optimizes PRCD_elements joins. 3. Consulted pricing manager identifies the stress case discount models and complex tiered scales for testing. 4. Informed IT transformation director monitors the average transaction time as a key project health metric. Accountability ensures that functional rules do not exceed the technical limits of the database.
Ownership, who actually fixes it.
Resolving this requires a pricing stress test strategy. 1. The SD functional lead identifies the top 10 materials with the most complex multi-tiered discount scales. 2. The performance manager mandates a deep document test, creating orders with 500 lines for those materials. 3. The ABAP lead uses SQL Monitor, or SQLM, to identify sequential scans on table PRCD_elements and replaces them with HANA-optimized queries. 4. The technical architect applies SAP Note 22673008 to ensure the latest pricing engine performance patches are active.
Who gets blamed versus who owns it?
1. Blamed. SD functional lead. The business assumes the pricing logic is built incorrectly. 2. Blamed. Basis team executives assume the HANA server is not powerful enough. 3. Actual owner. Performance manager responsible for the failure to mandate document depth testing during the realize phase. 4. Root cause. Underestimating the CPU impact of evaluating complex scales in a transparent database model. A pricing lag is an architectural failure, not a configuration error.
How this is actually fixed, the right way by a role.
1. The SD functional lead mandates a pricing audit, identifying any tiered scale that can be simplified into a flat rate model. 2. The team implements parallelized pricing evaluation for mass billing jobs to distribute the CPU load across all HANA cores. 3. The ABAP lead refactors custom VOFM routines, range 900 to 999, to ensure they only read PRCD_elements using the primary keys. 4. Functional leads execute volume comparison testing, verifying that the S/4HANA system can price 1,000 documents per minute.
What not to do, common wrong fixes.
1. Do not allow the go-live to proceed if the price update on a standard sales order takes more than 1 second. 2. Do not use direct SQL update statements to PRCD_elements to bypass the engine. This will corrupt the financials. 3. Do not skip the testing of group conditions under full volume. These are the most likely to cause a system hang. 4. Do not ignore database lock alerts during the pricing stress test. These indicate a structural flaw in the code. Shortcuts in pricing performance testing lead to an operational blackout on the first day of business.
Follow-up 1. Why did pricing feel faster in ECC for large documents?
Answer: ECC utilized a cluster table, KONV, which was highly red-optimized for ABAP. The entire pricing situation was loaded into the application server's local memory in one compressed block. S/4HANA's transparent model, PRCD_elements, is better for reporting, but it requires more database calls and CPU work to reevaluate scales across hundreds of lines.
Follow-up 2. What is the risk of group conditions in S/4HANA?
Answer: a group condition requires the system to check every line item in the order to calculate a total quantity or value before it can determine the correct scale tier. In S/4HANA, if this logic is unoptimized, the system will perform a full scan of table PRCD_elements for every line item, leading to exponential performance degradation as the document grows.
Follow-up 3. Curveball. How do you resolve a scenario where pricing performance is excellent for 99% of users, but the collective billing background job, VF04, crashes with a HANA thread limit exceeded error because it is evaluating complex scales for 5,000 intercompany invoices simultaneously?
Answer: this is a thread satiation failure. The HANA calculation engine has a limit on concurrent complex expressions. You must test the batch concurrency logic. The fix is to configure the billing parallelization server groups to limit the number of simultaneous pricing-heavy threads. You must find the sweet spot between throughput and CPU stability. Additionally, you should implement pricing buffering via SAP Note 22673008 to ensure that intercompany scale evaluations are cached rather than recalculated for every invoice in the batch.
Exclusive pro tip.
Before the realize phase ends, execute the pricing performance tracer, transaction ST05 with pricing filter. If a single price check is triggering more than 50 database reads, your scale logic is architecturally flawed and must be refactored into a HANA native CDS view immediately.
Scenario 164. BRF plus output runtime not tested.
In the realize phase of an ECC to S/4HANA migration, organizations often move to the new SAP S/4HANA Output Management Framework, based on Business Rule Framework Plus, or BRF Plus. Unlike the legacy NAST spool-based output, BRF Plus utilizes Adobe Document Services and XML-based rendering. If the testing strategy fails to validate the runtime performance of mass document generation, the system will experience severe CPU bottlenecks in the Java stack during the first high-volume billing run, leading to missing invoices and communication failures.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high communication and technical throughput risk. 2. Phase, realize. 3. Frequency, common in multinational rollouts with heavy Adobe form usage. 4. Primary ownership, test lead and performance manager, the person who owns this and gets fired if it fails. 5. Supporting basis lead and output developer. 6. Business ownership, customer service director. 7. Relevant SAP note. SAP note 2228611. S4 TWL output management in S4 HANA.
Diagnostic dashboard, symptoms and evidence.
How BRF Plus output bottlenecks manifest during validation. 1. Symptom. Creating an invoice takes 10 seconds per document when the print or email action is triggered via BRF Plus. 2. Red flag. Technical error logs in transaction SLG1 show ADS connection timeout during a simulated mass billing run. 3. Business impact. Nightly invoice distribution jobs fail to finish, leaving thousands of customers without their billing documents on day 1. 4. Detection. Checking transaction SB01 reveals 0 spools generated because the rendering failed in the Adobe Document Services Java stack. 5. Technical proof. High memory utilization on the Java instance, NetWeaver Java, coinciding with the execution of the APOC_render_document method. Insight. NAST was a procedural write-to-spool event. BRF Plus is a complex XML transformation that requires a high-performance Java engine.
Why this happens, scenario analysis and root cause.
1. Project teams assume that because the forms were migrated, the rendering engine will have the same performance profile as legacy smart forms. 2. Failure to scale the Adobe Document Services or ADS Java stack to handle concurrent requests from 20 parallel billing threads. 3. Underestimating the payload size. S4 HANA passes significantly more metadata to the form engine than ECC did. 4. The assumption that electronic output, email, or EDI, is faster than printing, ignoring that both require the same CPU-intensive rendering step. The failure is a result of treating output as a functional UI task rather than a non-functional throughput task.
Why this is a migration, exclusive failure.
1. ECC upgrades never change the output engine, NAST, ensuring 100% performance continuity for decades. 2. S4 HANA migration introduces the BRF Plus framework, which represents a fundamental technology shift in how documents are generated. 3. The move from legacy spools to PDF-based rendering via ADS is a one-time architectural change unique to the S4 HANA path. 4. This failure only surfaces when the new XML-based communication engine encounters the high-volume transactional pressure of the live O2C cycle. Migration introduces a rendering bottleneck that ECC row-based spooling never had.
Financial and customer impact.
1. Cash flow disruption, as invoices are not transmitted to customers, leading to a direct increase in unbilled revenue. 2. Damaged customer relationships when strategic clients receive unformatted or incomplete order confirmations due to rendering errors. 3. Increased infrastructure costs as the organization is forced to perform an emergency upgrade of the Java application server hardware. 4. Operational delays as warehouse teams wait minutes for a bill of lading or packing list to print during peak shipping waves. Output performance failures turn a high-speed S4 HANA system into a slow-motion logistics disaster.
Governance and accountability, RACI model.
Ensuring output throughput requires a link between SD basis and developers. 1. Accountable test lead and performance manager, the person who owns this and gets fired if it fails. 2. Responsible basis lead optimizes the Adobe Document Services connection and Java stack threads for document rendering. 3. Consulted output and form developer refactors complex Adobe form logic to reduce the XML payload size. 4. Informed IT Transformation Director manages the performance exit gate sign-off before the production cutover. Accountability ensures that customer communication is stable under peak business load.
Ownership, who actually fixes it.
Resolving this requires an end-to-end rendering audit. 1. The performance manager mandates a mass output stress test, triggering 1,000 PDF generations per minute in the test client. 2. The basis lead monitors the ADS RFC queue and increases the number of available XML transformation threads in the Java kernel. 3. The ABAP lead optimizes the data provider classes for the forms to ensure only necessary fields are sent to the rendering engine. 4. The technical architect applies SAP Note 2228611 and all subsequent performance patches for the S/4HANA output framework.
Who gets blamed versus who owns it.
1. Blamed ABAP developers. The business assumes the invoice form is poorly coded. 2. Blamed basis team users claim the network or printer is slow. 3. Actual owner, test lead and performance manager responsible for the failure to simulate mass rendering concurrency during testing. 4. Root cause, treating modern XML-based output as if it were legacy procedural spool output. A slow invoice is a technical throughput failure, not a business logic error.
How this is actually fixed, the right way by a role.
1. The performance manager mandates an output readiness gate, proving the system can render a month's worth of invoices in under 4 hours. 2. The basis lead implements ADS load balancing, distributing rendering tasks across multiple Java instances. 3. The team implements asynchronous output processing in BRF+, ensuring that a slow form rendering does not hang the user's VA01 session. 4. The project team utilizes SAP Note 2228611 to configure the output compatibility layer for low-priority documents to reduce the load on ADS.
What not to do, common wrong fixes.
1. Do not allow go live if the rendering time for a standard invoice exceeds 2 seconds during a multi-user stress test. 2. Do not use high-resolution images or large logos in the new Adobe forms. This exponentially increases the rendering time on the Java server. 3. Do not assume that because the PDF looks good on the screen, it will print fast. The technical payload is different. 4. Do not ignore PDF_error messages in the log. These indicate a Java heap memory exhaustion that will eventually crash the system. Shortcuts in output performance testing will lead to a frozen warehouse on Monday morning.
Follow-up 1. Why is S/4HANA BRF plus more resource-intensive than ECC and ST?
Answer: ECC and ST used a procedural logic that wrote text directly to a spool table, TSD03, which is a light database operation. BRF Plus for S/4HANA requires the system to build an XML data stream, send it via RFC to a Java server, ADS, render it into a PDF, and send it back. This round trip consumes significantly more CPU and network bandwidth.
Follow-up 2. What is the risk of keeping all my legacy smart forms in S/4HANA?
Answer: while technically possible via the compatibility layer, you lose the clean core benefits. Smart forms are not designed for the modern cloud-native communication channels that S/4HANA supports. Over time, maintaining these legacy forms will become more expensive than migrating them to Adobe Document Services.
Follow-up 3. Curveball. How do you resolve a scenario where individual document rendering is fast, but the nightly consolidated billing job, VF04, for 50,000 customers fails because the Adobe Document Services Java stack becomes fragmented and stops responding to new XML payloads after the first 10,000 documents?
Answer: this is a Java garbage collection and connection pooling failure. The ADS Java instance is not releasing memory fast enough between rendering requests. You must test the continuity of rendering under sustained volume. The fix is to tune the ADS destination and transaction SM59 to use persistent connections and to increase the maximum heap size on the Java as. If your SIT did not cover a sustained 4-hour rendering run, your month-end billing will trigger a Java stack dump, requiring a full system restart and delaying your financial close.
Exclusive pro tip.
Configure a dedicated basis monitor dashboard for Adobe Document Services during your UAT phase. If the response time for the ADS RFC destination, ADS_RFC, shows a trend of increasing latency over time. Your Java stack is fragmenting and must be resized before go live.
Category 3 wrap-up, non-functional testing.
Category 3 has demonstrated that system up does not equal business ready. We analyze the catastrophic risks of missing volume tests, unoptimized parallel processing, and the technical limits of the new ABAP and output engines. The lesson is clear. S/4HANA is a high-performance engine that requires a high-performance validation strategy. If you do not stress test the technical architecture, it will buckle under the pressure of real production volume.
Transition to Category 4, user acceptance testing risks.
Even with a technically perfect and high-performance system, a migration will fail if the users cannot operate it. In Category 4, we move to the human layer. We will analyze the UAT risks, focusing on the dangers of non-representative test data, missing business variants, and the failure to simulate the high-pressure, month-end close. This is where we ensure the business truly accepts the new digital core.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Category 4, user acceptance testing risks.
Category 4 addresses the risk of failed business validation. Many projects fail because UAT is treated as a training session rather than a critical validation. In S/4HANA, the shift in UI to Fiori and the change in master data to business partner require users to validate scenarios they never had to think about in ECC. We will examine why clean test data leads to false confidence and why a failed month-end simulation is the leading cause of post-go-live hypercare chaos.
Category 4 incident list, UAT risks.
The final group of testing incidents addresses the risk of failed user acceptance and business readiness. 165. Test data not representative. Relevant SAP note not applicable test strategy and execution. 166. Business variance not covered. Relevant SAP note not applicable test strategy and execution. 167. Cutover scenarios not tested. Relevant SAP note not applicable test strategy and execution. 168. Reconciliation approach missing. Relevant SAP note not applicable test strategy and execution. 169. Month-end acceleration not simulated. Relevant SAP note not applicable test strategy and execution. Category 4 incidents are the human gatekeepers that decide if the organization is ready to go live.
Scenario 165, test data not represent.
In the realize phase of an ECC to S/4HANA migration, organizations often conduct user acceptance testing using gold client data that has been manually cleansed and perfected. However, the actual production environment contains 20 years of data inconsistencies, such as customers with invalid tax registrations or materials with missing segments. If UAT is performed on sanitized data, the business users will never encounter the strict validation errors of the S/4HANA Business Partner and pricing engines, leading to a massive volume of failed transactions as soon as real-world dirty data hits the system.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium data governance and user adoption risk. 2. Phase, realize. 3. Frequency, extremely common in projects prioritizing a clean sandbox over a production copy. 4. Primary ownership, test lead and SD functional lead. The person who owns this and gets fired if it fails. 5. Supporting master data management lead. 6. Business ownership, sales operations manager. 7. Relevant SAP note, not applicable test strategy and execution. This is a data selection and governance failure.
Diagnostic dashboard, symptoms and evidence.
How non-representative test data manifests during the migration lifecycle. 1. Symptom. Users report that everything worked in UAT, but they cannot save a single order for their top 10 customers on the first day of go live. 2. Red flag. The UAT environment contains only 5% of the total customer master records from the legacy ECC system. 3. Business impact. Immediate halt in order processing post-conversion, forcing an emergency mass cleansing of master data in the live system. 4. Detection. Checking the UAT logs reveals that 0 one-time customers or intercompany partners were used during testing. 5. Technical proof. Errors in the S/4HANA CVI engine stating that tax jurisdiction is invalid for documents that passed UAT with dummy addresses. Insight. If you test with perfect data, you are validating the software, not the business. Real business is messy.
Why this happens, scenario analysis and root cause.
1. Data teams often filter out complex or incomplete records during the UAT load to prevent testing delays. 2. Organizations use scrambled data for privacy reasons, but the scrambling logic often replaces high-risk characters, like symbols in names, with simple strings. 3. Project managers assume that if the code is correct, the data quality is a secondary concern that can be fixed during hypercare. 4. Failure to perform a production copy refresh for the UAT client due to HANA storage costs or technical time constraints. The failure is a result of prioritizing a green test report over an accurate operational reality.
Why this is a migration, exclusive failure.
1. ECC upgrades kept existing data as it was. The system was already forgiving of the data it had stored for years. 2. S/4HANA migration involves a data model evolution where every record must pass through new, stricter architectural gates like CVI. 3. The shift from customer to business partner means that fields like email or country code, which were ignored in ECC, now act as hard blocks. 4. This failure only surfaces when the newly converted S/4HANA validation engine encounters the raw, uncleansed history of the ECC system. Migration removes the blind eye that ECC turned toward poor data quality.
Financial and customer impact.
1. Revenue recognition is blocked for high-value orders that contain non-compliant legacy tax or partner data. 2. Customer disputes arise when invoices are sent to old or truncated addresses that were not detected in UAT. 3. High operational costs as a data war room must be established post-go-live to manually repair thousands of records. 4. Loss of ROI as users lose faith in the new Fiori UI because the system will not let me do my job. Representative data is the only insurance policy against a day one operational crash.
Governance and accountability, RACI model.
Ensuring data realism requires a partnership between the business and the data team. 1. Accountable, test lead and SD functional lead. The person who owns this and gets fired if it fails. 2. Responsible, data migration lead curates the stress case data set and ensures the UAT client is a representative production copy. 3. Consulted, Master Data Governance Council provides the data quality rules that must be validated during UAT. 4. Informed, Sales Operations Manager validates that the test results match the operational performance of their team. Accountability ensures that success is measured against real-world complexity.
Ownership, who actually fixes it.
Resolving this requires a real data testing mandate. 1. Test lead mandates that 100% of the top 1,000 customers by revenue must be migrated and tested in UAT. 2. Data migration lead executes a production copy refresh of the UAT client and performs a zero cleansing load to see what breaks. 3. SD functional lead creates negative test data, including customers with multiple tax registration numbers and varied currency settings. 4. Business users are instructed to pick the hardest orders they ever had to enter as their primary UAT scenarios.
Who gets blamed versus who owns it?
1. Blamed master data team. The sales users assume basis lost the data or migrated the wrong version. 2. Blamed SAP. The business assumes S/4HANA is too restrictive for their industry. 3. Actual owner, test lead and SD functional lead responsible for allowing UAT to proceed using artificial data. 4. Root cause, treating UAT as a UI training exercise rather than a data integrity validation. If you do not test with the dirt, you will not survive the clean.
How this is actually fixed, the right way by a role.
1. Test lead establishes a data diversity gate. UAT cannot start until the test data contains 50 different countries and 20 different tax jurisdictions. 2. The team implements scrambled production data using SAP TDMS to maintain real-world relational complexity without violating privacy laws. 3. Functional leads execute ghost loads during SIT2 to identify data-driven short dumps before the business users arrive for UAT. 4. The project team utilizes SAP Note 2713963 to ensure the CV iSync engine is configured for production-level data variety.
What not to do, common wrong fixes.
1. Do not use testing-only materials and customers that do not exist in the real legacy system. 2. Do not allow the business to skip testing for one-off scenarios that represent high dollar values, like quarterly service contracts. 3. Do not accept successful UAT results if the users only tested the happy path scenarios. 4. Do not ignore invalid format warnings in the CV cockpit, assuming users will fix them post-go live. Shortcuts in data realism result in a financial and operational blackout on day 1.
Follow-up 1. Why is scrambled data sometimes still better than clean data for UAT?
Answer: clean data is artificial. It has zero history. Scrambled data keeps the structure of real production data, for example, specific field combinations, document depths, and pricing scales, while changing the names and IDs. This forces the system to process the actual complexity of your business rules without compromising data privacy.
Follow-up 2. How can I quickly find the dirtiest data in my ECC system to use for testing?
Answer: use transaction SD03N to find the most used transactions, and then look at the failed records in your background jobs or IDOC monitors. Transaction WE02. The data that is currently causing status 51 errors in ECC is exactly the data you must test in S/4HANA to see if the new architecture handles it better or worse.
Follow-up 3. Curveball. What if the UAT passes perfectly with scrambled data, but the new S/4HANA O data layer for Fiori sales apps crashes in production because of illegal UTF-8 characters or special symbols in the legacy customer addresses that were accidentally cleaned by the scrambling tool?
Answer: this is a metadata divergence failure. Fiori apps are much more sensitive to character encoding than legacy SAP GUI. You must test the raw character payload. The fix is to perform a symbol audit on the production KNA1 and KNA2 tables. You must identify any characters, like non-breaking spaces or non-standard regional symbols, that are valid in the ECC row-based database, but will trigger an invalid XML error in the S/4HANA OData service. Your testing strategy must include a payload validation step, specifically for Fiori critical data fields, to avoid a day 1 UI blackout.
Exclusive pro tip.
Mandate a data rejection exercise during the final week of SIT. Intentionally feed the system 100 known bad records from your ECC production system. If the S/4HANA system does not provide a clear, business-readable error message for every one of them, your validation logic is insufficient.
Scenario 166. Business variance not covered.
During the realize phase of an ECC to S/4HANA migration, The organization often validates the domestic sales flow, but ignores the complex O2C matrix of business variance. Because S/4HANA introduces new logic for advanced ATP and event-based revenue recognition, variants like third-party dropshipping, intercompany stock transfers, and consignment returns require unique technical handshakes. If the test plan misses these non-standard branches, the business will face immediate shipping blocks and intercompany financial imbalances post-go-live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high process integrity and integration risk. 2. Phase, realize. 3. Frequency, common in multi-entity global enterprises. 4. Primary ownership, SD functional lead and business process owner. The person who owns this and gets fired if it fails. 5. Supporting test lead. 6. Business ownership, sales operations director. 7. Relevant SAP note, not applicable test strategy and execution. This is a process scoping and script design failure.
Diagnostic dashboard, symptoms and evidence.
How business variant gaps manifest during system validation. 1. Symptom, standard domestic orders save perfectly, but intercompany billing transaction VF01 with type IV triggers an account determination error. 2. Red flag, the UAT tracker shows 0 entries for document types like KE consignment fill-up or NB standard purchase requisition from sales. 3. Business impact, total failure of the interentity supply chain on day 1, leading to millions in unshipped cross-border revenue. 4. Detection, comparing the active document types in ECC table T176 against the UAT scripts reveals a coverage gap of 40% or more. 5. Technical proof, missing entries in the S/4HANA copy control tables for variant-specific document categories that were never triggered during testing. Insight, if you only test the happy path, you are only validating the standard system, not your specific company logic.
Why this happens, scenario analysis and root cause.
1. Functional leads prioritize high-volume domestic flows to secure management success early in the project. 2. The project team assumes that because the configuration for intercompany did not change, the behavior will be the same in S/4HANA. 3. Testing scripts are often copied from legacy ECC user guides that were not updated for the new S/4HANA stock in transit or credit check logic. 4. Low-frequency variants like customer returns or debit memo requests are pushed to a future phase 2 that never actually happens before go-live. The failure is a result of a testing strategy that values volume over process complexity.
Why this is a migration, exclusive failure.
1. In ECC upgrades, the document flow and requirement classes remain static, so variant flows rarely broke between versions. 2. S/4HANA migration involves a fundamental change in how the system handles credit checks and revenue accounting for intercompany flows. 3. The mandatory move to business partner, CVI, requires that intercompany customers be perfectly linked to internal vendors, a unique S/4HANA prerequisite. 4. This failure only surfaces when the organization attempts its first cross-border or non-standard transaction in the converted environment. Migration forces a level of variant revalidation that ECC upgrades never approach.
Financial and customer impact.
1. Financial imbalances occur at month-end, as selling entity revenue is recognized, but supplying entity costs are not settled. 2. Damaged customer relationships as dropship orders are delayed because the purchase requisition was never triggered in the new system. 3. Audit failures if the incomplete variants allow users to bypass standard credit or margin controls using untested document types. 4. High cost of manual document reconciliation, as regional teams must manually create deliveries for orders that failed the system logic. Variant gaps turn a global rollout into a series of local supply chain crises.
Governance and accountability, RACI model.
Ensuring variant coverage requires a formal cross-functional sign-off. 1. Accountable SD functional lead and business process owner, the person who owns this and gets fired if it fails. 2. Responsible test lead manages the variant coverage matrix and ensures every document type is mapped to a test case. 3. Consulted global process leads validate that the global template variants are correctly tested in every local subsidiary. 4. Informed IT transformation director monitors the process completion rate as a primary project health indicator. Accountability ensures that no regional business variant is sacrificed for the global project timeline.
Ownership, who actually fixes it.
Resolving this requires an O2C variant inventory strategy. 1. SD Functional Lead extracts a list of every sales document type used in the last 12 months from table VBAK. 2. The team creates a transaction matrix mapping each document type to its corresponding item categories and billing types. 3. The test lead mandates that 100% of these unique combinations must have at least one pass result in the SIT2 cycle. 4. The global process owner performs a chain test, following a third-party order through SD, MM, and FI to ensure the value flow is correct.
Who gets blamed versus who owns it.
1. Blamed. SD lead the business assumes the consignment or returns configuration was deleted. 2. Blamed. SAP users claim S/4HANA does not support their specific business model. 3. Actual owner. SD functional lead and business process owner responsible for failing to define the process coverage requirements. 4. Root cause. Treating the migration as a technical switch for one process rather than an engine swap for all variants. A failure in a variant is a gap in the blueprint, not a system glitch.
How this is actually fixed, the right way by a role.
1. SD Functional Lead mandates a variant gap analysis during the Explore phase to identify S/4HANA impact on each O2C path. 2. The team implements automated regression suites that trigger orders for 20 different document types every night to catch configuration regressions. 3. Global Process Leads execute subsidiary UAT, where local entities test their specific local variants, for example, Brazilian Nota fiscal variants. 4. The project team utilizes SAP Note 2227014 to ensure that status handling for variants is correctly updated for the new S/4HANA core.
What not to do, common wrong fixes.
1. Do not assume that if a standard sales order works, an intercompany return will also work. They use different account keys. 2. Do not allow the business to auto-pass variants that have low volume, as these often contain the highest financial risk. 3. Do not skip the testing of document flow between SD and MM for third-party orders. 4. Do not allow go live until the variant coverage report shows 100% completion for all P1 and P2 business processes. Shortcuts in variant testing will lead to a supply chain paralysis on the first day of business.
Follow-up 1. How do I prioritize which O2C variants to test first?
Answer: prioritize based on financial weight. Calculate the total revenue generated by each sales document type in the legacy system. The variants that account for 90% of your revenue are your P1 test cases. The remaining 10% are your P2 cases. You must never go live without 100% P1 coverage.
Follow-up 2. Why is the intercompany variant so much more complex in S/4HANA?
Answer: in ECC, intercompany was often asynchronous. In S/4HANA, the new advanced intercompany sales, SAP Note 2503673, uses a real-time stock in transit model. If your test scripts do not account for this new valuated stock movement, your selling entity will show a profit while your supplying entity shows a permanent inventory variance.
Follow-up 3. Curveball. What if the domestic sales variant works perfectly in the Fiori Managed Sales Orders app, but the credit release variant fails specifically for orders where the reason for rejection is set on one of the items because the custom VOFM credit routine fails to recognize the rejected status in the new S/4HANA header tables?
Answer: this is a status logic failure unique to the S/4HANA data model simplification. In ECC, the item status was in table VBUP. In S/4HANA, it moved to the header or was virtualized. If your custom credit logic checks for open value without filtering for rejected items at the header level, the system will double count the credit exposure, blocking the order incorrectly. You must test the interaction between item status and header credit status. The fix is to refactor the credit routine to use the new document header status fields, table VBAKGBSDK, and ensure it correctly deducts rejected items from the total credit value calculation in real time.
Exclusive pro tip.
Create a variant heat map showing each document type and its test status. If the return or intercompany boxes are still read 2 weeks before go live, do not allow the PM to announce readiness. These are the variants that will paralyze your finance and logistics teams on Monday morning.
Scenario 167. Cutover scenarios not tested.
In the realize phase of an ECC to S/4HANA migration, organizations often neglect to perform a full technical dress rehearsal, or TDR. While SIT and UAT validate the system's functionality, they rarely simulate the high-pressure sequence of the cutover weekend, such as the exact timing of the data freeze, the execution of the Software Update Manager, or SUM tool, and the post-conversion manual activities. If the cutover runbook is not physically tested with 100% of the production data volume, the organization will encounter unexpected technical bottlenecks and sequencing errors that can force an emergency rollback during the go-live window.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high project governance and cutover stability risk. 2. Phase, realize and deploy. 3. Frequency, common in projects that treat cutover as a checklist rather than a simulated event. 4. Primary ownership, cutover lead and project manager, the person who owns this and gets fired if it fails. 5. Supporting basis lead and SD functional lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note, not applicable test strategy and execution. This is a project management and orchestration failure.
Diagnostic dashboard, symptoms and evidence.
How cutover testing gaps manifest during the conversion weekend. 1. Symptom, the technical conversion runs 12 hours behind schedule because the server groups were not tuned for the final data volume. 2. Red flag, the cutover runbook contains TBD or placeholder durations for critical SD tasks like the CV synchronization or pricing conversion. 3. Business impact, the Monday morning start of business is missed, resulting in a total shutdown of the warehouse and sales operations. 4. Detection, the first mock migration was performed on a small sandbox system rather than a production-sized environment. 5. Technical proof, database logs show massive rollback events during the downtime because a manual configuration step was performed out of sequence. Insight, if you have not practiced the cutover, you are not migrating. You are gambling with your company's revenue.
Why this happens, scenario analysis and root cause.
1. A lack of technical dress rehearsals using 100% of the production data volume on production-grade hardware. 2. The project team fails to document manual intervention steps, assuming that the automated SUM tool handles the entire process. 3. Underestimating the human fatigue factor. Cutover tasks are often performed 24/7, leading to errors in data entry or transaction execution. 4. Failure to include third-party integration resets in the cutover plan, such as repointing the e-commerce webshop to the new S/4HANA production instance. The failure is a result of treating cutover as an IT event rather than a synchronized business and technical performance.
Why this is a migration, exclusive failure.
1. ECC upgrades were in place and rarely required the complex extract transform load sequences of an S/4HANA conversion. 2. The S/4HANA brownfield path involves mandatory technical gates like CVI and PRCD_elements conversion that have strict sequencing requirements. 3. The downtime window for S/4HANA is significantly longer and more intensive than any standard ECC support pack update. 4. This failure only surfaces during the high-pressure go-live weekend when the clock is ticking against the business start time. Migration creates a time-critical dependency chain that ECC maintenance never faced.
Financial and customer impact.
1. Revenue loss as the system remains offline past the scheduled go-live, preventing the processing of daily sales orders. 2. Significant cost increases as the organization is forced to pay for emergency weekend support from SAP and external consulting partners. 3. Customer service reputation damage when the new system is unavailable on its promised launch date. 4. Loss of ROI as the organization is forced into a safe rollback to ECC, losing months of project effort and investment. Cutover failures are the most public and expensive way to fail an S/4HANA program.
Governance and accountability, RACI model.
Executing the cutover requires a centralized command and control structure. 1. Accountable cutover lead and project manager, the person who owns this and gets fired if it fails. 2. Responsible basis lead executes the technical conversion tool and monitors the system layer milestones. 3. Consulted SD functional lead validates the functional readiness at each gate of the technical transition. 4. Informed executive steering committee makes the final go or no-go decision based on the cutover status report. Accountability ensures that the runbook is a tested technical reality, not a theoretical plan.
Ownership, who actually fixes it.
Resolving this requires a rehearsal-first project methodology. 1. The cutover lead mandates a minimum of 2 full-scale mock migrations with 100% production data. 2. The basis lead records the exact start and end times for every SUM phase and pricing conversion task to establish a baseline timeline. 3. The SD functional lead creates a post-go-live validation checklist, smoke test, to be executed as soon as the technical conversion is finished. 4. The project manager facilitates a go or no-go rehearsal, simulating a technical failure to test the rollback and disaster recovery procedures.
Who gets blamed versus who owns it.
1. Blamed basis team. The business assumes the technical upgrade crashed or was too slow. 2. Blamed SAP. The project team claims the S/4HANA migration tools are unreliable. 3. Actual owner, cutover lead and project manager responsible for the failure to simulate the cutover window and validate the durations. 4. Root cause, treating the go-live weekend as the first time the full technical sequence is ever performed. If you fail to plan the sequence, you are planning to fail the conversion.
How this is actually fixed, the right way by a role.
1. The cutover lead establishes a master runbook with hour-by-hour ownership and dependencies for every task. 2. The team implements technical checkpoints every 4 hours during the cutover window to assess if the project is still on schedule. 3. Basis lead utilizes uptime processing features in the SUM tool to perform as much data transformation as possible before the users are locked out. 4. Functional leads execute modular smoke tests immediately after their specific data object, for example, pricing or BP, is converted, catching errors before the next phase.
What not to do, common wrong fixes.
1. Do not allow the go-live to proceed without a tested rollback plan that has been proven to work in the sandbox. 2. Do not use average durations from other companies as your cutover baseline. Every HANA server and data set is unique. 3. Do not skip the post-conversion technical cleanup tasks like SGEN or index rebuilds to save time. 4. Do not open the system to users before the financial reconciliation gate is confirmed as 100% complete. Shortcuts in cutover simulation will lead to a day 1 operational emergency.
Follow-up 1. What is a technical dress rehearsal or TDR?
Answer: a TDR is a one-to-one simulation of the actual go-live weekend. You use the final production-grade hardware, the full production data set, and the actual cutover team. You follow the runbook from the first user lockout to the final system release. The goal is to identify every technical bottleneck and confirm the exact downtime window.
Follow-up 2. How do I handle interface catch-up during the cutover?
Answer: you must define a catch-up strategy for all external systems. During the downtime, external systems like web shops or 3PLs should either be paused or point to a holding queue. Part of your cutover testing must include draining the queues in a specific sequence to ensure no orders are lost or duplicated.
Follow-up 3. Curveball. What if the technical conversion is 100% successful, but the system crashes 2 hours after opening to users because the update terminated queue transaction SM13 is flooded with V1 and V2 update failures for sales orders that were not detected during the technical dress rehearsal because the TDR used a background user with SAP_all rather than the restricted production business roles?
Answer: this is a security and load collision failure. Your cutover testing must include a persona-based smoke test. If your technical team performs the TDR with godlike permissions, you will never see the authorization-driven update failures. The fix is to mandate that the first 50 transactions after conversion be performed by real business users with their actual production roles. You must also monitor transaction SM13 every 15 minutes during the first 4 hours of go-live to identify these silent transactional failures before they corrupt the document flow.
Exclusive pro tip.
Add a buffer window of at least 20% to your technical cutover schedule. If the conversion takes 40 hours in your final mock, plan for a 48-hour downtime. In the world of database transformation, things will go wrong, and having a time contingency is the difference between a successful go-live and a panicked rollback.
Scenario 168. Reconciliation approach missing.
In the realize phase of an ECC to S/4HANA migration, the organization often fails to define a value-based reconciliation framework. While IT teams focus on migrating the record counts, for example, 100,000 orders, the business fails to define how they will prove the financial integrity of those orders. If the reconciliation approach ignores the cent-by-cent balance of revenue, tax, and inventory values between the legacy ECC subledgers and the new S/4HANA Universal Journal, the company will face massive audit failures and a loss of financial control post-go-live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial governance and compliance risk. 2. Phase, realize and deploy. 3. Frequency, common in large organizations with decentralized finance and SD teams. 4. Primary ownership, corporate controller, the person who owns this and gets fired if it fails. 5. Supporting FICO lead and SD functional lead. 6. Business ownership, CFO. 7. Relevant SAP note, not applicable test strategy and execution. This is a financial governance and audit compliance failure.
Diagnostic dashboard, symptoms and evidence.
How reconciliation gaps manifest during the testing cycles. 1. Symptom, the finance team asks for proof that the migrated open sales value matches ECC, and IT can only provide account of document numbers. 2. Red flag, the project plan contains 0 tasks for subledger to GL reconciliation post-data load. 3. Business impact, external auditors refuse to sign off on the first financial report post-S/4HANA migration, triggering a stock market risk. 4. Detection, checking the data migration monitor reveals that the only verification step is record count OK. 5. Technical proof, variances between table VBRK billing and table ACDOCA financials that cannot be explained or traced back to a specific migration logic change. Insight, record counts prove that data moved. Value reconciliation proves that the business moved.
Why this happens, scenario analysis and root cause.
1. Project teams treat data migration as a technical IT task rather than a financial event that requires a balancing of accounts. 2. A lack of involvement from the corporate audit and tax departments during the initial design of the migration scripts. 3. The assumption that the S/4HANA Software Update Manager, SUM, automatically handles financial reconciliation. It does not. It only handles table transformation. 4. Underestimating the complexity of multi-currency and multi-ledger environments where rounding logic can vary between the legacy and target systems. The failure is a result of prioritizing technical completion over financial truth.
Why this is a migration, exclusive failure.
1. ECC upgrades never moved data between different financial subledgers, so the audited state of the system remains static. 2. S/4HANA migration involves a point-to-point value transfer from SD tables to the unified ACDOCA table, which is a critical financial handshake. 3. The legal requirement to prove continuity of revenue during a system change is a unique compliance hurdle of the S/4HANA migration. 4. This failure only surfaces when the organization attempts to close its first fiscal quarter in the new system. Migration creates a break in the financial chain that only a formal reconciliation can bridge.
Financial and customer impact.
1. Material misstatement of financial results, leading to regulatory fines and a significant loss of investor confidence. 2. Inaccurate customer balance reporting, resulting in strategic clients being blocked for credit because of a migration rounding error. 3. High cost of forensic accounting post-go-live to reconstruct the migration history and satisfy external auditor demands. 4. Loss of management confidence, as the CFO cannot explain the variances in net revenue growth versus the legacy system. Reconciliation gaps directly jeopardize the financial certification of the enterprise.
Governance and accountability, RACI model.
Establishing financial truth requires a partnership between the controller and the data team. 1. Accountable corporate controller, the person who owns this and gets fired if it fails. 2. Responsible FICO lead identifies the mandatory reconciliation reports and signs off on the financial integrity of the load. 3. Consulted SD functional lead provides the pricing and tax logic that explains why specific values moved the way they did. 4. Informed internal audit lead validates the reconciliation methodology before the final production cutover. Accountability ensures that the migration is an auditable business event, not just a technical load.
Ownership, who actually fixes it.
Resolving this requires a value match reconciliation framework. 1. The corporate controller mandates a golden baseline report from ECC, capturing the total net value of all open documents by sales org. 2. The FICO lead utilizes SAP Note 2349298 to implement the financial consistency checks in the S/4HANA migration workbench. 3. The SD functional lead executes a pricing audit, comparing the total condition values in table KONV against the new table PRCD_elements. 4. The data migration team implements automatic value validation scripts that compare source and target dollar amounts after every load cycle.
Who gets blamed versus who owns it.
1. Blamed data migration team. The auditors assume the load was inaccurate or incomplete. 2. Blamed SD lead. The business assumes the invoices were created incorrectly. 3. Actual owner, corporate controller responsible for the failure to define the reconciliation baseline during the explore stage. 4. Root cause, treating a financial migration as a technical lift and shift rather than a ledger transformation. Audit failures are governance gaps, not technical glitches.
How this is actually fixed, the right way by a role.
1. The corporate controller establishes a reconciliation policy that requires a signed-off value baseline 30 days before cutover. 2. The team implements point-to-point balancing. For every $100 of revenue in ECC, there must be a corresponding $100 in S/4HANA. 3. Functional leads utilize report FINS_recon_SD_FI to automate the identification of document-level variances between sales and finance. 4. The project team performs a rec drill during UAT, where auditors pick 10 random orders and trace their financial lifecycle from ECC to S/4HANA.
What not to do, common wrong fixes.
1. Do not assume that balanced GL accounts means the SD subledger is reconciled. You must verify at the document and condition level. 2. Do not accept an approximate reconciliation. In an audit, a $1 variance is just as dangerous as a $1 million variance. 3. Do not wait until after go live to find out the reconciliation methodology. The auditors must approve the plan during the realize phase. 4. Do not allow manual journal entries in S/4HANA to force a balance without documenting the root cause of the migration mismatch. Shortcuts in reconciliation result in a material weakness finding that will haunt the CFO for years.
Follow-up 1. What is the difference between count reconciliation and value reconciliation?
Answer: count reconciliation proves that you moved 1,000 sales orders. Value reconciliation proves that the $1,245,678.90 net value of those orders in ECC matches the net value in S/4HANA. Only value reconciliation can satisfy a financial auditor, as it proves that the complex pricing and tax logic survived the migration.
Follow-up 2. Which S/4HANA table is the golden source for SDF/I reconciliation?
Answer: the golden source is table ACDOCA, the Universal Journal. Every SD billing event must create a corresponding entry here. You must reconcile your SD reports, like VF05, against the ACDOCA table to prove that the sales subledger and the general ledger are in perfect technical sync.
Follow-up 3. Curveball. How do you handle a scenario where the net value for a set of 50,000 historical sales orders matches exactly between ECC and S/4HANA, but the credit exposure in the new FSCM model, table UKM_item, is 1% lower than the legacy ECC credit limit used because the S/4HANA migration engine utilized a different currency exchange rate type for the credit reevaluation than the one used for the original billing document postings.
Answer: this is a multi-ledger inconsistency failure. Even if the net sales is reconciled, the risk management layer is out of sync. This happens when the FSCM migration does not use the historical rate from the document header, but instead uses the current rate in transaction OB08. You must test the rate mapping logic. The fix is to configure the credit migration report to use the document-specific exchange rate to ensure the credit exposure matches the audited legacy financial state. If you miss this, you will have a secret variance in your risk reporting that will cause strategic customers to be blocked unexpectedly when the next exchange rate update occurs.
Exclusive pro tip.
Establish a reconciliation war room during SIT2. Invite your auditors to watch a live data load and the subsequent value check report execution. By making the reconciliation process transparent to the auditors early, you secure their technical approval and avoid a go-live veto at the last minute.
Scenario 169. Month-end simulation missing.
In the realize phase of an ECC to S/4HANA migration, organizations often sign off on UAT based on individual transaction success, but fail to simulate a full month-end close cycle. S/4HANA introduces real-time profitability analysis and new settlement management accruals that trigger during the closing window. If the high-pressure sequence of mass billing, rebate settlements, and revenue recognition is not stress-tested in a month-end simulation, the finance and sales teams will face system timeouts, out-of-balance ledgers, and reporting failures during their first actual production close.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial integrity and operational risk. 2. Phase realize. 3. Frequency, extremely common in large global organizations. 4. Primary ownership, SD functional lead and FICO lead. 5. Supporting test lead. 6. Business ownership, corporate controller. 7. Relevant SAP note, not applicable test strategy and execution. This is a process validation and business readiness failure.
Diagnostic dashboard, symptoms and evidence.
How the lack of month-end simulation manifests during the first production close. 1. Symptom, mass billing jobs VF04 or settlement runs, WB2R_SC, fail to complete within the scheduled closing window. 2. Red flag, 0 defects were logged during UAT for closing activities because the scripts only covered day-to-day order entry. 3. Business impact, inability to release financial results on time, leading to corporate compliance risks and loss of management trust. 4. Detection, checking transaction SM37 during the first close reveals background jobs crashing due to HANA log full or lock contention errors. 5. Technical proof, high volumes of unprocessed revenue accounting items in the RI monitor that were never tested for a mass-commit scenario. Insight, month-end is the ultimate stress test for an O2C system. If you have not practiced it, you have not validated the solution.
Why this happens, scenario analysis and root cause.
1. Testing schedules prioritize go-live day over month-end day, leaving closing activities to the hypercare phase. 2. A lack of historical production copy data prevents the team from generating the thousands of documents needed for a realistic close simulation. 3. Underestimating the impact of Universal Journal real-time postings, which adds CPU overhead to every closing task compared to ECC. 4. Failure to coordinate between the SD, MM, and FI teams for the technical sequence of closing steps in the new S/4HANA architecture. The failure is a result of treating month-end as a collection of reports rather than a high concurrency event.
Why this is a migration, exclusive failure.
1. In ECC, month-end was a batch-end buffer process where SD errors did not always block the FI close immediately. 2. S/4HANA migration introduces embedded analytics and real-time profitability analysis that requires 100% data consistency during closing. 3. The move from legacy rebates to settlement management introduces a new closing engine that uses a different technical logic for payouts. 4. This failure only surfaces when the newly converted S/4HANA subledgers encounter the true month-end pressure of the legacy business volume. S/4HANA removes the separation between modules, making month-end a single high-risk event.
Financial and customer impact.
1. Deferred revenue collection if the billing cycle is delayed, resulting in a negative impact on the company's monthly cash position. 2. Customer disputes increase if quarterly rebate payouts are missed or calculated incorrectly by the new untested settlement logic. 3. Internal audit failures due to the inability to reconcile the sales subledger with the universal journal during the first close. 4. Massive consulting costs for emergency support as teams work 24/7 to force the close in the live production system. Month-end simulation gaps directly threaten the financial certification and reporting accuracy of the enterprise.
Governance and accountability, RACI model.
Securing the first close requires an integrated functional and finance leadership. 1. Accountable test lead and QA manager, the person who owns this and gets fired if it fails. 2. Responsible SD functional lead and FICO lead jointly responsible for designing and executing the month-end simulation cycle. 3. Consulted corporate controller provides the closing calendar and defines the mandatory financial checkpoints. 4. Informed IT transformation director monitors the first close status as a critical post-go-live milestone. Accountability ensures that the system is ready for the closing pressure, not just the opening ribbon cutting.
Ownership, who actually fixes it.
Resolving this requires a day 30 simulation strategy. 1. The test lead mandates a month-end simulation phase, cycle 3, where a full 30-day transactional workload is processed. 2. The SD functional lead executes the mass billing and rebate settlement runs using 100% production data volumes. 3. The FICO lead performs the period-end closing activities, including foreign currency valuation and profitability reconciliation. 4. The basis lead monitors system performance during the simulation to identify parallel processing bottlenecks.
Who gets blamed versus who owns it.
1. Blamed, FICO team. The business assumes the accounting module is not letting them close the books. 2. Blamed, SAP users claim the new system is less reliable than the legacy ECC system for closing. 3. Actual owner, test lead and QA manager responsible for the failure to include a dry run close in the project plan. 4. Root cause, treating month-end as a business activity to be figured out after go-live rather than a system validation requirement. Month-end failures are the result of poor test strategy, not technical bugs.
How this is actually fixed, the right way by a role.
1. The test lead mandates a closing dress rehearsal 2 weeks before go-live, following the exact minute-by-minute closing schedule. 2. The team implements post-conversion accruals correctly in S/4HANA to ensure the starting balances match the legacy audited state. 3. The FICO lead utilizes transaction FINS_closing_status to automate the monitoring of the multi-modular closing tasks. 4. Functional leads execute reconciliation reports. For example, FINS_recon, immediately after the mass billing simulation to prove subledger integrity.
What not to do, common wrong fixes.
1. Do not allow the go-live to proceed until the system has proven it can execute a mass settlement run without technical error. 2. Do not use dummy data for the close simulation. You will miss the real-world rounding and tax variances that cause balancing errors. 3. Do not assume that the standard closing steps from ECC are identical in S/4HANA. You must revalidate the sequence. 4. Do not ignore performance warnings during the simulation, assuming basis can tune the system later. Shortcuts in closing validation will lead to a financial crisis at your first month-end.
Follow-up 1. Why is a month-end simulation harder than standard UAT?
Answer: Standard UAT tests individual horizontal processes, order to cash. A month-end simulation tests vertical pressure across all modules simultaneously. It involves high-volume batch processing, data aggregation, and financial locking that individual test scripts never trigger.
Follow-up 2. What is the single most important SD task during a month-end simulation?
Answer: Mass billing and rebate settlement. These two tasks create the largest database load and involve the most complex interaction with the universal journal. If you cannot process 50,000 invoices and 500 rebate agreements in your test environment, your production close will fail.
Follow-up 3 Curveball. How do you handle a scenario where the month-end simulation passes perfectly in the sandbox, but the actual production close fails because the settlement management engine, LOAB, triggers a massive memory overflow dump when calculating accruals for a multi-level national account customer hierarchy that was accidentally excluded from the test data?
Answer: this is a hierarchy volume collision failure. The settlement engine must unroll the entire customer hierarchy to determine eligibility. If your test data only used simple hierarchies, you missed the recursive memory limit. You must test the deep hierarchy scenarios. The fix is to implement block-based settlement via SAP Note 22673777 to limit the number of nodes processed in a single thread. You must perform a hierarchy stress test during SIT2, ensuring that your top 5 most complex national account trees are fully represented in the simulation to avoid a day 30 financial hard stop.
Exclusive pro tip.
Create a closing runbook that includes both technical basis tasks and functional SD tasks. Use this runbook to manage your month-end simulation. If a step in the runbook takes 50% longer than expected during the simulation, mandate a technical HANA SQL optimization for that specific report before go live.
Category 4 Wrap-Up. User acceptance testing risks.
Category 4 has highlighted the human gatekeeper risks of the migration. We analyzed how non-representative test data, missing business variants, and the failure to simulate the high-pressure month-end close can derail user adoption. The takeaway is that UAT is not a training session. It is the final functional validation of the enterprise's ability to survive on the new digital core. If the users cannot break the system during UAT, they will certainly break it on day 1.
Section 6 Wrap-Up. Testing incidents.
We have completed Section 6, the longest and most critical section of our validation roadmap. We have moved through the functional core, the modular handshakes, the performance limits, and the human acceptance risks. We have seen that S/4HANA testing is a multidimensional discipline that requires 100% production copy data and a search for failure mindset. The system is now validated, but now it must be physically moved to production.
Transition to Section 7 Cutover risks.
The validation is signed off, and the green light has been given. We now enter the most high-pressure 48-hour window of the entire project, the production cutover. In Section 7, we analyze the incidents that occur when technical conversion meets real-world business execution. We will look at runbook errors, transport conflicts, and the high-stakes orchestration required to survive the go-live weekend.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Section 7 Cutover risks.
Section 7 addresses the incidents triggered during the final move to production. This is where the project timeline is measured in minutes, not weeks. At this stage, the risks shift from functional design to technical orchestration and process discipline. We will examine failures in the technical sequence, the consequences of mismanaged data freezes, and the mandatory financial reconciliations that must be performed before the first truck can leave the warehouse.
Section 7, Incident List, Cutover Risks.
The following incidents represent the critical path failures during the production go-live weekend. 170. Cutover sequence errors. Relevant SAP note not applicable cutover and project management. 171. Business freeze scope mismatch. Relevant SAP note not applicable cutover and project management. 172. Transport sequencing conflicts. Relevant SAP note not applicable cutover and project management. 173. Client copy side effects. Relevant SAP note not applicable cutover and project management. 174. Job schedule conflicts. Relevant SAP note not applicable cutover and project management. 175. Authorizations incomplete at go live. Relevant SAP note not applicable cutover and project management. 176. Number range transport errors. Relevant SAP note not applicable cutover and project management. 177. Parallel landscape inconsistencies. Relevant SAP note not applicable cutover and project management. 178. Open transaction handling errors. Relevant SAP note not applicable cutover and project management. 179. Revenue reconciliation not executed. Relevant SAP note 2225170. 180. Workflow activation incomplete. Relevant SAP note not applicable workflow activation governance gap. Section 7 incidents determine if the system opens on time or faces a catastrophic Monday morning rollback.
Scenario 170, Cutover sequence errors.
In the deploy phase of an ECC to S4 HANA migration, the minute-by-minute orchestration of technical and functional tasks is critical. Unlike a standard upgrade, a brownfield conversion requires a specific sequence: technical conversion first, followed by business partner synchronization, then financial transformation, and finally SD document reconciliation. If these tasks are executed out of order, such as attempting to reconcile SD pricing before the CV synchronization is complete, the system will trigger mass data integrity errors, potentially corrupting the document flow and forcing a project rollback.
Scenario classification and relevant SAP note, if applicable.
Complexity, high critical path and system integrity risk. 2. Phase deploy technical conversion window. 3. Frequency common in complex landscapes with multiple interdependent work streams. 4. Primary ownership, project manager and cutover lead. The person who owns this and gets fired if it fails. 5. Supporting basis lead and SD functional lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note not applicable cutover and project management. This is a sequence orchestration and project governance failure.
Diagnostic dashboard, symptoms and evidence.
How cutover sequencing errors manifest during the go-live weekend. 1. Symptom, technical transformation jobs for SD pricing PRCD_elements fail because the corresponding business partner IDs have not been generated. 2. Red flag, the cutover runbook contains parallel tasks for data transformation and configuration transport that share the same database tables. 3. Business impact, the technical downtime window is exceeded by 12 hours as basis teams attempt to rerun failed jobs in the correct order. 4. Detection, error logs in the Software Update Manager or SUM show reference integrity violations for tables VBAK and BUT000. 5. Technical proof, mismatches in the system readiness dashboard where technical milestones are marked as finished, but functional data is missing. Insight, S4 HANA is a house of cards. If you pull the finance card before the master data card, the sales floor collapses.
Why this happens, scenario analysis and root cause.
1. The project team treats the cutover runbook as a simple to-do list without documenting the technical hard dependencies between modules. 2. Failure to conduct a full technical dress rehearsal or TDR to validate the real-world sequence of a brownfield conversion. 3. Siloed workstreams where the FICO team and the SD team execute their post-conversion tasks independently without a central command and control. 4. Pressure to catch up on lost time leads the cutover manager to allow parallel execution of tasks that are technically sequential. The failure is a result of treating an architectural transformation as a standard IT upgrade.
Why this is a migration, exclusive failure.
1. ECC upgrades, EHP upgrades, were in place and rarely involve the multi-step data transformations, CVI, PRCD, ACDOCA, of S/4HANA. 2. S/4HANA migration enforces a dependency chain where master data must be transformed into the BP model before transactional subledgers can be balanced. 3. The technical use of the post-processing office, PPO, during cutover is a unique requirement of the S/4HANA migration path. 4. This failure only occurs during the high-pressure 48-hour window of a brownfield system conversion. Migration introduces a level of intermodule lockstep that ECC never required.
Financial and customer impact.
1. A failed cutover sequence leads to a go-live abort, resulting in a total loss of project investment and a rollback to ECC. 2. Data corruption in the sales document flow leads to incorrect revenue recognition and significant financial audit risks. 3. Operational paralysis as the warehouse remains offline on Monday morning because the shipping routes were not determined in time. 4. Customer frustration as the company is unable to confirm order statuses or issue invoices for several days post-migration. Cutover sequence errors are the leading cause of Monday morning rollbacks.
Governance and accountability, RACI model.
Orchestrating the cutover requires a single point of authority. 1. Accountable project manager and cutover lead, the person who owns this and gets fired if it fails. 2. Responsible basis lead executes the technical conversion sequence and monitors the technical gate completion. 3. Consulted SD and FICO lead provide the functional dependencies and validate the data state at each gate. 4. Informed executive steering committee makes the final go or no-go decision based on the runbook status. Accountability ensures that no task starts until its prerequisite is 100% confirmed.
Ownership, who actually fixes it.
Resolving this requires a dependency-first planning strategy. 1. Cutover lead creates a minute-by-minute master runbook identifying the specific owner and duration for every task. 2. Basis lead enforces technical gates where the system is locked until the previous module's transformation is verified. 3. SD functional lead executes functional smoke tests, for example, creating a sales order immediately after the CV sync finishes. 4. The project manager facilitates a simulation week where the entire team practices the sequence in a non-production environment.
Who gets blamed versus who owns it.
1. Blamed basis team, the business assumes the system upgrade was buggy. 2. Blamed SAP, the project team claims the SUM tool does not handle dependencies. 3. Actual owner, project manager and cutover lead responsible for the failure to design a technically sound orchestration sequence. 4. Root cause, treating the cutover as a list of tasks rather than a connected technical workflow. The sequence is the strategy. If the sequence is wrong, the strategy fails.
How this is actually fixed, the right way by a role.
1. Project manager mandates a no parallel path policy for core data transformations during the first 24 hours of cutover. 2. The team implements dependency validation scripts that check for record counts in parent tables before child jobs are allowed to start. 3. Basis lead utilizes the phase-specific logging in the SUM tool to identify bottlenecks and adjust the sequence for the next mock. 4. Functional leads execute gate sign-offs, where the next phase of the cutover cannot proceed without a formal signature from the previous lead.
What not to do, common wrong fixes.
1. Do not allow functional tweaks to be performed while the technical conversion, SUM, is still active. 2. Do not skip technical gates to make up for lost time. This will only lead to more complex failures later in the weekend. 3. Do not assume that the order of operations from an ECC upgrade applies to S/4HANA. It does not. 4. Do not allow multiple users to have SAP_all access during the cutover, as they may accidentally trigger tasks out of sequence. Shortcuts in the cutover sequence will lead to a day 1 system-wide data integrity crisis.
Follow-up 1. What is the most critical hard dependency in an SD brownfield cutover?
Answer: the most critical dependency is configuration transports to master data CV async to transactional table conversion. If you attempt the CV async before the business partner configuration is imported, every single customer record will fail to synchronize, blocking the entire migration.
Follow-up 2. How can I minimize the risk of sequencing errors in a global rollout?
Answer: you must use a regional gate approach. The global technical conversion happens once, but each regional functional team must have their own specific subsequence and sign-off window. This ensures that a localization error in one country does not block the go-live for the rest of the world.
Follow-up 3. Curveball. How do you manage a scenario where the technical conversion of the SD pricing table, KONV, is 90% complete, but the FICO team discovers a critical ledger mismatch that requires a configuration change and a rerun of the universal journal transformation, while the warehouse team is already demanding access to the system to print shipping labels for the Monday morning wave?
Answer: this is a crisis decision event. You must follow the point of no return logic defined in your runbook. In S/4HANA, you cannot pause the pricing conversion to fix a FICO ledger error because they share the same architectural core. You must execute a hard lock on the warehouse, stop the FICO team, and finish the pricing conversion first. Once the database is stable, you apply the FICO fix and rerun the entire financial transformation loop. If you try to fix both at once, you will trigger a database deadlock and likely corrupt the metadata. You must communicate a downtime extension to the warehouse rather than risking the integrity of the financial subledger.
Exclusive pro tip.
Add wait tasks of 15 minutes between each major cutover section. Use this time to perform a technical smoke check of the database logs. In the world of S/4HANA conversion, silence is not always success. You must verify the result before moving to the next task.
Scenario 171. Business freeze scope mismatch.
In the deploy phase of an ECC to S/4HANA migration, the organization enters a data blackout period. However, a failure occurs when there is a mismatch between the IT system lock and the business stop-work reality. If regional warehouses or external e-commerce interfaces continue to push sales orders, deliveries, or payments into ECC after the final data migration snapshot has been taken, these transactions become orphan data. They exist in the legacy system but are missing from S/4HANA, creating immediate financial imbalances and customer service failures on day 1.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial integrity and operational continuity risk. 2. Phase, deploy technical cutover. 3. Frequency, extremely common in 24/7 global operations. 4. Primary ownership, project manager and business lead, the person who owns this and gets fired if it fails. 5. Supporting SD functional lead and basis lead. 6. Business ownership, global operations director. 7. Relevant SAP note, not applicable cutover and project management. This is a process discipline and communication failure.
Diagnostic dashboard, symptoms and evidence.
How business freeze gaps manifest during the go-live phase. 1. Symptom, a strategic customer calls to track an order they placed last night, but the order ID does not exist in the new S/4HANA system. 2. Red flag, transaction SM21 in the legacy ECC system shows document created events timestamped after the official freeze deadline. 3. Business impact, inability to fulfill hundreds of leaked orders, resulting in lost revenue and a negative first impression of the new system. 4. Detection, comparing the highest document number in ECC at the start of the weekend against the snapshot data reveals new numbers were generated. 5. Technical proof, interface logs in the middleware show a success status for postings to the legacy system during the scheduled blackout window. Insight, a data freeze is not an instruction. It is a technical lock that must be enforced by IT.
Why this happens, scenario analysis and root cause.
1. Poor communication of the global cutoff time across multiple time zones, leading to regional teams working past the deadline. 2. Failure to deactivate inbound EDI and e-commerce background jobs in the legacy ECC system before taking the final data snapshot. 3. Support teams using emergency user IDs to fix late Friday issues in ECC, inadvertently creating new data that was not part of the migration scope. 4. Underestimating the process tail, where a delivery started before the freeze results in a goods issue that completes after the freeze. The failure is a result of treating the data freeze as a social contract rather than a technical barrier.
Why this is a migration exclusive failure.
1. Standard ECC upgrades happened in place, so any data created during the upgrade remained in the system. There was no source-to-target gap. 2. S/4HANA brownfield conversion involves a database transformation that is point-in-time based. Anything created after the snapshot is physically lost to the process. 3. The Delta catch-up process for SD transactions is notoriously complex and often requires manual re-entry, which ECC upgrades never required. 4. This failure only surfaces when the organization attempts to reconcile the final legacy balances with the new S/4HANA production ledger. Migration creates a data cliff that standard ECC maintenance never encountered.
Financial and customer impact.
1. Revenue leakage occurs as leaked invoices in ECC are never processed in S/4HANA, resulting in services delivered but never billed. 2. Audit failures as the general ledger in S/4HANA cannot be reconciled to the final audited state of the ECC system. 3. High operational costs as a special task force must manually identify and re-enter all missing transactions into the live system. 4. Severe loss of customer trust as in-flight orders disappear, forcing customers to replace orders or cancel them entirely. Freeze mismanagement directly compromises the financial continuity of the migration project.
Governance and accountability, RACI model.
Managing the data freeze requires authority over both technical and business operations. 1. Accountable project manager and business lead, the person who owns this and gets fired if it fails. 2. Responsible basis lead executes the technical locking of all users' transaction SU10 and deactivates RFC gateways. 3. Consulted global operations director confirms that all regional business units have successfully stopped work. 4. Informed integration lead ensures that all inbound middleware queues are paused and verified as empty. Accountability ensures that the system is technically dead before the migration snapshot is taken.
Ownership, who actually fixes it.
Resolving this requires a double audit of the legacy system state. 1. Cutover lead performs a system state check in ECC 15 minutes after the freeze to ensure 0 active sessions. 2. SD functional lead creates a last document ID report for all O2C objects, orders, deliveries, invoices at the exact moment of the snapshot. 3. Basis lead deactivates the SAP job scheduler, transaction BTCTRNS1, to prevent any background tasks from creating data. 4. The team performs a Delta recon on Monday morning, comparing the snapshot ID to the live ID in ECC to identify any leaked records.
Who gets blamed versus who owns it.
1. Blamed basis team. The business assumes IT failed to lock the doors. 2. Blamed business users. The project team assumes users ignored the instructions. 3. Actual owner, project manager, and business lead responsible for the failure to verify and enforce the system blackout. 4. Root cause, treating the data freeze as a policy rather than a technical enforcement event. In a cutover, trust is good. Technical locking is better.
How this is actually fixed, the right way by a role.
1. Project manager mandates a hard system lock where transaction SCC4 is set to no changes allowed immediately after the snapshot. 2. Integration architect implements queue blocking in the middleware, SAP PI and PO or BTP, to prevent external data from reaching the SAP kernel. 3. Basis lead locks all non-essential users and changes the background user passwords to prevent interface retriggers. 4. The team implements a shadow client, a read-only copy of ECC for users to check history while the migration proceeds, reducing the temptation to log into prod.
What not to do, common wrong fixes.
1. Do not rely on corporate communication to stop users. There will always be a user who needs to finish one more thing. 2. Do not leave the inbound IDOC queue active. Even if the UI is locked, the background process can still create data. 3. Do not attempt to delete leaked data in the legacy ECC system. This creates a nightmare for auditors who want to see the sequence. 4. Do not skip the final row count comparison between the ECC snapshot and the S/4HANA load files. Shortcuts in freeze enforcement result in a dirty go-live that takes weeks to reconcile.
Follow-up 1. How do I technically identify data that leaked during the freeze?
Answer: you must record the high watermark for every transactional table VBAK, LIKP, VBRK at the moment of the snapshot. After the freeze begins, run a query in ECC to find any records with an ID higher than that mark. These are your leaked records that must be manually addressed in the S/4HANA system.
Follow-up 2. What happens if a leaked order in ECC is for a high-priority customer?
Answer: you cannot simply import it into the running S/4HANA conversion. You must document it, and then manually enter it into S/4HANA once the system is live on Monday. You must then manually cancel the original order in the old ECC system to ensure the audit trail is clear.
Follow-up 3. Curveball. How do you handle the scenario where the ECC system is technically locked, but an external third-party logistics or 3PL provider sends a goods issue confirmation for 5,000 deliveries via an asynchronous web service that is still pointing to the ECC production URL, and the middleware auto-retries the connection for 48 hours until it finally finds a gap in the firewall during the system restart, successfully posting the inventory reductions into the legacy system after the S/4HANA system has already gone live with the original inventory levels.
Answer: this is the synchronous persistence nightmare. Your inventory in S/4HANA is now inflated compared to the physical warehouse reality. You must test the interface DNS switch. The fix is to change the ECC URL at the DNS or load balancer level to point to a dead end or a holding client during the cutover. Simply locking the ECC user is not enough because a persistent middleware will keep knocking on the door. You must perform a post-cutover interface audit, comparing the 3PL's outbound log against the S/4HANA inbound log to find these lapse confirmations, and manually adjust the S/4HANA inventory levels before the first picking wave begins.
Exclusive pro tip.
Establish an ECC Ghost team during the go-live weekend. Their only job is to monitor transaction SM21 and SM04 in the old ECC system. If they see any user activity or document creation after the freeze, they have the authority to immediately kill the session and alert the cutover lead.
Scenario 172. Transport sequencing conflicts.
In the deploy phase of an ECC to S/4HANA migration, the orchestration of the transport buffer is a high-risk technical activity. A brownfield conversion typically involves hundreds of transports covering remediate ABAP code, new S/4HANA configuration, and data mapping rules. If these transports are imported out of sequence, such as importing an ABAP pricing routine before the corresponding transparent table structure or the SAP note for the pricing engine, the system will trigger a technical collision, leading to inactive objects, syntax errors, and a stalled cutover.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high technical stability and landscape integrity risk. 2. Phase deploy technical cutover. 3. Frequency common in complex landscapes with multiple development workstreams. 4. Primary ownership basis lead and ABAP lead. The person who owns this and gets fired if it fails. 5. Supporting SD functional lead and cutover manager. 6. Business ownership IT transformation director. 7. Relevant SAP note, not applicable cutover and project management. Reference SAP note 2198647 for code adaptation context.
Diagnostic dashboard, symptoms and evidence.
How transport sequencing errors manifest during the cutover window. 1. Symptom: the transport import log in transaction SDMS shows a return code 8 error for a critical SD pricing or billing object. 2. Red flag: developers are manually reactivating objects in the production system because they imported in an inactive state. 3. Business impact: inability to execute smoke tests post-conversion because the sales order screen VA01 is throwing a syntax error dump. 4. Detection: checking transaction SBAU and SPDD reveals unresolved conflicts that were supposedly fixed in the development environment. 5. Technical proof. Transport logs show that a method was imported before the class definition existed in the target system. Insight. A transport is not a file. It is a technical dependency. If you ignore the order, you break the logic.
Why this happens, scenario analysis and root cause.
1. The project team failed to maintain a master transport tracker during the year-long realize phase, leading to ghost transports. 2. Parallel development workstreams, for example, one for CVI and one for FICO, created overlapping changes in the same SD includes without coordination. 3. Basis teams utilize mass import all, which does not always respect the logical dependencies of custom ABAP objects. 4. Lack of a transport freeze period, where developers continued to create new transports while the cutover mocks were already in progress. The failure is a result of technical siloing, where different teams assume their transports are independent.
Why this is a migration, exclusive failure.
1. In standard ECC maintenance, the volume of transports is low and easily managed. S/4HANA migration involves thousands of objects moving at once. 2. The S/4HANA technical conversion requires a specific interleaving of SAP standard updates and custom Z code remediation transports. 3. The requirement to resolve conflicts in SPDD and SBAU creates a unique transport bridge that is specific to the migration lifecycle. 4. This failure only surfaces when the final production system is being assembled from the various project development tracks. Migration creates a logistical storm for transports that ECC maintenance never encounters.
Financial and customer impact.
1. A failed transport import can corrupt the entire sales kernel, requiring a system restore and losing 24 hours of cutover downtime. 2. Revenue leakage if pricing routines are inactive or partially imported, resulting in $0 invoices being sent to customers. 3. Supply chain paralysis as delivery document creation is blocked by syntax errors in shipping point determination logic. 4. Audit risk if the final production state does not match the tested QA state due to transport sequencing variances. Transport sequencing errors directly jeopardize the stability of the enterprise digital core.
Governance and accountability, RACI model.
Managing transport flows requires a centralized registry authority. 1. Accountable basis lead and ABAP lead, the person who owns this and gets fired if it fails. 2. Responsible transport coordinator manages the import buffer and ensures the cutover sequence is strictly followed. 3. Consulted SD functional lead validates that the configuration is imported before the master data loads begin. 4. Informed IT transformation director monitors the import success rate as a key indicator of cutover health. Accountability ensures that no object is moved to production without a documented dependency check.
Ownership, who actually fixes it.
Resolving this requires a clean buffer and dependency audit. 1. Basis lead performs a buffer cleanup in SDMS, removing any obsolete or superseded project transports. 2. ABAP lead utilizes transaction SE03 to check for object overlaps between different transport requests. 3. SD functional lead creates the functional dependency list, for example, load company codes before sales orgs. 4. The team executes a dry run of the transport sequence during the final mock migration to verify the exact import time and result codes.
Who gets blamed versus who owns it.
1. Blamed basis team. The developers assume basis imported the wrong files. 2. Blamed SAP. The business assumes the transport management system is unreliable. 3. Actual owner basis lead and ABAP lead jointly responsible for the failure to manage the technical dependencies of the code. 4. Root cause, treating transport management as a file copy task instead of a logic integration task. A transport error is a communication failure, not a system bug.
How this is actually fixed, the right way by a role.
1. Basis lead mandates a hard transport sequence where transports are grouped into tiers. Tier 1 DDIC, Tier 2 configuration, Tier 3 code. 2. The team implements cross-project conflict analysis using SAP Solution Manager or CHA-RM to prevent overlapping changes. 3. Technical architect utilizes consolidation transports to merge multiple small changes into one stable object before the final cutover. 4. The project team executes an import and activate loop, importing a small set of transports and checking for syntax errors before proceeding.
What not to do, common wrong fixes.
1. Do not use import all with the ignore invalid component version flag. This is a recipe for system corruption. 2. Do not allow manual changes in the production system to bypass a transport error. You must fix the transport in dev and re-import. 3. Do not skip the generation of programs transaction SGEN after a mass transport import, as hidden syntax errors will remain. 4. Do not assume that the import date in the QA system is the same as the sequence required for the production system. Shortcuts in transport sequencing will lead to a permanently unstable and unpatchable production environment.
Follow-up 1. What is the risk of superseded transports in a migration?
Answer: a superseded transport contains an older version of an object. If a developer creates transport A, then transport B the fix, but the basis team imports B and then during cutover, the fix will be overwritten by the error. You must lock the transport sequence to ensure the latest version always wins.
Follow-up 2. How does S/4HANA change the transport profile for SD?
Answer: S/4HANA introduces many new object types, such as CDS metadata extensions and BRF plus decision tables. These objects have different transport headers and activation rules than classic ABAP. You must ensure your basis team is trained on how to import these modern artifacts to avoid inactive object errors.
Follow-up 3. Curveball. What if a transport contains a data element change that requires a mass conversion of a 1 terabyte SD table like VBFA, and the basis team imports it mid-cutover, while the CV synchronization is also trying to access the same table, resulting in a database-exclusive lock failure that crashes the transport engine and corrupts the table index?
Answer: this is an architectural collision. You must test dictionary transports separately. The fix is to identify any table-altering transports and move them to the very start of the cutover, immediately after the SUM downtime. You must execute them while the application server is still quiet and before any master data synchronization or transactional loads begin. If you miss this, the DB-level alter table command will collide with the sync command, leading to an index corruption. You must perform a metadata audit of all transports 72 hours before the cutover to flag these high-risk objects.
Exclusive pro tip.
Create a dependency matrix for your top 50 custom SD programs. List the specific tables and configuration objects they require. Give this matrix to your basis lead and mandate that no code transport is imported until all prerequisite configuration is confirmed as green in the target system.
Scenario 173. Client copy side effects.
In the deploy phase of an ECC to S/4HANA migration, organizations often use client copy or system refresh to create the final production environment or the hypercare sandbox. However, failure to manage client-dependent versus cross-client settings results in critical SD failures. If RFC destinations, output device mappings, or background job owners from the source system are carried over into the target environment, the system will attempt to post sales data to the wrong general ledger or send customer invoices to a test printer, leading to data leaks and financial inaccuracy.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium technical infrastructure and security risk. 2. Phase deploy technical cutover. 3. Frequency common in multi-tier landscapes with frequent system refreshes. 4. Primary ownership basis lead, the person who owns this and gets fired if it fails. 5. Supporting SD functional lead and security lead. 6. Business ownership IT transformation director. 7. Relevant SAP note, not applicable cutover and basis execution. Reference SAP note 1614266 for system copy technical context.
Diagnostic dashboard, symptoms and evidence.
How client copy side effects manifest during the transition. 1. Symptom. Creating a sales order triggers a short dump call function remote error because the system is trying to call an ECC sandbox RFC. 2. Red flag. Transaction SM59 contains destinations that point to QA or DEV systems instead of the new S/4HANA production landscape. 3. Business impact. Sensitive financial sales data is leaked into a test environment or critical tax calls, to Vertex or Avalara fail because the credentials are legacy. 4. Detection checking transaction BDLS reveals that the logical system name has not been converted to the production ID. 5. Technical proof errors in the spool monitor transaction SB01, showing invoices being sent to a printer located in a different geographical region. Insight: a client copy is a brain transplant. If you do not reconnect the nerves, RFCs, and IDs, the body will not function.
Why this happens, scenario analysis and root cause.
1. Basis teams use standard client copy profiles, for example, SAP_all, which include technical settings that should have been excluded for a production system. 2. Failure to execute transaction BDLS, logical system conversion, which is required to update thousands of internal table references from legacy to target IDs. 3. The project team fails to perform a post-copy technical cleanup, ignoring the SD-specific integration points like distribution model or partner profiles. 4. Hard-coded application server paths or file directory names in custom SD ABAP code that point to non-existent locations in the new landscape. The failure is a result of treating a client copy as a purely basis task without functional validation.
Why this is a migration, exclusive failure.
1. In ECC, the landscape was established for years. System refreshes were predictable and rarely impacted the stable O2C core. 2. S4 HANA migration involves moving from an ECC logical system to an S4 HANA logical system, which triggers a cross-system identity crisis. 3. The use of the S4 HANA Migration Cockpit, LTMC, creates staging tables in the /1 LT/ namespace that are highly sensitive to logical system changes. 4. This failure only surfaces when the newly refreshed S4 HANA environment attempts to communicate with the rest of the enterprise ecosystem. Migration turns a routine refurbishment into a critical identity transformation.
Financial and customer impact.
1. Operational disruption on day 1 as interfaces fail to post sales data, resulting in missed delivery windows and revenue deferral. 2. Security risk as production data is visible in non-production systems through unsevered RFC links. 3. Inaccurate inventory reporting if the system communicates with a warehouse management system that is still in test mode. 4. Loss of ROI as the company spends thousands on cleanup consulting to fix errors that should have been handled by the Cutover runbook. Client copy side effects directly compromise the security and reliability of the go-live.
Governance and accountability, RACI model.
Ensuring system integrity requires a post-copy technical verification. 1. Accountable basis lead, the person who owns this and gets fired if it fails. 2. Responsible technical architect performs the BDLS conversion and the RFC destination cleanup. 3. Consulted SD functional lead provides the list of critical external endpoints, for example, printers, tax engines, 3PL. 4. Informed IT transformation director manages the technical readiness sign-off after each environment refresh. Accountability ensures that the system is cleaned before it is opened.
Ownership, who actually fixes it.
Resolving this requires a technical scrub and identity conversion. 1. Basis lead utilizes transaction SCC1 to selectively copy only functional data while excluding technical RFC and background job data. 2. Technical architect executes transaction BDLS for all client-dependent tables to update the logical system name to the production ID. 3. SD functional lead executes transaction SM59 and verifies that all Type G and Type 3 destinations point to production URLs. 4. Security lead performs a connection audit to ensure no cross-client backdoors exist between the new S4 HANA system and legacy ECC.
Who gets blamed versus who owns it.
1. Blamed basis team. The business assumes basis did not copy the data correctly. 2. Blamed SAP. The users claim S4 HANA is not compatible with our interfaces. 3. Actual owner. Basis lead responsible for the failure to manage the post-copy infrastructure updates. 4. Root cause, treating a system copy as a simple snapshot while ignoring the logical identity of the system. A copy is not a clone. You must always reintroduce the new system to its neighbors.
How this is actually fixed, the right way by a role.
1. Basis lead mandates a post-copy checklist that includes transaction BDLS, SM59, and SCOT for email cleanup. 2. The team implements substitution variables for RFC destinations, ensuring that the system automatically points to the correct environment. 3. Technical architect utilizes transaction BD64 to verify the distribution model and ensures no legacy ECC IDs remain. 4. Functional leads execute communication testing, sending a test email and a test print job to verify the infrastructure layer.
What not to do, common wrong fixes.
1. Do not run a full copy of the production ECC system into the S4 HANA sandbox without immediately deactivating all outbound RFCs. 2. Do not skip transaction BDLS because it takes too long. An incomplete conversion will cause silent data corruption in the future. 3. Do not ignore background job owners. If the job owner is a user who no longer exists in the target system, the job will fail. 4. Do not leave test email addresses in the customer master of the newly copied system. Shortcuts in post-copy cleanup result in a system identity conflict that will paralyze your interfaces.
Follow-up 1. What is transaction BDLS, and why is it the holy grail of client copies?
Answer: BDLS is the logical system conversion tool. Every SAP table that contains a field for logical system must be updated when you move data between environments. If you copy data from ECC ID ECC prod to S4 HANA ID S4 prod, but do not run BDLS, the system will still think it is ECC prod, causing every cross-system interface to fail.
Follow-up 2. How do I server the links between my newly copied system and the rest of the world?
Answer: immediately after the copy, you should go to transaction SM59 and invert the RFC destinations. You can use a mass script to change all URLs to localhost or a dummy IP address. This prevents the system from accidentally reaching out and sending data to production systems while you are still in the cleanup phase.
Follow-up 3. Curveball. How do you handle a scenario where transaction BDLS was executed for 100% of standard SAP tables, but the S4 HANA system still attempts to post financial accruals for migrated sales orders to the legacy ECC archive system because a custom Z table used to store historical revenue IDs was defined as a character field rather than a logical system data element, causing it to be bypassed by the BDLS conversion engine?
Answer: this is a metadata mapping failure. The BDLS tool only identifies fields that are technically linked to the logsys data element. If your custom table used a generic char 10 field to store the system ID, BDLS is blind to it. You must test the custom metadata integrity. The fix is to perform a global string search in the database for the old logical system name. For example, ECC prod. Any hits in Z tables that were missed by BDLS must be updated via a custom SQL script. You must perform this deep scan during your final technical dress rehearsal to avoid a day one data routing crisis.
Exclusive pro tip.
Create a communication snapshot before you perform any client copy. List the top 10 RFCs and the primary SMTP email server. Immediately after the copy is finished, verify that these 11 endpoints are either severed or pointed to the correct target system. Never trust the automatic cleanup settings of the client copy tool.
Scenario 174. Job schedule conflicts.
In the technical conversion window of an ECC to S4 HANA migration, uncoordinated background jobs frequently derail the cutover timeline. While the system is in the middle of a physical table transformation, such as the pricing or document flow move, legacy background jobs for billing or credit reorg might automatically restart. This leads to massive database deadlocks and the corruption of in-flight document data, forcing an immediate and expensive rollback of the entire conversion.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium system stability and cutover window impact. 2. Phase deploy technical conversion window. 3. Frequency, extremely common in large systems with complex job schedules. 4. Primary ownership basis lead, the person who owns this and gets fired if it fails. 5. Supporting SD functional lead and cutover lead. 6. Business ownership IT transformation director. 7. Relevant SAP note, not applicable cutover and basis execution. This is an IT operational failure.
Diagnostic dashboard, symptoms and evidence.
How job conflicts manifest during the conversion downtime. 1. Symptom. The technical conversion tool hangs with the error unable to acquire exclusive lock on table PRCD_elements. 2. Red flag. Transaction SM37 shows active jobs for billing or IDOC processing during the scheduled blackout period. 3. Business impact. The conversion downtime window is exceeded as basis teams are forced to manually kill zombie background jobs. 4. Detection. Checking transaction SM12 reveals hundreds of technical locks held by the background user WF batch. 5. Technical proof. System logs in SM21 show database deadlock detected during a critical S/4HANA data transformation report. Insight. A single active job during the conversion window can turn a 48-hour migration into a 72-hour disaster.
Why this happens, scenario analysis and root cause.
1. The project team failed to execute transaction BTCTRNS1 to suspend the background job scheduler before starting the conversion. 2. Implicit background tasks triggered by the post-processing office or workflow were not factored into the system shutdown plan. 3. Interface jobs from external middleware were not stopped at the source, allowing them to re-trigger the SAP kernel during downtime. 4. The system copy used for the conversion inherited the job schedule from production without disabling the periodic flag. The failure is a result of technical collision, where legacy automation disrupts the migration engine.
Why this is a migration, exclusive failure.
1. ECC upgrades were less sensitive to data transformation locks as the table structures remained static. 2. S/4HANA migration involves a physical restructuring of tables. You cannot have a job reading KONV while the system is deleting it. 3. The use of the SUM shadow instance creates a unique risk where jobs might accidentally start in the shadow system. 4. This failure only occurs during the technical data conversion phase of the S/4HANA brownfield path. Migration requires an absolute system silence that standard maintenance never approached.
Financial and customer impact.
1. A failed conversion results in an immediate rollback, costing the company hundreds of thousands of dollars in lost project effort. 2. Risk of data corruption if a background job partially processes a document while the transformation engine is moving it. 3. Business disruption on Monday morning as users find that nightly billing jobs were interrupted and must be manually restarted. 4. Loss of management trust when the technical team cannot explain why the system crashed during the go-live window. Job conflicts are the silent killers of a successful cutover weekend.
Governance and accountability, RACI model.
Managing background jobs requires an integrated IT operations view. 1. Accountable basis lead. The person who owns this and gets fired if it fails. 2. Responsible cutover manager defines the stop and start sequence for all business-critical background jobs. 3. Consulted SD functional lead provides the inventory of O2C jobs that must be verified as finished. 4. Informed. IT transformation director manages the downtime schedule and communicates delays to the executive board. Accountability ensures that the technical conversion engine has 100% of the system resources.
Ownership, who actually fixes it.
Resolving this requires a full job inventory and a technical shutdown. 1. Basis lead executes transaction BTCTRNS1 to suspend all periodic jobs and verifies the status in table TBTCO. 2. SD functional lead uses transaction SM37 to find in-process sales jobs and confirms they are safe to kill. 3. Technical architect ensures that all RFC destinations in transaction SM59 are locked to prevent external system triggers. 4. The team performs a post-downtime cleanse, identifying any jobs that were interrupted and manually rescheduling them.
Who gets blamed versus who owns it.
1. Blamed, basis team. The business assumes basis forgot to stop the jobs. 2. Blamed, SAP. The project team claims the SUM tool is not handling locks correctly. 3. Actual owner, basis lead and cutover manager jointly responsible for the failure to define a hard system shutdown procedure. 4. Root cause, treating the conversion as a background process while ignoring the existing legacy automation layer. A job conflict is an operational planning failure, not a software bug.
How this is actually fixed, the right way by a role.
1. Basis lead mandates a hard system lock where transaction SCC4 is used to prevent any logical data changes. 2. The team implements a job blackout list, identifying every periodic job and assigning a specific cutover owner. 3. Technical architect utilizes kernel-level locks to prevent the scheduler from starting new tasks during the SUM execution. 4. Functional leads execute a job audit immediately after go-live to verify that the first 50 jobs started on schedule.
What not to do, common wrong fixes.
1. Do not leave inbound IDOC queues active. A single incoming order will trigger a task and block the table conversion. 2. Do not assume transaction BTCTRNS1 handles custom Z jobs and schedulers. You must manually verify those. 3. Do not try to restart a failed conversion step without checking SM12 for lingering locks first. 4. Do not forget to notify external partners to stop their data transmissions during the weekend. Shortcuts in job management result in a dirty downtime that risks the integrity of the new system.
Follow-up 1. What is transaction BTCTRNS1 and why is it important?
Answer: it is the job suspension tool. It takes all scheduled periodic jobs and marks them as suspended so the scheduler cannot start them while the technical conversion is running. After the cutover, you use BTCTRNS2 to release them.
Follow-up 2. How do I handle a job that was killed mid-process?
Answer: you must perform a functional recovery. Check the database to see which records were processed and which were missed, then manually reschedule the job for only the missing subset to avoid duplicates.
Follow-up 3. Curveball. What if a job is technically suspended, but its underlying event is still triggered by an external system, causing a massive backlog that crashes the system the moment it is unlocked?
Answer: this is an event queue overflow. You must test the event clearing logic. The fix is to deactivate the event linkage in transaction SWE2 before the cutover. If you only suspend the job but leave the event active, thousands of trigger requests will pile up in the system buffer, causing a kernel-level hang on Monday morning. You must purge or process these events in small blocks after go-live.
Exclusive pro tip.
Establish a silent night protocol 4 hours before the conversion begins. All jobs must be finished and all RFC gateways closed. If SM37 shows even one active job at the start of the SUM phase, stop the migration immediately.
Scenario 175. Authorizations incomplete at go-live.
In the deploy phase of an ECC to S/4HANA migration, organizations often discover that users cannot execute basic SD transactions. S/4HANA introduces a new security model where SAP GUI authorizations must be supplemented by Fiori catalogs, groups, and OData service permissions. If the security team fails to provision these modern roles before go-live, users will log into a blank Fiori launchpad or encounter no authorization errors when saving sales orders, paralyzing the business.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium security, and user adoption risk. 2. Phase deploy technical cutover. 3. Frequency common in projects moving from SAP GUI to Fiori. 4. Primary ownership SAP security and GRC lead. The person who owns this and gets fired if it fails. 5. Supporting SD functional lead and Fiori lead. 6. Business ownership sales operations manager. 7. Relevant SAP note, not applicable cutover and project management. This is a security governance failure.
Diagnostic dashboard, symptoms and evidence.
How authorization gaps manifest during the go-live window. 1. Symptom: users report a blank screen after logging into the Fiori launchpad for the first time. 2. Red flag: technical error logs in transaction/IWFND/error_log show thousands of 403 forbidden errors for OData services. 3. Business impact: total operational stop as sales reps cannot create orders and warehouse staff cannot see delivery work lists. 4. Detection: testing with a production copy user ID reveals that the managed sales orders tile is missing from the dashboard. 5. Technical proof, transaction SU53 shows missing authorizations for the S4HANA specific object S_service. Insight in S4HANA, security is a two-key system. You need the backend PFCG role and the front-end Fiori catalog.
Why this happens, scenario analysis and root cause.
1. The security team used legacy ECC roles without adding the mandatory OData service and Fiori app permissions. 2. A lack of persona-based testing where the technical team tested with SAP_ all rather than restricted business roles. 3. Failure to synchronize the transport of roles with the activation of OData services during the cutover sequence. 4. Underestimating the impact of business partner authorizations, which are separate from traditional customer master permissions. The failure is a result of treating S4HANA security as a simple copy-paste of ECC roles.
Why this is a migration, exclusive failure.
1. ECC upgrades never changed the fundamental security architecture or introduced a new UI layer like Fiori. 2. S4HANA migration moves the organization to a web-based architecture that requires service-level authorizations. 3. The move from customer to business partner introduces new authorization objects like B_BUPA_GRP that ECC never used. 4. This failure only surfaces when the organization attempts to operate the system through the new Fiori interface. Migration introduces a UI security layer that ECC security teams have never managed before.
Financial and customer impact.
1. Immediate revenue loss as the business cannot process orders, leading to missed delivery slots and customer penalties. 2. Damaged customer trust when sales reps cannot answer inquiries because they lack the permissions to view sales history. 3. High cost of emergency security support as consultants must manually trace and patch thousands of user roles post-go-live. 4. Audit risk if security teams open up the system with broad permissions as a temporary fix to clear the backlog. Authorization failures are the most frustrating way to halt an O2C process.
Governance and accountability, RACI model.
Securing the go-live requires a partnership between security and UX leads. 1. Accountable SAP security and GRC lead, the person who owns this and gets fired if it fails. 2. Responsible security administrator performs the role maintenance and OData service assignments. 3. Consulted Fiori and UX lead provides the final list of catalogs and groups required for each business persona. 4. Informed sales operations manager validates that their team has full access to the required O2C apps. Accountability ensures that user access is a mandatory gate for system readiness.
Ownership, who actually fixes it.
Resolving this requires a persona-based audit and service activation. 1. SAP security lead identifies every legacy role and adds the required S4HANA authorization objects for BP and pricing. 2. Fiori lead utilizes transaction/IWFND/main_service to ensure all O2C OData services are active in the production client. 3. ABAP development team ensures that custom CDS views have corresponding DCL authorization files. 4. The team performs a first login test for 10 key personas, verifying that the dashboard and apps are 100% functional.
Who gets blamed versus who owns it.
1. Blamed security team. The business assumes IT forgot to give them access. 2. Blamed SAP users claim the Fiori apps are broken because they will not load. 3. Actual owner SAP security and GRC lead responsible for the failure to perform a realistic security UAT cycle. 4. Root cause, treating S4HANA security as a back-end task while ignoring the front-end requirements. If a user cannot see the app is broken from their perspective.
How this is actually fixed, the right way by a role.
1. SAP security lead mandates a 0 SAP_all policy for the final integration testing cycle. 2. The team implements task-based roles rather than module-based roles to simplify the Fiori launchpad layout. 3. Technical architect utilizes transaction SDAuthTrace to capture missing service permissions during UAT. 4. Functional leads execute a security smoke test immediately after the conversion, logging in as a sales rep to create an order.
What not to do, common wrong fixes.
1. Do not grant wide open roles to users on day 1 to bypass security errors. This creates a permanent SOD audit violation. 2. Do not assume that if a transaction works in SAP GUI, it will work in Fiori. The authorization paths are different. 3. Do not ignore service not found errors in the browser console. They are usually authorization issues, not network issues. 4. Do not allow go live without a persona-based security sign-off for every major O2C job function. Shortcuts in security validation will lead to a day one operational crisis and long-term audit risk.
Follow-up 1. Why do users need OData authorizations in S4HANA?
Answer: Fiori apps do not talk to the database directly. They talk to an OData service, which then talks to the database. If a user has the permission to save a sales order but lacks the permission to call the OData service, the app will hang or return a forbidden error.
Follow-up 2. What is the most common missing object in S4HANA SD security?
Answer: it is usually the S_service object. This object controls which OData and SOAP services a user can execute. Because it did not exist in the same way in ECC, it is often forgotten during the role migration process.
Follow-up 3. Curveball. What if a user has the right Fiori role to create an order, but the stateless OData call fails because the technical user in the background lacks the permission to update the new S4HANA pricing table?
Answer: this is a cross-layer authorization failure. S4HANA pricing often triggers secondary updates in the background. You must test the technical execution user context. The fix is to use transaction SU53 specifically for the background process, or check the system logs for authority check failures on table PRCD_elements. You must ensure that the security model accounts for both the user action and the system reaction layers to avoid silent data save failures.
Exclusive pro tip.
Add a security trace task to your final UAT day. Ask 5 users to perform their entire daily O2C routine while transaction SD0-1 is running in the background. This will identify 100% of the missing objects that standard unit tests always miss.
Scenario 176. Number range transport errors.
In the technical conversion window of an ECC to S4HANA migration, the transport of number range objects often leads to critical data collisions. While number range intervals can be transported, the current number status or levels are technically client-dependent and do not move with the transport. If the basis team ignores the manual update of these levels in the new production system, users will attempt to create documents using IDs that already exist in the migrated history, triggering immediate update terminations in the sales and billing cycles.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium technical integrity and transactional risk. 2. Phase, deploy technical cutover. 3. Frequency, common in multi-tier landscapes during the final conversion. 4. Primary ownership, basis lead. 5. Supporting SD functional lead and MDM lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note, not applicable cutover and basis execution. This is a technical orchestration and transport governance failure.
Diagnostic dashboard, symptoms and evidence.
How number range transport errors manifest during the go-live window. 1. Symptom, creating a sales order, VA01, results in a runtime error, SAP SQL_array_insert_duprec referencing table VBAK. 2. Red flag, transport logs for number range objects show return code 0, giving a false sense of success while the status remains at 0. 3. Business impact, complete operational halt as the system refuses to generate new document numbers for orders, deliveries, or invoices. 4. Detection, checking transaction SNRO for object RV_beleg reveals the current number is set to 1, while the database already contains millions of records. 5. Technical proof, mismatches in table NRIV where the to-year or from number settings conflict with the legacy ECC data profile. Insight, intervals are configuration, status is data. Transports move configuration, but humans must manage the status.
Why this happens, scenario analysis and root cause.
1. The basis team follows a mass transport strategy and assumes that the number range object, which includes the status field, is fully synchronized. 2. Lack of coordination between the technical team and the data migration team regarding the high watermark of existing document IDs. 3. Standard SAP behavior intentionally excludes number range levels from transports to prevent overriding production counters with development counters. 4. Underestimating the impact of custom Z tables that share standard number range objects without having their own dedicated SNR row counters. The failure is a result of treating client-dependent data as client-independent configuration.
Why this is a migration exclusive failure.
1. In standard ECC maintenance, number ranges were already established. Migration creates a new environment where every counter is effectively zeroed. 2. S/4HANA migration involves a big bang insertion of historical data which sets the baseline for all future numbers. 3. The technical requirement to manually reconcile table NRIV post-transport is a unique cutover task for any S/4HANA brownfield conversion. 4. This failure only surfaces when the first post-migration transaction attempts to consume the next available number from a reset counter. Migration creates a numbering void that standard ECC upgrades never encountered.
Financial and customer impact.
1. Immediate revenue loss as the business cannot save orders or invoices, leading to missed shipping targets on day 1. 2. Severe data corruption risk if duplicate numbers are forced into the system via unremediated custom Z interfaces. 3. Customer frustration as the company is unable to provide order numbers for new phone inquiries or web shop orders. 4. Loss of management confidence in the IT department's ability to manage the technical transition safely. Number range errors turn a technically live system into an operationally dead one.
Governance and accountability, RACI model.
Ensuring numbering integrity requires a link between basis and functional leads. 1. Accountable basis lead. The person who owns this and gets fired if it fails. 2. Responsible technical architect performs the manual update of number range levels post-transport. 3. Consulted SD functional lead provides the last document ID list for orders and invoices from the final legacy snapshot. 4. Informed Cutover manager monitors the number range readiness gate in the production runbook. Accountability ensures that technical transports are followed by manual validation.
Ownership, who actually fixes it.
Resolving this requires a technical audit and manual status adjustment. 1. Basis lead identifies every number range object in the cutover transport list using transaction SC03. 2. Technical architect executes transaction SNR row for each object and manually enters the current number from the ECC production snapshot. 3. SD functional lead performs a maximum value check on table VBAK to verify the counter is at least one digit higher than the existing data. 4. Data migration team validates that business partner and customer number ranges are perfectly synchronized to allow the same number principal.
Who gets blamed versus who owns it.
1. Blamed basis team. The business assumes the system setup is incomplete. 2. Blamed SAP users claim the transport tool is not moving all the data. 3. Actual owner basis lead responsible for the failure to manage the client-dependent status of the number range objects. 4. Root cause treating number range status as something that can be transported rather than managed. The failure is not in the transport file, but in the lack of a manual post-import task.
How this is actually fixed, the right way by a role.
1. Basis lead mandates a number range audit task in the cutover runbook immediately after the final transport import. 2. The team implements a SQL script to compare the current status in table NRIV against the max VBELN in the document tables. 3. Technical architect utilizes transaction SNUM to perform a mass-level reset for all SD and FI objects during the downtime. 4. Functional leads execute a first transaction smoke test to verify that the next number generated is sequentially correct.
What not to do, common wrong fixes.
1. Do not allow users to log in until every SD number range status is confirmed as 100% accurate. 2. Do not use SQL update commands on table NRIV to fix the status. You must use the standard transaction SNR row to avoid buffer corruption. 3. Do not ignore interval overlap warnings during configuration. These will become hard errors in production. 4. Do not assume that internal numbering in S/4HANA will automatically find the end of the ECC external range. Shortcuts in number range management will lead to a permanently fragmented and unauditable database.
Follow-up 1. Why does not SAP transport the current status of a number range?
Answer: this is a deliberate safety feature. If SAP transported the status, importing a transport from a development system where only 10 orders exist would overwrite the production system status, where 10 million orders exist, instantly breaking the system. Number range levels are treated as master data and must be maintained client by client.
Follow-up 2. What is the impact of HANA number buffering on this problem?
Answer: HANA buffering takes a block of numbers, for example, 100 into memory for performance. If you fix the status in table NRIV but do not clear the buffer, the system will still try to use the old, incorrect block of numbers stored in memory, resulting in continued duplicate key errors. You must reset the buffer after any manual status change.
Follow-up 3. Curveball. What if the number range level is correct, but users still get duplicate errors because a legacy interface is still pushing orders using a hard-coded number range that overlaps with the new S/4HANA internal range?
Answer: this is an interface collision failure. You must test the external range isolation. The fix is to configure the S/4HANA internal range to start far above any known legacy interface IDs. You must perform an audit of all inbound numbering sources during the realize phase to identify these potential overlaps before they crash your production database on day 1.
Exclusive pro tip.
Add a high watermark report to your ECC production system. Run it 10 minutes before the data freeze. Compare this report to the S/4HANA status in SNRO immediately after conversion. If the numbers are not identical, your system is technically a time bomb waiting for the first user to click save.
Scenario 177. Parallel landscape inconsistencies.
In the deploy phase of an ECC to S/4HANA migration, organizations often fail to synchronize their business as usual landscape with the project landscape. During the long-term realize phase, the legacy ECC production system receives urgent tax updates, legal configuration changes, and custom patches. If these changes are not manually replicated or retrofitted into the S/4HANA project system, the final production cutover will contain obsolete business rules, leading to incorrect pricing and tax calculations on day 1.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium change management and functional integrity risk. 2. Phase deploy technical cutover. 3. Frequency extremely common in projects with durations longer than 6 months. 4. Primary ownership, project manager and cutover lead. The person who owns this and gets fired if it fails. 5. Supporting SD functional lead and ABAP lead. 6. Business ownership, global process owner. 7. Relevant SAP note, not applicable cutover and project management. This is a change management and synchronization failure.
Diagnostic dashboard, symptoms and evidence.
How parallel landscape drift manifests during the go-live phase. 1. Symptom: a critical tax update that was applied to ECC 3 months ago is missing in S/4HANA, resulting in incorrect invoice totals. 2. Red flag: the retrofit log in the project management tool is incomplete or shows 0 activity for the last 30 days of the project. 3. Business impact: significant financial risk and non-compliance as the new system is technically a step backward from the old system's latest patches. 4. Detection: comparing the last change date of critical SD configuration tables, for example T683 or T001, between ECC and S/4HANA reveals massive drift. 5. Technical proof: transport logs in the production system show that a BAU transport from legacy ECC was never imported into the S/4HANA development stream. Insight: a migration project is a race against a moving target. If you do not track the target ECC, you will miss the go-live.
Why this happens, scenario analysis and root cause.
1. Lack of a formal dual maintenance policy, where every transport in ECC must be evaluated for its impact on the S/4HANA project. 2. The project team is focused on transformation and ignores the continuous improvement occurring in the legacy production system. 3. underestimating the impact of SAP support packs or legal notes applied to ECC that change standard application logic. 4. Failure to utilize automated landscape synchronization tools like SAP Solution Manager or CHA-RM to track cross-system changes. The failure is a result of treating the S/4HANA project as a static snapshot rather than a dynamic migration.
Why this is a migration, exclusive failure.
1. In a standard technical upgrade, the downtime is short enough that parallel changes can be frozen. S/4HANA projects take months or years. 2. S/4HANA migration involves a parallel track, N+1, landscape which naturally drifts away from the production source every day. 3. The requirement to translate ECC fixes into S/4HANA syntax, for example, refactoring an ECC user exit fix into a S/4HANA body, is a unique migration task. 4. This failure only surfaces when the organization attempts to replicate its latest legacy business state in the new S/4HANA environment. Migration creates a landscape divergence that standard ECC maintenance never faces.
Financial and customer impact.
1. Material misstatement of revenue or tax if critical legal patches from ECC are not retrofitted into the S/4HANA Go-Live build. 2. Customer service paralysis as reps find that a bug fix they received in ECC 6 months ago is suddenly broken again in S/4HANA. 3. High cost of post-Go-Live remediation as developers must urgently refix issues that were already resolved in the legacy system. 4. Audit risk as the company cannot prove a consistent application of business rules during the transition period. Parallel landscape drift directly erodes the integrity of the corporate digital core.
Governance and accountability, RACI model.
Ensuring landscape synchronization requires a dual maintenance authority. 1. Accountable, project manager and cutover lead, the person who owns this and gets fired if it fails. 2. Responsible, change manager monitors all ECC production transports and coordinates the retrofit into S/4HANA. 3. Consulted, SD functional lead evaluates each legacy fix to determine if it is still required in the new S/4HANA architecture. 4. Informed, IT transformation director monitors the retrofit backlog as a key indicator of cutover readiness. Accountability ensures that business as usual and transformation remain in sync.
Ownership, who actually fixes it.
Resolving this requires a continuous retrofit and audit process. 1. Change Manager utilizes transaction SE01 in the ECC system to identify every transport released to production since the project started. 2. SD Functional Lead performs an impact assessment on each transport to identify critical O2C logic changes. 3. ABAP Development Team manually refactors or reimplements legacy fixes into the S/4HANA development environment. 4. Technical Architect performs a system comparison, transaction SCMP, between ECC and S/4HANA configuration tables 2 weeks before go-live.
Who gets blamed versus who owns it.
1. Blamed, SD functional lead, the business assumes the consultant forgot a setting. 2. Blame, testing team executives assume the regression should have caught the missing rule. 3. Actual owner, project manager and cutover lead responsible for the failure to implement a robust dual maintenance governance model. 4. Root cause, treating the ECC production system as static while the S/4HANA system is being built. The failure is not the missing code, but the missing synchronization process.
How this is actually fixed, the right way by a role.
1. Project manager mandates a mandatory retrofit task for every ECC transport, with no S/4HANA sprint being finished until the retrofit is complete. 2. The team implements an ECC freeze 30 days before go-live, allowing only P1 emergency patches to be applied to the legacy system. 3. Change Manager utilizes SAP CHA-RM to automate the cross-system object lock, which flags a developer if they touch an object that is also being changed in S/4HANA. 4. Functional leads execute state verification tests, ensuring that the latest ECC production values are reflected in the final S/4HANA UAT scripts.
What not to do, common wrong fixes.
1. Do not assume that an ECC fix is irrelevant to S/4HANA without a functional review. Standard logic often survives in the new core. 2. Do not allow retrofitting to be done by junior developers who do not understand the legacy business context. 3. Do not skip the testing of a retrofitted fix, assuming it worked in ECC so it must work in S/4HANA. 4. Do not wait until the final cutover weekend to perform a mass retrofit of 3 months of ECC changes. Shortcuts in dual maintenance result in a day 1 functional regression crisis.
Follow-up 1. What is retrofitting in an S/4HANA migration project?
Answer: retrofitting is the process of manually re-implementing a change that was made in the legacy ECC production system into the new S/4HANA project landscape. Since you cannot simply import an ECC transport into S/4HANA due to technical differences, you must analyze the logic and manually recreate it in the new system.
Follow-up 2. How can transaction SCMP help prevent landscape drift?
Answer: SCMP is the table comparison tool. It allows you to compare the data in a configuration table, like T001W for plants or T005 for countries, between 2 different systems. Running this between ECC production and S/4HANA queue before go live will immediately highlight any configuration drift.
Follow-up 3. Curveball. How do you handle a scenario where an ECC production fix is mandatory for legal compliance today, but the fix utilizes a legacy user exit that has been physically deleted in S/4HANA?
Answer: this is a redesign retrofit. You cannot simply port the code. The fix must be translated into the new S/4HANA enhancement framework. You must identify the corresponding baddie or enhancement spot and implement the logic using S/4HANA compliant syntax. This requires a high-level coordination between the BAU support team and the project transformation team to ensure the legal compliance remains intact across both architectures.
Exclusive pro tip.
Establish a dual maintenance registry on day 1 of the project. Every transport released in the legacy ECC system must be entered into this registry. Use this list as a mandatory audit checklist for your cutover lead to sign off before the final production snapshot is taken.
Scenario 178. Open transaction handling errors.
In the deploy phase of an ECC to S/4HANA migration, the failure to clear in-flight transactions before the system shutdown leads to permanent data corruption. Technical update tasks in transaction SM13, asynchronous background processes, and locked records in transaction SM12 must be 100% finalized before the conversion snapshot. If zombie transactions are carried into the migration, the S/4HANA transformation engine will encounter inconsistent record states, resulting in broken document flows and unbillable sales orders.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium data integrity and cutover stability risk. 2. Phase, deploy technical cutover. 3. Frequency, common in high-volume environments with frequent background updates. 4. Primary ownership, project manager and basis lead, the person who owns this and gets fired if it fails. 5. Supporting SD functional lead and ABAP lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note, not applicable cutover and project management. This is a technical cleanup and process discipline failure.
Diagnostic dashboard, symptoms and evidence.
How open transaction errors manifest during the conversion weekend. 1. Symptom: the S/4HANA conversion log shows errors referencing inconsistent table state for table VBUK or VBUK. 2. Red flag: transaction SM13 in the legacy ECC system shows error or stated update tasks just minutes before the data freeze. 3. Business impact: specific sales orders appear in the new system but cannot be changed or delivered because they are technically incomplete at the database level. 4. Detection: checking transaction SM12 reveals locks held by users who are no longer logged into the system. 5. Technical proof: errors in the SUM tool stating that an exclusive lock could not be obtained for a specific document range. Insight: an open transaction is a dirty record. If you do not sweep the floor before you paint migrate, the finish will be ruined.
Why this happens, scenario analysis and root cause.
1. Lack of a formal system quiescence procedure, where basis and functional leads verify that all update queues are empty. 2. Failure to deactivate inbound IDOC processing, allowing new records to enter the update task buffer after the freeze started. 3. Underestimating the time required for long-running SD background jobs, like mass pricing updates, to finish and commit to the database. 4. Technical zombie sessions where a user's connection was dropped, but the database lock remained active on the document. The failure is a result of treating the shutdown as a power-off event rather than a transactional integrity event.
Why this is a migration exclusive failure.
1. ECC upgrades typically allowed the update queue to be carried forward because the table structures did not change. 2. S/4HANA migration involves a physical transformation of the data. The transformation engine cannot process a record that is currently in an update buffer. 3. The requirement to have a transactional zero state is a mandatory technical gate unique to the S/4HANA brownfield conversion. 4. This failure only surfaces when the physical table conversion, XBRA, fails because it encounters a record in an intermediate state. Migration creates a commit gap that standard ECC maintenance never faced.
Financial and customer impact.
1. Data loss occurs if update tasks are simply deleted to pass the conversion check, resulting in missing orders or payments. 2. Inaccurate financial subledgers if a billing document was created in SD, but the FI posting task was stuck in the queue during migration. 3. Operational delays as warehouse staff find they cannot pick deliveries that are locked by a non-existent legacy session. 4. Audit risk as the company cannot prove that 100% of the in-flight transactions from Friday were successfully processed. Open transaction failures directly compromise the audit trail and the operational readiness of the system.
Governance and accountability, RACI model.
Ensuring transactional integrity requires a strict cleanup authority. 1. Accountable project manager and basis lead, the person who owns this and gets fired if it fails. 2. Responsible cutover manager monitors the SM13 and SM12 queues and executes the kill commands for lingering tasks. 3. Consulted SD functional lead validates that any failed update tasks are either reprocessed or documented for manual entry. 4. Informed IT transformation director monitors the system quiescent status as a mandatory cutover gate. Accountability ensures that the system is technically quiet before the conversion starts.
Ownership, who actually fixes it.
Resolving this requires a triple check of the legacy system state. 1. Basis lead utilizes transaction SM13 to identify all V1 and V2 updates and mandates their completion before the freeze. 2. SD functional lead reviews transaction SM12 and manually deletes any document locks held by users who have logged off. 3. Technical architect utilizes transaction SMQ1 and SMQ2 to ensure all outbound and inbound queues are perfectly empty. 4. The cutover lead performs a final row count audit of the update tables, like VB data, to ensure zero entries remain.
Who gets blamed versus who owns it.
1. Blamed basis team. The business assumes basis did not copy the data correctly. 2. Blamed SAP users claim the conversion tool corrupted the sales orders. 3. Actual owner, project manager, and basis lead responsible for the failure to enforce a quiet system protocol. 4. Root cause, treating the shutdown as a simple server stop while ignoring the asynchronous update layer. The failure is not the data itself, but the in-motion state of the data.
How this is actually fixed, the right way by a role.
1. Project manager mandates a transaction stop 1 hour before the system stop to allow the update queues to drain naturally. 2. The team implements a final update audit, where no conversion task is allowed to start until SM13 is confirmed as 100% empty. 3. Basis lead utilizes transaction SMQ1 and SMQ2 to pause all external data flows before the final snapshot is taken. 4. Functional leads execute state verification on the first 100 orders in S/4HANA to ensure no update terminated flags exist.
What not to do, common wrong fixes.
1. Do not simply delete red update tasks in SM13 to pass a technical gate. You are deleting a customer's business event. 2. Do not allow emergency fixes to be entered into the legacy system once the data freeze has officially started. 3. Do not assume that update tasks will automatically finish once the user logs out. They are background processes that can fail. 4. Do not skip the Q audit for the shadow client during the uptime phase of the conversion. Shortcuts in transaction cleanup will lead to a Swiss cheese database with missing data holes.
Follow-up 1. What is a V2 update, and why is it high risk for SD cutover?
Answer: V1 updates are critical, like saving the order header. V2 updates are non-critical, like updating statistics or LIS tables. In a cutover, V2 updates often run in the background minutes after the user sees a success message. If you shut down the system too early, the V1 is saved but the V2 is lost, leading to out-of-sync reporting and credit tables.
Follow-up 2. How do I handle a stuck update task that will not process?
Answer: you must troubleshoot it functionally. Usually, it is a lock or an account determination error. You must fix the root cause in ECC and reprocess it. If you cannot fix it before the freeze, you must document it, delete it, and manually re-enter the transaction in S/4HANA.
Follow-up 3. Curveball. What if an update task technically succeeds in the legacy logs, but the physical database commit fails during the S/4HANA conversion because the record points to a document category that was deleted in the simplification list?
Answer: this is an architectural drift failure. The S/4HANA transformation engine expects data to be in a consistent legacy state. If an update task modifies a record into an unsupported category, the SUM tool will flag it as a data model violation. You must test your document cleanup scripts against the most recent production data to identify these illegal states before the final cutover weekend begins.
Exclusive pro tip.
Add a Q drainage milestone to your cutover runbook. 1 hour after the data freeze begins, run transaction SM13 and SMQ1. If either is not empty, the project manager is forbidden from giving the green light for the data snapshot.
Scenario 179. Revenue reconciliation not executed.
In the deploy phase of an ECC to S/4HANA migration, failure to execute a formal revenue reconciliation results in immediate financial audit risk. Because S/4HANA deprecates legacy SD revenue recognition in favor of SAP revenue accounting and reporting, or RER, the starting balance of every open contract must be verified. If the organization skips the cent-by-cent reconciliation between the legacy VBREV schedules and the new RER contract subledger during cutover, the first month-end close will be plagued by unexplained variances.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial integrity and compliance risk. 2. Phase deploy technical cutover. 3. Frequency common in industries with subscription billing or long-term projects. 4. Primary ownership, corporate controller and FICO lead. The person who owns this and gets fired if it fails. 5. Supporting SD functional lead and revenue accountant. 6. Business ownership, CFO. 7. Relevant SAP note. SAP note 2225170. Revenue accounting reconciliation tools.
Diagnostic dashboard, symptoms and evidence.
How revenue reconciliation gaps manifest during the cutover window. 1. Symptom: the final cutover report shows 0 variances for record counts, but the dollar value of recognized revenue in S/4HANA is lower than ECC. 2. Red flag: the project runbook contains 0 tasks for running the inception-to-date value check reports post-migration. 3. Business impact: external auditors refuse to sign off on the first financial report post S/4HANA, triggering a corporate compliance crisis. 4. Detection: comparing the deferred revenue GL account balance against the SUM of the S/4HANA revenue contracts reveals a mismatch. 5. Technical proof: errors in transaction FRR_check_consistency, stating that the legacy recognized revenue field is out of sync with the RER contract. Insight: record counts only prove that the paper moved. Value reconciliation proves that the money moved.
Why this happens, scenario analysis and root cause.
1. The project team treats the move to SAP RER as a technical data load rather than a financial transition that requires a balanced trial balance. 2. Failure to involve the revenue accounting team in the final cutover sign-off gate, leaving IT to validate the numbers based on record counts. 3. Rounding logic differences between the legacy SD pricing engine and the new S/4HANA Universal Journal that were not identified during UAT. 4. Incomplete data cleansing of legacy VBREV tables, where orphan revenue schedules were migrated and incorrectly recalculated by the new engine. The failure is a result of prioritizing technical completion over financial truth.
Why this is a migration exclusive failure.
1. Standard ECC upgrades did not move data between different financial subledgers. The audited state of the system remained static. 2. S/4HANA migration involves a point-to-point value transfer from SD tables to the new RR engine, which is a critical financial handshake. 3. The legal requirement to prove continuity of revenue during a system change is a unique compliance hurdle of the S/4HANA migration. 4. This failure only surfaces when the organization attempts to close its first fiscal month end in the new system. Migration creates a chain of evidence requirement that standard ECC maintenance never faced.
Financial and customer impact.
1. Material misstatement of financial results, leading to regulatory fines and a significant loss of investor confidence. 2. Delayed revenue recognition directly impacts the corporate profit and loss statement and can cause the company to miss quarterly earnings targets. 3. High cost of forensic accounting post-go-live to reconstruct the migration history and satisfy external auditor demands. 4. Loss of management confidence, as the CFO cannot explain the variances in net revenue growth versus the previous year. Revenue reconciliation gaps directly jeopardize the financial certification of the enterprise.
Governance and accountability, RACI model.
Establishing financial truth requires a partnership between the controller and the data team. 1. Accountable corporate controller and FICO lead, the person who owns this and gets fired if it fails. 2. Responsible revenue accountant executes the mandatory reconciliation reports and signs off on the final revenue balance. 3. Consulted SD functional lead provides the pricing and tax logic that explains why specific values moved the way they did. 4. Informed internal audit lead validates the reconciliation methodology before the final production cutover. Accountability ensures that the migration is an auditable business event, not just a technical load.
Ownership, who actually fixes it.
Resolving this requires a value-based reconciliation framework. 1. The corporate controller mandates a golden baseline report from ECC, capturing the total recognized revenue of all open documents. 2. The FICO lead utilizes SAP Note 2225170 to implement the financial consistency checks in the S/4HANA migration monitor. 3. The SD functional lead executes a pricing audit, comparing the total condition values in table KONV against the new table PRCD_elements. 4. The revenue accountant implement point-to-point balancing. For every $100 of revenue in ECC, there must be $100 in S/4HANA.
Who gets blamed versus who owns it.
1. Blamed data migration team. The auditors assume the load was inaccurate or incomplete. 2. Blamed SD lead. The business assumes the sales orders were created incorrectly in the new system. 3. Actual owner, corporate controller and FICO lead responsible for the failure to define the reconciliation standard during the cutover simulation. 4. Root cause, treating a financial transformation as a technical lift and shift rather than a subledger balancing item. Audit failures are governance gaps, not technical glitches.
How this is actually fixed, the way by a role.
1. The corporate controller establishes a reconciliation policy that requires a signed-off value baseline 24 hours before go-live. 2. The team implements automatic value validation scripts that compare table VBREV ECC to table FRR_D_contract S/4HANA post-load. 3. FICO lead utilizes report FRR_check_consistency to automate the identification of document-level variances. 4. The project team performs a rec drill during the cutover window, where auditors trace 10 high-value contracts from ECC to S/4HANA.
What not to do, common wrong fixes.
1. Do not allow the go-live to proceed until the revenue variance is 0% or explained and approved by audit. 2. Do not use manual journal entries in S/4HANA to force a balance without documenting the root cause of the mismatch. 3. Do not assume that the migration cockpit will automatically calculate the inception-to-date revenue correctly. 4. Do not skip the reconciliation of partially invoiced orders, as these contain the highest risk for double postings. Shortcuts in revenue reconciliation will lead to a material weakness finding in your first corporate audit.
Follow-up 1. What is the single most important report for revenue reconciliation?
Answer: it is transaction FRR_check_consistency. This report compares the data in the revenue accounting items, ROI, with the actual contracts and the universal journal. It is the only way to technically prove that the revenue chain is unbroken.
Follow-up 2. Why is dollar value reconciliation harder than record count reconciliation?
Answer: record counts only tell you if the shell of the order moved. Value reconciliation proves that all the complex pricing, tax, and currency conversion logic inside the order moved correctly. It captures the financial truth of the record.
Follow-up 3. Curveball. What if the ledger balances perfectly, but the performance obligation levels in S/4HANA do not match the historical revenue schedules in ECC because the new engine applied a material-based allocation that ECC never used?
Answer: this is a strategy mismatch failure. S/4HANA RAR often enforces standalone selling price allocations that ECC SDRevRec ignored. You must test the allocation logic. The fix is to use the legacy override feature in the RAR migration tool to freeze the historical allocation. If you allow the new engine to reallocate historical revenue, your inception-to-date balances will drift, creating a reconciliation error that auditors will reject. You must ensure the migration respects the past while enabling the future.
Exclusive pro tip.
Invite your external auditors to review your revenue reconciliation baseline 4 weeks before the cutover. If they approve the methodology in the sandbox, you avoid a high-stakes go-live veto on the final weekend.
Scenario 180. Workflow activation incomplete.
In the deploy phase of an ECC to S/4HANA migration, the organization often fails to technically activate the new flexible workflow scenarios in the production environment. Unlike legacy workflows that were transport persistent, S/4HANA flexible workflow requires a manual activation of scenarios and the initialization of the task gateway during the cutover window. If these steps are missed, sales orders and billing blocks will remain stuck in the system with no approval tasks generated, paralyzing the O2C cycle on day 1.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium process automation and cash flow impact. 2. Phase, deploy technical cutover. 3. Frequency, common in projects moving to Fiori-based approvals. 4. Primary ownership, SD functional lead, the person who owns this and gets fired if it fails. 5. Supporting, workflow architect and developer. 6. Business ownership, sales operations manager. 7. Relevant SAP note, not applicable workflow activation governance gap. Reference SAP note 2198647 for custom code adaptation context.
Diagnostic dashboard, symptoms and evidence.
How workflow activation gaps manifest during the go-live window. 1. Symptom: high-value sales orders are saved within an approval status, but no work item appears in the Fiori My Inbox app for any manager. 2. Red flag: transaction SWF_flex_activate shows O2C workflow scenarios as deactivated in the production client. 3. Business impact: urgent customer shipments are blocked because the release event cannot be triggered by the business. 4. Detection: checking transaction SWF_process_, admin reveals thousands of wait statuses with 0 agent assignments. 5. Technical proof: technical logs in transaction /IWFND/error_log show service not available for the workflow task gateway. Insight: S/4HANA workflow is a metadata switch. If you do not turn it on in production, the logic does not exist.
Why this happens, scenario analysis and root cause.
1. The project team treats workflow as a configuration transport task and fails to realize that Fiori-based scenarios require manual cutover activation. 2. Failure to synchronize the workflow scenario activation with the team and responsibility data load. 3. The technical background user WF batch was not properly authorized in the new S/4HANA production system. 4. Underestimating the mobile notification setup. Push alerts often require separate technical steps in the SAP Launchpad service. The failure is a result of technical sequencing gaps during the high-pressure conversion weekend.
Why this is a migration exclusive failure.
1. ECC Business Workflow (SWDD) was triggered by stable events that rarely required post-upgrade manual activation. 2. S/4HANA migration introduces the flexible workflow engine as the strategic foundation, which uses a different activation architecture. 3. The transition from legacy GUI-based inboxes to the Fiori My Inbox is a fundamental UI shift unique to S/4HANA. 4. This failure only surfaces when the newly converted S/4HANA system encounters its first approval-relevant document after cutover. Migration turns a technical background task into a mandatory cutover milestone.
Financial and customer impact.
1. Revenue is frozen in the system, as billing blocks cannot be released by managers who are unaware of the pending tasks. 2. Operational paralysis on day 1 leads to missed shipment windows and potential delivery penalties. 3. Customer frustration peaks when urgent orders are delayed by 48 hours due to a missing system notification. 4. Loss of management trust in the new Fiori UI, as approvers are forced back into legacy transactions as a workaround. Workflow activation errors directly block the physical and financial movement of goods.
Governance and accountability, RACI model.
Managing the workflow cutover requires a triple sync between SD workflow and UX teams. 1. Accountable SD functional lead, the person who owns this and gets fired if it fails. 2. Responsible workflow architect and developer executes the technical activation and ensures the agent logic is active. 3. Consulted Fiori and UX lead ensures that the My Inbox app is functional for all manager roles. 4. Informed IT transformation director monitors the workflow error queue during the first 24 hours of operation. Accountability ensures that system readiness includes user notification readiness.
Ownership, who actually fixes it.
Resolving this requires a config data user activation sequence. 1. Workflow architect executes transaction SWF_flex_activate to ensure all O2C scenarios are technically initialized. 2. SD functional lead utilizes the Manage Teams and Responsibilities Fiori app to load the final list of approval agents. 3. Basis lead ensures that the workflow background user WF batch has full authorization for sales and billing processing. 4. The Fiori lead performs a notification test to verify alerts appear on a manager's mobile device.
Who gets blamed versus who owns it.
1. Blamed workflow architect, the business assumes the code for the approval is broken. 2. Blamed training team users claim they were never told how to use the My Inbox app. 3. Actual owner SD functional lead responsible for the failure to define the activation sequence in the cutover plan. 4. Root cause treating workflow as a technical transport rather than a live functional event. Workflow success is 10% code and 90% mapping and activation.
How this is actually fixed, the right way by a role.
1. SD functional lead mandates a workflow readiness audit 4 hours before the system is open to users. 2. The team implements manual fallback agents to ensure orders are routed to a super user if a regional lead is missing. 3. Workflow developer utilizes transaction SWF_process_admin to perform a mass restart for documents that errored during go live. 4. Functional leads execute a workflow smoke test, creating one approval-relevant order per region to verify the inbox task.
What not to do, common wrong fixes.
1. Do not manually release orders via SQL to bypass a workflow block. This violates financial controls. 2. Do not ignore workflow error logs during mock migrations, assuming they are just test data issues. 3. Do not attempt to use legacy ECC agent groups in an S/4HANA scenario. They are technically incompatible. 4. Do not open the system to sales users before the team and responsibility data load is confirmed as complete. Shortcuts in workflow activation will lead to an immediate margin and compliance crisis.
Follow-up 1. What is the mandatory activation sequence for flexible workflow?
Answer: the sequence is strictly 1. Technical activation of the scenario. 2. configuration of steps and conditions in Fiori. 3. Loading of team and responsibility master data. 4. Initialization of the task gateway. Any deviation results in an approval failure.
Follow-up 2. Why do I need to check the WF batch user in production?
Answer: WF batch is the technical user that saves the document after a manager clicks approve. If this user does not have the right S/4HANA authorizations for billing or sales documents, the manager will click approve, but the document status will never change.
Follow-up 3. Curveball. What if a workflow triggers successfully, but the manager's approve button is disabled because the Fiori O data service metadata is out of sync after the final technical transport import?
Answer: this is a metadata cache failure. You must test the UI sync logic. The fix is to clear the Fiori cache using transaction/UI2/invalidate_client_caches. You must include this cache clearing step as a mandatory task in your production cutover runbook to ensure the UI buttons are functional for all approvers.
Exclusive pro tip.
Add a workflow smoke test to your cutover runbook. 1 hour before go live, create one approval-relevant order for every region and verify the task lands in the correct manager's inbox. If it does not, you have a mapping error that must be fixed before the sales team starts their day.
Section 7 wrap-up, cutover risks.
Section 7 has analyzed the big bang of the production go-live. We saw how logical errors in the runbook sequence, mismanaged data freezes, and transport conflicts can lead to an immediate Monday morning crisis. The takeaway for any architect is that cutover is not a technical event. It is a synchronized business performance. If you have not practiced the sequence in a full technical dress rehearsal, you are risking the entire migration effort.
Part 3 Volume 1 wrap-up, the go-live gate.
We have successfully completed Volume 1 of Part 3. We have analyzed the 39 critical incidents that form the go-live gate, navigating the functional testing core, the modular handshakes, the performance limits, and the high-stakes cutover orchestration. Your S/4HANA system is now technically and legally validated for the production move. You have survived the testing crucible and the conversion window.
What we are covering in Volume 2.
System is live and the users are logged in. In Volume 2, we move to the operational frontline, covering the remaining 46 incidents of Part 3. Section 8, Post-Go-Live O2C incidents, pricing behavior drift, condition exclusion changes, and AATP logic shifts. Section 9, Delivery and Logistics incidents, EWM staging inconsistencies, batch determination errors, and export control failures. Section 10, Cross-Module integration, solving the breaks between SD, MM, FICO, and SAP transportation management. To continue your training, please check the link in the description for Part 3 Volume 2, Day 1 Operational Failures.
Complete your solution architect journey.
A true S/4HANA solution architect does not stop at the go-live celebration. You must understand how the system behaves under real-world transactional pressure. If you have mastered the go-live gate in this video, you are ready for the final operational deep dive. Ensure you watch Volume 2 to see why integrations break and how to stabilize the digital core. All links are available in the description below.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The Elite Transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
For more exciting tips, tricks and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers. For 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.